Hello aspirants, welcome to PW Only IAS English. I am here Harpreet Singh with the marathon of the World Physical Geography. Now, many would be thinking, sir, what is this marathon? Please remember, this is a very unique concept from my side. You have to be with me if you want to complete the World Physical Geography properly. Now, you'll be thinking, sir, what are the things that we're going to do in this Physical Geography marathon? Please remember, before I tell you what we're going to do, let us see certain things. Let's see. Okay, let's see, there's a question here where I have put Big Bang Theory. I have put certain features here. It was proposed by George Lemaitre. Universe originates from singularity of indefinite density and temperature. The expansion of universe has stopped, and there are certain points here. Do you realize what I'm doing here? I will be solving live MCQs in front of you. In this whole marathon, we'll be doing close to 50, 55, 60 MCQs also. These MCQs are based on the previous year questions, the practice question, and what can come. So, if you are with me, I'm going to tell you this. Make sure that if you're going to be with me, you will be able to learn the art of solving MCQs today, along with the complete portion of the physical geography. Let's see what we're going to do actually. Now, similarly, every single topic, I will be doing the MCQs. Now, what I'm doing, please remember, I have divided the entire marathon into various parts. With every single part I will complete, I will be giving you 5-6 MCQs. And based on that, you are going to answer them in the comment section, right? Please remember, if you keep on doing this, you will realize yourself that you have practiced so many questions which might be coming in the examination also. Clear? Let us see what is the uniqueness that we are going to have in this particular marathon. Please remember, this is going to be the revision of the physical geography in totality, where I am going to cover the parts of, let us say, all dimensions of physical geography. Second, multiple choice questions where I'm going to solve in front of you. I will be giving you an opportunity. See, there will be answer written also, but don't see the answer. I want you to first of all solve it and then tell me. Then after that, I will be giving you the reasoning why a particular question is right or wrong. See, getting the answer is fine, that is important, but along with it is important how you derive that answer. It is extremely important for all those who are appearing for 2026 examination, but along with it, those who want to appear or those who will be appearing in 27, 28, 29 and henceforth, it is equally important for them because this is that part which is very, very critical for your prelims as well as those who appear in the mains examination later on, right? So, are you all ready for the marathon? Quickly tell me, let me know. Are you all ready? Quickly, right? So, you all know all these faculties are here. Nikhil sir has already taken the polity session. I am taking the geography session. Similarly, other faculties are also going to take your sessions. And make sure if you are attending these sessions well, by the end of the session, you will be in a state where you will be able to solve the questions. You will be able to remember. These notes will also be provided to you so that you can revise them also very well, right? So, this session is not going to be one way. You know, if you have attended my batches also classes, I keep on talking to you all, right? So, please, these 11 hours or 10, 11 hours, if you are with me, I'll be taking break. You will be also taking break in between. If you are with me, I am guaranteeing you, your queries will be resolved. If you have any query while I am explaining you a certain concept, you ask me. I will be very happy to answer you also. So, don't worry about that. Clear? Chaliye. Okay. So, these are the teachers which are going to take. Nikhil sir has already taken Indian polity. He will be taking government schemes also. I will be taking geography, places in use and mapping. Ritesh sir will be taking science and technology. Abhishek sir, ancient and medieval history. Ranchan sir, Indian economy. Pavan sir, art and culture and modern history. Dimple ma'am, environment. And Manjeet sir, CSAT. So, in totality, everything is going to be covered in this UDAAN series in this English channel, right? Indian geography will be coming on the 19th. Today is 16th. Today we are covering the world geography. Then we will be covering the Indian geography on the 19th. We will be also later on covering the mapping also. So, don't need to worry. Everything will be covered. Okay. So, please remember, we are going to have the classes on Monday and Thursday. Today is your world geography. Thursday, this very Thursday, I'll be taking your Indian geography also in totality. And This is the UDAAN series, free of cost. Please remember, all the class notes will be available free of cost on the PW app. You need to enroll on the description that is given below. Free of cost, you will be getting the notes, so don't need to worry about that. Your focus should be to listen to it very, very carefully, right? Okay. Now, this is my Telegram account. You can subscribe to this. I'll be putting the notes here also. Along with this is my Instagram account. You can use this also. Now, okay, let's come here. Quickly, we will be going ahead. You need to understand any query you tell me. Whenever we talk about geography, right? The word geography again comes, sir. What do you mean by geography? Who has given this name? Now, these words, sometimes you'll be saying, sir, why do we need to even do these words? Who's been a father of geography and all? But remember, UPSC is nowadays asking them also. So, Eratosthenes is a father of geography. Now, that he has basically given the term geography, and that is why he is also known as a father of geography. When you see from where the word geography has been derived, you will realize that it is derived from two Greek words. One is geo, other is graphos. When I see geo, it means earth. Graphos means description. So whenever we talk about geography, initially it basically meant, right? Initially it basically meant description of the earth. What? Description of the earth. Now in this series, please remember, your dimensions with respect to NCERT, advanced topics and all these things are covered in totality. If you have covered this series, I am guaranteeing you one thing. In your examination, majority of the questions will be easy for you to solve if you stick to what we are telling you right now or explaining you right now. Do you understand this? I'm again guaranteeing you, if you complete this series properly, majority of the questions that were going to come in your examination, preliminary examination, you will be able to solve very easily. I'm not saying 100%, but majority. If you able to solve majority of them also, then you are in the race to achieve success also. This is my guarantee. When the paper comes, you will match your paper with the notes which I have provided, because I'm live here to explain you. So make the best use of it, right? So geography. So initially when we used to understand what is the meaning of geography, you will realize that it was a description of the earth, right? But do you think that description of the earth is the only definition of earth? No, because see, let us assume I am also staying on the earth, on the surface of the earth, right? So am I excluded from the definition of geography? Then that will be wrong, right? That will be wrong. So please remember, the thing is, earth is also an abode of humans. That means human beings are staying here. So certain people will also say that geography is also defined as a description of earth as an abode of human beings. Now it will depend upon who is basically writing geography or explaining geography from what context. If anybody who's a physical geographer will be talking about the description of the earth in more detail. Any person who will be a human related to human geography, he will be talking about the description of human beings who are residing on the earth. So all these definitions are correct. It is depending just on the fact that you are studying geography from what aspect or angle. If you are studying from human geography, they will be saying, okay, that means that it is a description of earth, of where human beings are staying. If you are a physical geographer, you will basically describing the earth. So there are various definitions. All of them are correct. There is no problem. Now coming to this fact, geography as a subject, if you study, you will be realizing that again, it is an interdisciplinary subject. What do you mean by interdisciplinary subject? It is not a subject that does not derive from other things. In fact, you will realize that from so many subjects, a lot of content has been taken, right? Content has been taken. And after that, you realize geography as a subject is created. Now, please see, when I say a lot of content from various subjects has been taken, we need to understand one fact, that this does not happen at a single moment. Initially, possibly, you will realize that physical geography has been emphasized. Later on, you will realize elements of human geography also come, and people say that you need to focus on humans also. So many branches are here. Now, please remember, let us see branches of geography. If I see the branches of geography, broadly I can divide into one is physical geography, second is human geography, and third are the geographical techniques. Why I am telling you these is because you will get to know why these questions have been asked in your mains also and prelims also. You will understand this. See, I'll be explaining you all these threes. Now understand. If I see physical geography, the ones which I have written in yellow are the branches of geography. Now, when they are branches of geography, you will be asking me, sir, from which subject has this branch basically taken from or related to? Now, if you see geomorphology, it is basically related to the subject of geology. That means it has taken a lot of content from geology. If you see climatology, you will see there's a subject of meteorology. From there, a lot of content has been taken. If you see biogeography, over there, content from biology has been taken. If you see soil geography, pedology, study of soil, from there the content is taken. Oceanography, you have hydrology, from there content has been taken. That is why you study various concepts. We are going to cover every single thing today. I am there for over here 12 hours. You are going to be there. That is more important here. Please understand that. Clear? Geography. Now comes the human geography part. These are the major physical geography branches. So that means they're taken from various subjects. Now, if you see over here, human geography as historical geography, it basically has been derived from history. Political geography, political science, a lot of questions come like, for example, how does the geography determine the relationship between countries? Now, for example, India and Pakistan are there. Now, you know that very well. We can choose our friends, but we cannot change our neighbors. Now, this question also comes in the international relations and it is also related to geography. How is this geography creating a problem? For example, when the issue with respect to rivers which are crossing various countries are there. You know that now that river does not know the political boundaries. It knows the natural boundaries. The river are going to flow through various countries. Yes. Now, those things can create disputes also. Those things can be means of cooperation also. So that is why please understand that comes under political geography, which is also related to political science. Economic geography derived from economics. Now, for example, trade relations. You realize that nowadays you realize trade relations with respect to various countries, tariffs and all those things are going on. Those are also related to your place in which part of the earth you are. Do you have those minerals or not? Do you have the resources or not? Those things also are very closely related to this. Social geography. Now, social geography even covers aspect of, like, for example, caste system, population and all. Those things also, population can also come in population geography, but it is also a part of social geography. Caste system, tribal system and all those things are also a part of sociology. So that thing has also been derived. Cultural geography, again, anthropology, it more emphasizes on the aspect of, again, tribes and various dimensions of human being. Absolutely, absolutely. Very nice, Akshay. Population geography is related to demography. So do you realize all these branches again derive from one or the other subject? Now comes the geographical techniques. Now you will be asking me, sir, just tell me one thing, that why is this being written over here? Please remember, do you realize this very examination, the last mains that happened, there was a question on geographical information system and remote sensing. How many of you know that? How many of you know that? That is why I am telling you, people in paper 1, when they saw the paper, they saw geographical information system and remote sensing. This is not a science paper. This is a paper which is related to history, geography, social science and all. How come this topic has come? The problem is that we sometimes miss these topics. This is very well part of geography. That is why very often you see questions of remote sensing, questions of satellite, question of these topics come. Why do they come? Because these are techniques through which all these things are being studied. Right? Now see, remote sensing has been derived from engineering, right? Clear? Cartography from geodesy, GIS, geographical information system, is from computer science. Quantitative techniques from statistics. Quantitative technique means that those mathematical techniques, formulas and all that you use, statistical techniques have been used. So these are also ways through which you study. For example, if you want to, let us say, modify your land records, or if you want to see what is the extent to which there is distribution of, let us say, forest cover in some region. Earlier it was done manually. Now you can use satellites for them. So that is why please remember, these are also very well the part of geography. Are the branches clear to everybody? Are the branches clear? So we are done with the branches. Clear everybody? Can we move ahead? Chaliye. Now let us understand, before I go ahead, we will be beginning with the concept of geomorphology, and before that certain important concepts. After completing this part, we will be doing some questions, then we will take a break of few minutes, let us say 10-15 minutes, and then we will again begin with another topic. Then again after completion we will have some MCQs. Similarly the concept will go on. Please remember, you necessarily do not have to note down right now because all these notes will be available to you. What is important is any single word that you do not understand, you have to tell me. It is a session where I am with you for 12 hours. You have to be with me. Clear? Let's begin. Now, if you see this, billions and billions of stars and things are present here, right? Billions and billions. Now, if you realize this, that, sir, will you please use Hindi? But this channel is PW only as English. So, we have to speak in English. Okay, that is important here. If you do not understand anything, I can repeat it in Hindi, 1 or 2 lines, but it is majorly English, right? Now, see, what is universe? Whenever we talk about universe, there are a lot of theories, whether the universe has certain boundaries or not, whether there is end or not. But one thing we know that we do not know right now. That is the thing. But if you ask me with respect to definition, a very important thing is that it is a vast cosmic system of mass and energy and has billions of galaxies, right? Someone is asking, sir, what is the best way to remember the names of the places? Please remember, it comes with practice and revision. The more you revise, the more you read, better you will remember, right? Better you will remember. There is no shortcut for that. Clear? Clear? Sir, I am in first grade student. What are you teaching? I am teaching beta geography. If you are first grade, then there is a lot of time for you to study for civil services. Okay? Chaliye. Okay. Okay. Chaliye. Universe is a vast cosmic system of mass and energy. That means you realize there's an infinite, like if you go towards various direction, any space, there is an infinite, there is no end only. You keep on moving. Billions of galaxies are present. Each galaxy has a lot of, let us say, stars, lot of planets and all. So this is an vast cosmic system where mass and energy is present, and you realize there are billions of galaxies in this. So this is a universe. Now let me take one single dust of it. It is, see, this is simply a galaxy here. Like there are billions of galaxies here. Now, if you take one galaxy, let us say this. Now, what is a galaxy? You will see galaxy is a massive system of stars, stellar remains, gases, dust, and all bounded by gravity. Now, within this galaxy, let us assume this is Milky Way galaxy. If I take just single point, it has our solar system. Now, can you realize if you are on this earth, what are you basically in this universe? Nothing. Nothing. Okay? Nothing. So you're teaching like to a child? Yes, exactly, because civil services requires understanding and curiosity of a child and intellect of a mature person. Because when you are studying class 6 NCERT, that is from where civil services examination come, questions come. So you can also say that, sir, that is like a child's play, but you have to study from there. So if you have to study NCERTs, if you have to study standard books, then you have to understand all these things. If people who think that we don't have to study all these things and we straight away want to go advanced level, then it becomes difficult to qualify this examination, even the prelims. One who has the basic knowledge, one who has all these things in the mind, they are the ones who qualify the examination. That is why you would have seen many people, he's studying NCERT, he's studying the basic books, right? And then we say he will not qualify. And he or she is a person who is the one who basically qualify this examination later on. And then we are shocked how come that he or she has qualified. So that is why, please remember, understanding of the concept becomes very critical here. Please understand this. You do not have to do rocket science. You have to understand the basics. Clear? Now comes out of this whole galaxy comes a small point, which is our solar system. Now, what is a solar system? It is our specific neighborhood. Like we are Earth here, it comprises various planets, it comprises various asteroids, comets and all. So this is a solar system here. Now this is, please remember, this question over here becomes very important, because if in the interview are sitting there and they ask you what is the difference between a universe and a galaxy, and possibly you're not able to, at that particular point, able to answer, it is quite possible that your marks will be cut. So please be aware of these basic things, right? Before we go on to theories, then you will realize what the level is. Let's move ahead. This is a basic representation how the solar system is, right? This is the sun. After the sun, you have the Mercury. After Mercury, you have Venus. After Venus, you have Earth, then Mars, and then you have the asteroid belt, right? Asteroid belt. After this, you have the largest planet, that is Jupiter. We will be doing the details also later on for every planet because questions have been asked on these in civil services examination also. Then you have the Saturn, then you have Uranus, and then have you Neptune. Just to let you know what these things are, you should have a brief idea about these. I will be going into all these things, right? Clear? Right? There are many solar systems in the galaxy, absolutely. In this whole galaxy, this one specific point is our solar system. There are billions of solar systems within Milky Way galaxy. And there are billions of galaxies within this universe. So when we say, is there a possibility of other people living or any life being present? Absolutely. Absolutely. So please remember, we cannot deny it because we just are this small dust over here. Billions of solar system here and billions of such galaxies here. So you can remember, we are small dust particles in this whole universe. Okay, let's move ahead. Now question comes a little bit advanced level. You've studied right now about sun, you studied a little bit about the solar system. Can we begin the theories of universe, solar system and the earth, how they were formed? Now comes a little bit advanced concept. I have linked the NCERT, the UDAAN magazine, the basic standard books and combined into one. So the advantage is that I'm not only covering UDAAN, I'm also covering other concepts. So you are completely prepared for the prelims after the completion, right? Now, having done, why I mentioned that? Why I mentioned that? Because you need to know a little bit about the solar system before we begin. Now comes the advanced concepts which are not necessarily present in your NCERTs, but they are present in the UDAAN magazine and standard books. So you should understand each and every theory because from the prelim point of view also they can ask you, in the mains also they can ask you later on. So let's begin. But from where did this all come? We are talking about the galaxies, right? Right? We are talking about the galaxies, we're talking about the solar system, sun and all. So from where have they come? That is a basic question. Let us begin and understand. Okay. Origin of Earth, universe and solar system. Now, there are a lot of theories that have been given. If you see the NCERT, in the chapter, in the first page itself, you will realize theories have been mentioned, but they have not been explained, right? They have not been explained. Important over here is understanding all those theories also. So let me explain you one by one. Please remember, this is a unique opportunity. These all theories are very critical. I'll be explaining you with a diagram. So understand them, put it in your head properly. First is gaseous hypothesis by Immanuel Kant, nebular hypothesis by Laplace, planetesimal hypothesis by Chamberlain and Moulton, tidal hypothesis by James Jeans and Harold Jeffrey, binary star hypothesis by Russell, supernova hypothesis by Hoyle, interstellar dust hypothesis by Otto Schmidt, and Big Bang theory. Right? Let us go into all these one by one, what these theories are. Let us understand them. Okay. Gaseous hypothesis. Please remember, in every single concept that I am mentioning, I am going to have drawn all these diagrams here. All these diagrams have been drawn here. So you just need to understand the concept because these questions have been asked in the civil services also, prelims as well as mains. Clear? Let's see. Gaseous hypothesis by Immanuel Kant in 1755. What did he say? Now please say, he said there are certain assumptions that he had taken into consideration. Based on them, he has given certain statements. Let us see one by one what is he saying. Supernaturally created primordial matter or cloud scattered in the universe. Now supernaturally means that there is no definite reason how it came, but from initial point there was a primordial matter. What do you mean by primordial matter? Very old matter was present, something like this. This primordial matter, he called it as a cloud, primordial cloud or primordial matter. Now see, this cloud he later on called is a nebula, right? Nebula. Remembering year is not important. Please remember, please understand, long ago, many years ago, they just used to ask, arrange them in order, but now those questions do not come. You do not have to remember the year. You need to remember the concept, right? This cloud, this is type of a cloud. You will realize that old matter previously. Now, why he says supernaturally? Because there is no answer to it. He just says, yes, it is present. Assumed it. Now he called this cloud as nebula. This nebula was slowly rotating cloud of gases and matter. Now he said this cloud was slowly rotating. What was the type of matter that was present here? It was cold, it was solid and motionless. Itself it was motionless, but whole cloud was moving. It is somewhat like when I am standing on the surface of the earth, I am still, but my earth is moving, right? Somewhat like that. So particles over here were motionless, but overall cloud was moving. So this whole cloud is slowly moving. Now you realize initially they were motionless. But with slower movement, what happened is, you know that every single entity has a gravitational force depending upon the mass. Particles slowly collided, because once they started moving, after some movement or rotation, some sort of energy, again they said that is how they came, they are not defined it. Some sort of energy was there because of the rotation, and slowly because of the gravitational force, the particles started colliding with each other. He has not answered why these things happen. We do not have to go into all those also, because these are assumptions. Now, particles collided against each other under the gravitational attraction. Every single body has a gravitational attraction depending upon the mass of the body. So what happened? Again, supernaturally, primordial matter or old matter or cloud was present. This cloud was known as a nebula. Now, this nebula basically had gases and matter. That matter was basically cold, solid and motionless. Because of the movement, slowly, because of the gravitational force, these particles collided with each other. Now, what was the reason for the collision? The gravitational force. These are the assumptions that he has taken. Everybody, are the assumptions clear? Based on these assumptions, he has given certain statements. He says that this mutual attraction and collision, because of the attraction of the gravitational force, and collision, random motion started. Random motion, please understand. Random motion start. There is supposedly this cloud. There was certain, because of the gravitational force, there is certain collision. Because of the collision, now the particles are moving in random direction. See here, collision, random direction. This started. So this is the point. Due to attraction and collision, particles generated random motion. Random motion means that they are moving in the random directions, no specific path. This collision and attraction generated heat, leading to increase in temperature. You know that whenever there is collision of certain particles, there will be some heat that will be generated. Now, depending upon the extent to which the heat is generated, that will vary. But over here, some heat will be generated. Now, the particles are hitting each other with a great extent. So many particles are here. So the heat will be generated, right? Heat will be generated. Clear? Now, see, but please understand, if there is this particle, it also has a gravitational force. Now, if the particles are in huge number, billions, automatically there is some form of gravitational force that is present. If you see Earth, let us assume, if you see Earth, you see Moon, you see Sun, right? Every single body has a gravitational force. It depends upon the mass also of the body. Over here, particles are motionless, yes, very small particles, but they are in billions. Billion is also a very small number. So for them, their energy is also small, but they are enough to hit each other. That is why we said that there was attraction based on their mass. See, for a particle to move, my body is difficult, but a particle which is of the similar weight and size, for them to get attracted towards each other is possible. That is the reason. For your answer, who has asked me right now? Akshay. Now see, collision generated heat. Now this led to increase in the temperature of the primordial matter. Now, one statement that he added is, he did not give the answer to it also. He said, random motion of the particles also generated rotatory motion. He said, please understand here, this is one diagram you need to understand. Okay? You need to understand that there was random motion. With random motion, there is generation of heat. With generation of heat, he said, with time, this movement started moving in this manner, rotatory motion. He does not give an answer to this. We cannot add our own views. We need to understand the theory. He said this random motion generated rotatory motion. This was added to it. Clear? So they started moving in rotatory motion. Now next he says is that with time what happened? With time, due to increase in heat, the size of the nebula increased. He said because there is heat generation, the size of the nebula will increase. What does he say? Because of the addition of heat, the size of the nebula will increase. So the size of the nebula will increase. Now this process continues. Later on what happens? Various orbits are formed and there is segregation that happens. See here, these rotatory motion is going on, size has increased. Now you will realize there will be different type of particles are flowing in certain direction. Now they might collide with each other and get together, and this is known as the process of accretion, where certain particles are moving in the orbits, they collide with each other and come together, and that is why this leads to creation of various planets. I'll be repeating it again, please understand. Please remember. Let us understand this. First, there is a nebula. Which basically has gases and particles which are motionless, cold and solid. You know that very well. Because of the gravitational force, there is again collision. Now collision leads to what? Collision leads to over here, because of the gravitation, random motion. Random motion will later on lead to movement in rotatory motion. This rotatory motion has started. Now when the rotatory motion has started, already the heat is being added. So what will happen? This nebula will increase in size. Slowly what happens? This thing over here will form rings with the time, they are saying. They'll form rings. Now in this particular orbit, let us say a lot of dust particles are here. Slowly what happens? They are colliding with this, and accretion, that means collection of certain particles happen. It will lead to creation of one planet, another planet, right? Residual nebula, because of the heat, forms the sun. The heat was there, and heat was present there, and the remaining part which was in between from the sun. There are a lot of problems here. There are a lot of problems with respect to the theory. First, we need to understand the theory because it has been asked in the paper also. Because earlier on, Immanuel Kant, what were the views of Immanuel Kant? They had put certain statements of other thinkers, so you should be aware of it. Clear? Immanuel Kant, everybody. Let us move to next. Nebular hypothesis by Laplace. Everybody clear? Is the gaseous hypothesis by Immanuel Kant clear to everybody? So can we move ahead? So let's move to the next is nebular hypothesis by Laplace, 1796. Now what happens? Yes, deposition because of accretion. Accretion means they're getting together, right? Colliding and coming together. Now comes the concept of nebular hypothesis by Laplace. Now he basically criticized the previous theory, that is by Immanuel Kant. What does he say? Understand. He says large amount of heat cannot be generated due to collision of primordial matter. He said that the amount of heat we are talking about will be, if due to collision, cannot be generated to an extent that Immanuel Kant is talking. He says by this collision, such large amount of heat cannot be generated. Okay, he has criticized. Second thing he says that, how is it that random motion is leading to rotatory motion? How is random motion, or let us say this random motion is leading to rotatory motion? This is not possible. So he basically criticized Immanuel Kant that these statements that you have said, both of them are wrong. And very smartly, what did Laplace do? He said the same thing, but he said in a very different way. Now let us understand this. Please see. What assumptions did he put? See very smartly. He said that he assumed that there was huge and hot nebula in the space. See, please understand. Immanuel Kant said that because of the collision, the heat was generated. Laplace has criticized that, and he says that no, there was already a huge hot gas nebula present from the beginning only. That means from the beginning itself, hot nebula was present, and he does not answer why or how. He has just criticized Immanuel Kant, but he himself says that a hot gaseous nebula was present. See, he has assumed this. Second is, from the beginning, huge and hot nebula was rotating. Do you realize how smartly he has done this? He has criticized Immanuel Kant, but he himself says that there was a nebula which was hot and there was a nebula which was rotating. Though he has criticized Immanuel Kant, but he has just changed the language. Do you understand this? Clear, everybody? Let's move ahead. Nebula was continuously cooling due to the loss of heat and continuously contracting. Now, this is a different thing. He said the nebula was already very hot and it was rotating from the beginning. With the time, he said the nebula started losing heat and it started contracting, right? What does he say? The difference here is, he says that because it was already hot in the beginning, and already rotating also, he said that with the time there was loss of heat and the nebula started contracting. You very well know, because supply of heat tends to expand and contracting becomes because as an outcome of cooling. So he said the nebula started cooling. Now these are the assumptions that he has already made. Everybody clear? Now what does he say? He says that a gradual loss from the outer surface of the nebula due to circular motion. I have drawn the diagram also. Please remember, I have written the content. If you do not want to remember that, I will be showing you through the diagram also. So if you know the diagram, you can write it in your own words. That is why I have done in both ways. I am explaining you through these statements, but I have drawn the diagram. If you remember the diagram also, you can very well write the answer properly. There is no problem. Clear? Okay. So what we have done here, there was a hot and rotating nebula in the beginning. With the time you realize there was contraction because there was cooling of the outer surface, right? Now come here. Gradual loss from the outer surface and the nebula due to circular motion. Now you remember that it is moving in a circular path. Slowly it is losing heat and contracting. Gradual cooling leads to contraction of the size of the nebula, which increases the speed. Now please understand, see, there is again contraction taking place, but energy is there. Now in order to balance this, there is increase in the speed of the nebula. Please see, you know that there is a concept of conservation of energy. Now you know that very well. There is concept of angular momentums also come here. We do not want to go there. We do not have to go there, physics concepts. We simply need to understand in order to balance this, because now it is contracting. Now because of the contraction, we realize there is increase in the relative speed of the motion. With the increase in the speed, you realize a single ring basically comes out. What it is, understand this now. Hot and rotating, this nebula is present. Contraction takes place, right? Contraction takes place. Cooling of the outer surface, and it is rotating at a very fast pace. Now realize out of this, a single ring comes out. This ring later on divides into various parts and formed various planets. Immanuel Kant does not mention a single ring come out. He simply says there is expansion and various rings are formed. On the other hand, Laplace mentions that there is a single ring that is created. Again, that ring of matter, dust and all. And later on, this ring basically segregates to form various planets. Do you notice the difference? See this? Over here, heat generation. Over here, again, rotation taking place. And there are various rings that are present here. And then those planets are formed. Over here, what is happening? Over here, there is already a hot nebula that is present. That nebula basically contracts on cooling. A ring comes out, that is dust and particles. And you will realize this later on. This single ring divides into various parts. And those multiple rings are created, and multiple rings form various planets by accretion. Accretion means colliding with each other and getting together. Clear? Clear, everybody? So, this is Nebular Hypothesis by Laplace. We have already done Immanuel Kant. We have done Laplace also, right? See, sir, are these rings parts of planet? See, see, bachche, remember. This ring is basically composed of particles, dust particles and all, right? Gases are also present, dust particles are also present. Later on, these particles will act as a nuclei for creation of what? Planets, right? These will act as what? Nuclei for the creation of planets. So these are all dust particles over here, and they will slowly collide, come together, and later on form planets. That is what is shown here. Clear, everybody? Any other query? Clear? So somebody thinks I just completed my 12th grade. 12th grade? 12th exams, the board exams are going on, if I am not wrong, right? First, bache, let the, if you are preparing for class 12, if you have in class, just completed class 12th, I think board exams are going on. First of all, focus on the board exams. Later on, when you have completed your board exams, then you can definitely enroll in, there is Praram batch, that is a 3-year course, definitely you can prepare for that. Otherwise, if you do not want to enroll also, there is free, like these platforms, English platform and all those YouTube channels are there you can study from there also. Remember that, right? Yes, Princey, you can, these forms, these are complete basics to advanced, so you can focus on them. Absolutely. Just have a look at this complete lecture. Okay. Next is Planetesimal Hypothesis by Chamberlain and Moulton. These all words are present in your NCERT. If you think that these questions cannot be asked, then please remember, you know that civil services examination and they're asking various types of questions. So you should be very well aware of them. Planetesimal Hypothesis by Chamberlain and Moulton. Can we analyze what this theory basically is and a hypothesis is? See here. Let me show you in simple words the diagram first. Let us see the diagram, you will understand the whole theory or hypothesis. See here. They say there was a proto-sun. What do you mean by proto-sun? Proto-sun means that it is not a sun right now, the initial stage of a sun. There was a proto-sun that was located in one position here. From a very far off distance, another sun came. What came? Another sun came. Another sun is being sold as a companion star. Now that was very huge size. Now that star came. That star basically pulled out lot of material from this proto-sun. What did it do? Pulled out, due to the gravitational force, lot of material from this particular proto-sun. This particle slowly came out and they formed various rings which were later formed as what? Planets. This companion star went away in its own direction from wherever it came. This is again a view. See, again, same thing is present here also. If you understand that diagram, it will be very clear. Let us see here. A proto-sun, that means, proto-sun means not a true sun, a fake sun, that means the initial stage of a sun. That is just not a sun right now. A companion star came at a very fast pace. It basically pulled all the material, most of the material from this particular proto-sun, and this material later on divided itself into various rings and this started moving around the sun, and this became later on the sun. So this is again a such a theory where you will realize that, okay, important is that you need to understand, you do not have to go into R&D. Simply, let us see, hypothesis in which there is proto-sun and companion sun. Proto-sun made up of very small particles with a cold and solid. The companion star came very close to the proto-sun, detaching the particles. You know that very well, right? And you will realize that detached small particles are called planetesimals. Now, please understand, what do you mean by planetesimals? Planetesimals are the nuclei from which the planets are formed. So that is why they are made up of dust particles and nuclei for the planet of formation of the planet. That means out of these particles, the planet will be formed. That is why they are known as planetesimals. Planetesimals. Accretion leads to becoming planets. Accretion means that these particles will collide and become one. Accretion. With passage of time, proto-sun changed into present-day sun. He does not explain how the proto-sun changed into present-day sun. He has just mentioned it. So that is why we do not have to go into R&D. Is this diagram clear? If this diagram clear, remember, in the examination, you need to have the idea of what the theory is. If that is clear, you can answer the question very well. Clear? This is the planetesimal theories. Let us move ahead. Tidal hypothesis by James Jeans and Harold Jeffrey. Again, I will be showing you the diagram rather than going into the content. Let's see this. What is happening here is, see, again over here, we see that there is a proto-sun. What is it? A proto-sun. Proto-sun, again the same concept. Initial or not a true sun, a sun that is present from which out of which sun will be created. So this is a proto-sun. Again an intruding star comes. It is similar concept to a companion star. That means an intruding star comes. The difference over here is that when it is in this position, material is pulled out in a form of a cigar or a filament. Now see, you will be asking why, sir, it is in this format. See here, when it is far off, little bit material will be pulled out. When it is far off, little bit material will be pulled out. When it reaches its position, large amount of material will be pulled out and it goes away. So when it is core, when it is near to, please understand, here, when it is closer to the proto-sun, large amount of material is removed. That is why this part is broader. This part was pulled when it was far away. This part again when it will be far away. So that means a difference in this theory is, hypothesis is that the companion star or the intruding star pulls out material from the proto-sun in the form of a filament. In the form of a filament. This is the only difference. And this filament is like this. That is why you will realize you have Mercury, Venus, Earth, Mars, Jupiter, and in between these a huge planet of Jupiter is present. So they say because this is the reason why this is the arrangement of the present day planets also. See here. Have you seen the solar system? Do you realize it is like, if I put it like this, do you realize it is like a filament? It is appearing like a filament? Yes or no? That is why he said this is the reason. Now please understand these, whatever these hypotheses and the concepts are given, they are not necessarily correct also. These are views that have been presented and there are multiple views. That is why had there been a single view, we would have had a simple one theory that would have been present. We do not have any single theory, multiple theories are present. Every theory has its own criticism. Clear? Okay. Let's come back to this concept here. We have done with the planetesimal hypothesis. Now let's come to the tidal hypothesis. Now let's come to the binary star hypothesis by Russell. This is again a very interesting concept. Let us understand this. See here. See here. What does this concept say? See. He says that this is a primitive or a proto-sun. This is again a companion sun or companion star, you can say, companion star. Just a minute. Companion star. These two are located next to each other. Now what happens is there is an intruding star. This intruding star basically pulls out all the material from this companion star and it basically moves away. And this leads to creation of various planets around this proto-sun, which later forms as the sun which is present today. Again, a very similar concept. You just need to understand the diagram and you will be very well prepared for the theory. Binary star hypothesis by Russell says that there is a proto-sun, there is a companion sun or star. There is another intruding star that basically comes and it basically pulls out material from this particular companion star. And this later forms all these planets and this has already moved away, gone away. Clear? This is known as the binary star hypothesis of Russell. Clear, everybody? Done? Can we move ahead? Okay. Supernova hypothesis of Whale, right? What happens to the companion star? Good question. Companion star has lost its existence because all the material has been pulled out of it and all these planets have been formed out of the material that was present in the companion star. All the material is pulled and various planets are formed. So it has lost its existence only. This intruding star has gone. It had pulled all the material from this and various planets are formed out of the companion star. So it does not exist anymore. Clear? Clear, everybody? Okay, let's move ahead. Supernova hypothesis of Whale. What does he say? Please understand. He says that there was a sun. To be more precise, we can put it as a proto-sun. Along with it was a companion star. Along with it was a companion star. Whenever we say supernova, that means there is explosion of the star. We will study this also when I will be telling you, teaching you about star. He says that under the supernova hypothesis, they say that there was a sun or a proto-sun, you can say, and a companion star. This companion star exploded. Because of the explosion, whatever material was there, because of the gravitational force of this sun, it started moving or rotating around it. Or sorry, revolving around it. Now later on what happens is, because of this movement, slowly planets formed and their various orbits were formed here. Very similar to the initial concept that we had studied. So what happened? Supernova hypothesis says that a sun was there and there was what? A companion star. Companion star, whenever we talk about supernova, there is death, obviously there is explosion. When there is explosion, all the material that was there, it started moving around the sun. Later on what happened? Because of this movement, slowly there was accretion. Accretion led to what? Planet formation. Again, very similar to what we had studied in the initial theories. Everybody clear? Supernova hypothesis basically says that there is explosion of the star. Explosion led to the formation of the planets. Clear, everybody? Just need to know the core and the diagram and you are done with these theories. You do not have to go into R&D also. And this is important for prelims also. Why? Because you never know those questions can be asked here. Because these words have been mentioned in your NCERT. They have not been explained in your NCERT. These are explained in the UDAAN magazine. So I have picked up all these things from UDAAN, NCERT and standard books and whatever was there in all these things. That is why, because NCERT mentions it, but it does not explain it. That is why they can ask you also. That is why UDAAN also comes here to help you out by explanation of these concepts. Clear? Okay. Interstellar dust hypothesis. Very simple, the simplest of all. What it basically says is that around a sun, already a lot of dust particles or dust was present. Simple. This dust, because of the because of the gravitational force also, and initial little rotatory motion was present, and it started further revolving around the initial sun or the proto-sun. This slowly rotation that was present, accretion process happened. Accretion basically led to planets forming, and planet formation laterally led to what we see today. Let us see here. A large glass of cloud and dust was revolving around the sun. With time, the process of accretion took place and planets were formed. It does not explain how this processes took place, what happened. There was no explanation. So we will not go into all those which is not explained. Please remember, you cannot add your own views in the theories or views because it is presented by a thinker. So what happened? A sun was present, dust particles are present, which were again moving around the sun. This later led to accretion. Accretion means again all the particles colliding with each other and forming planets. So planets were formed, and this is what is present here. Clear? Done? Okay. Last theory which comes here is the Big Bang theory. Now please remember one thing. Today's time, Big Bang theory is what we keep on reading very often and say that this is the best theory. It does not mean that it is the correct theory or absolutely correct theory. Right? There can be multiple of things, multiple concepts where we present, right? We right now, please remember, whatever to the best of our knowledge is present according to the studies that have been carried out, we say that, okay, this is a more practical theory than the other theories. Clear? Okay. So let us understand this. Big Bang, when I talk about Big Bang, that means there is certain sort of bang, or let us say a certain type of explosion might have taken place. So let us see this. Big Bang theory is prevailing model to explain the universe birth and is called the expanding universe hypothesis. In the examination, in the prelim, they can ask you expanding universe hypothesis. With respect to that, answer the following points, or which points are correct. So please understand, it is the Big Bang theory only. One more thing they can ask you, they can test you with respect to who formulated it, because that is not again present in your NCERT, but it is present in UDAAN magazine and other standard books. It was formulated by George Lemaitre. What? George Lemaitre. You should be aware of this name. Why? Because they can ask you very well. Now, what it says is that it states that 13.7 billion years ago, all the space was contained in a tiny ball. It says that there was a tiny ball that was infinitely small, right? Tiny ball which had infinite density, infinite temperature and unimaginably small volume. So that means there was a tiny ball where we realize that, right? Where we realize that it had infinite density. That means it was so high that you cannot even calculate it. It had indefinite temperature. Then you had unimaginably small volume. This is known as the primordial atom, right? Primordial atom, before actually things happened. This is known as the primordial atom, or you can say singularity, right? Singularity, nothing else. There, single primordial atom was present. That is why it is called singularity. Please remember, singularity was again asked to you in this year examination. Have you seen that? Right? Right? Cosmic wave background radiation is absolutely correct. There is no doubt about it, right? But can we say it happened 13.7 billion years only? Possibly there was again destruction, again things have been created. I'll give you a certain example also. Please remember, whenever we say how old the earth is, we say it is close to 4.6 billion years old, right? Based on what do we ask? Or what do we analyze it? Based on, let us say, we have found certain, let us say, rock particles, certain fossils, this, that, and we say, okay, these are the reasons behind possibly 4.6 billion years the older Earth is. This is the approximate age. Assume, so for example, that there might be multiple destructions and formation of the Earth, multiple volcanic eruptions, complete destruction of the Earth. Can, after that, you find out the age of the Earth? No. Why? Because again, all the melting of the rocks would have taken place. All the fossils would have been destroyed, everything would have been destroyed. We are talking about 13.7 billion years based on what we know. It might be even older than that also. But what we say is currently, according to our analysis, whatever we know, we are saying that 13.7 billion years old is a Big Bang theory took place, and 4.6 billion years ago, Earth basically formed. Now, these are again assumed fact based on what we know. There might be a lot of mysteries in store which we do not know. That is the case. Clear? Now see. Singularity, that is why please remember, whatever I am teaching you here, remember, whatever I am teaching here, it is more than sufficient for your preliminary examination, and also it will be very helpful for your mains and all other examinations, PCS, NDS, EDS, whatever you are doing. That is why whatever I had mentioned here, singularity and all this concept, majorly what people face whenever they are writing the mains examination, they do not know what is singularity. So every single thing is going to be covered. So that is why every single word that I have mentioned here, your notes will be available to you. Please make sure that you read it again and again after understanding what I'm explaining you. So your task today is to understand every single thing here. Clear? Okay. Now this was known as a singularity because a primordial single atom is present, which is again infinitely small, infinite density is present, and infinite temperature. Now what happens is the atom exploded violently, leading to expansion of the universe. They said that this particular atom exploded. Now this explosion led to creation of the universe. Earlier they said nothing was present, only this tiny atom was present. Now what are they saying is, see, this tiny atom is present, it exploded, and slowly the universe is expanding. And we are here at 13.7 billion years ago, right here. Clear? PPT, beta lecture pura dekho, and you will get the PPT also, this PDF also, right? ये बहुत जरूरी है आपके लिए, सब लोगों के लिए, and everybody here, that do not simply go for this PDF and listen to the lecture. Later on you can download the PDF. Clear? As the universe grew, some energy was converted to matter. Do you know E is equal to mc square? There is a relationship between energy and mass. That means energy can be converted to mass. When the explosion took place, very high amount of energy was released. So there's a possibility that lot of conversion of energy to mass also took place, right? Mass also took place. That is why when people ask now, from when a single atom was present, from where has these dust particles or these different things have come up? The reason is Einstein had told that there is a relationship between energy and mass, and energy can be converted to mass. That is why this mystery of Big Bang theory was also solved here. Okay? With the first time, 3 minutes, the Big Bang theory, first atom began to form. So that means after the explosion took place, atoms started forming, and slowly you realize various types of things and matter started creation. So within 3 lakh years of Big Bang, the temperature dropped to 4500 Kelvin and gave rise to atomic matter. So as the temperature cooled, again there were a lot of other matters are also created. Particles started colliding, accretion also happened, and again slowly you realize a lot of other let us say planets and all later on formed here. Clear everybody? Clear everybody? कोई problem इसमें? Anything? Sir, आप जयपुर सेंटर आओगे क्या? Definitely we'll come. No problem. We'll definitely come. Clear? Done with Big Bang? Okay. So we have completed with the Big Bang. Now please tell me, is it clear? Clear to everybody how the universe, solar system, sun and all those things have been formed? Clear to everybody? Now this diagram in front of you, this is again everything is handmade. I have not taken a photograph from anywhere. I have just made it by hand on my iPad. Do you realize there were two questions that were asked? There were two questions that were asked from this particular slide that I have mentioned here. Why? I tell you, every single year they ask you what is a white dwarf, what is a black dwarf, what is a red giant, what is a supernova. The problem is that we are never able to understand the differences between or among them. That is why we are never able to answer that also, right? Now please understand, whenever we are doing the life cycle of a star, this becomes critical here. Why? Once you have done this, you will realize that you will be able to solve one or two questions that are related to this particular topic. So my request to you here is that understand single word over here. Once you've understood that, you will be able to answer all the questions which come from the star part. There were two questions in this preliminary examination which were related to this topic. Now, see here, I am just showing you the diagram here. In the next slide, I have explained what these things are. So you don't need to worry what these things are. You just need to understand first of all. See here. Initially, what they say is, right? Somebody is asking for which exam this class is. This class is for civil services examination, and obviously it is equally relevant for your PCS exams and other examinations, because geography is present in every examination that you come across, any competitive examination, right? Initially, there is a nebula or a gas cloud. We'll be understanding, don't worry. Initially, there is a nebula or a gas cloud. After that, a stage comes a protostar. After a protostar comes T Taurus phase. I'll be explaining you all these, just wait. Nebula or a gas cloud, protostar. After protostar, right? Bache, please focus in the class right now, right? Please focus in the class. Let us complete this. All the queries will be resolved once we have done this, right? There'll be a lot of other things I'll be mentioning. Just focus on the class, otherwise you'll be missing on this, right? Okay. Okay, chali. Nebula, the gas cloud. Later on, protostar is formed. From the protostar, T Taurus phase comes. Now you will say, sir, what are these things? What are these things? Understand this. Please remember, whenever we are studying, these are the phases through which a star basically undergoes. Initially, it is a nebula. It will later form a protostar, then a T Taurus phase. This is the birth stage. After that, there is another stage, then the old stage and the death stage. Please understand this. Everybody listen to me and focus on the board. This is the birth stage, the gas on the nebula, the gas stage, then the protostar and T Taurus phase. Let us understand what is the birth stage. See, what is a nebula? Nebula is a giant interstellar, again, dust particles of cloud which is basically composed of dust particles. So this is what nebula is, a gas cloud composed of what? Dust particles. Clear? Dust particles. Protostar, next stage is protostar. Clear? Heat energy produced from the nebula which results in warm up of the molecules. Now, how is the heat energy basically created? Can anybody tell me how is the heat energy created in the protostar from the nebula? We've already done this. I said the initial stage is what? The nebula. I say after the nebula, a protostar is created. And I say the protostar is created because the heat energy that is present there. From where has the heat energy come up? Can anybody tell me? Can we say that the nebula had a lot of dust particles and they were colliding with each other, and this collision led to the creation of what? heat energy under the gravitational impact. Remember, this specific question has been asked in certain PCS examinations also. Long ago, this was asked in civil services examination also. They said, with respect to the creation of a protostar from a nebula, how does a protostar gain energy? Right? How does a protostar gain energy? In that case, it was first point already present. Second, because of the collision. So similarly, and similar points are given. So it is because of the collision under the impact of the gravity that led to the creation of the heat energy. This is again very, very, very important. Clear? This is very, very important here. Now see here. Next is the T Tauri phase. This phase begins when the material stops falling into the protostar and further releases tremendous energy. What happens is, as the protostar over here, heat energy is created, a lot of particles are attracted towards it. See here, what is going? Collision is taking place here. This collision is creating energy, heat energy. Now, heat energy will create certain regions over here, might be little bit higher in temperature because of the energy that is created. There will be accretion activities also taking place. There will be a lot of material that will be attracted towards it also. In the T Tauri phase, you realize that this process slowly stops. That means this phase begins when the material stops falling into the protostar. Because you know that this is a protostar, material is still surrounding it. It will stop falling. And over here what happens? Further release of tremendous energy. So please remember that energy is still present over there. What? In the surroundings. This region. So tremendous amount of energy is present here, but the material is not falling into the protostar anymore. When the material stops falling into the protostar, this phase is known as T Tauri phase now. It is a intermediary phase between the protostar and the next phase which we will be studying right now. Nebula is a gas cloud. Protostar is where the heat energy because of the collision has taken place and material are aggregating. Next is T Tauri phase, that their phase begins when the material stop falling into the protostar, and that phase is known as the T Tauri phase. Next comes the two stages or two cases here. Now from the T Tauri phase, because T Tauri phase is an intermediate phase. After the intermediate phase, you will realize two possibilities happen. If the star that is formed is of a very large size or massive size, or low or medium mass. So two stars, please understand. No, it is not equilibrium stage. It is an intermediary state. It is not a stable stage. Right? From T Tauri phase, you will realize that two possibilities can happen. If the material that was present was in a huge quantity, large material was present, large amount of energy is present, or in case lesser amount of material is present. So in case if the material that was present, energy that was present was very high, then this stage will come. If material that was present is less, then the low or medium stars will be formed. Our star is coming in the category of this medium star. It is not a very large size star. Please remember that very well. There are billions of stars present in the universe which are huge, which are massive, but this our star, our sun, comes under the category of this. If you want to have an example of the very massive star, then it is Sirius star. The Sirius star is a very massive star. So in the birth stage from nebula from protostar to T Taurus phase, here every sun goes to this phase. After this depends upon what the mass is. If the mass is very huge, then one category, this category, or if the mass is less, then another category. Because why we have divided into two categories? The reason is that there will be different outputs later on. Till here it is clear. Quickly tell me. Till here it is clear? First, nebula, protostar, T Tauri phase. From T Tauri phase, you have a possibility that the star If the material available is very large quantity, the energy or the temperature is very high, then one type of star will form. If they are of a lesser size, if they are a lesser mass and lesser energy is provided available, then this category will form. Now we have divided the star into two categorization based on the mass and the size also. So we have the low and medium mass stars, which are like our sun, and the high mass and massive star like the Sirius. Now please understand this. From this stage to the next stage, what happens is, in the old phase, a low and medium star will form a red giant, whereas a high and massive star will form a red supergiant. Now let us understand what these things are. Because why red giant? Because it is larger size. Why supergiant? Because it was much more larger in size. So let us see here, come here. Now see here, main sequence over here, you realize that in this phase, core temperature reaches the fusion. This is again a basic understanding. Obviously, the fusion reaction also start, but major thing is the old stage where we are studying here. Now see, red giant over here, please understand, formed due to the later stages of the evolution, which runs out of the hydrogen fuel at its center. Now please understand, this is the phase where the over here, the fusion reactions have taken place. So the main sequence phase is marked by fusion reaction. Remember this very well. Write it here. Right now, our sun is in which state? Can anybody tell me? Right now, our sun is in which stage? It is in the birth stage or the main sequence stage? Anybody, quickly tell me. Our sun of our solar system is present in which stage? They can ask you first the birth stage, second the main sequence stage, the third the old stage, or let us say the death stage. Can anybody tell me? Right now, the sun is in which stage? Our sun. Among all these four stages which I have mentioned here, which is the stage where our sun is present? Right? Old stage. No. Don't you realize right now the fusion reaction are taking place? Has a sun, our sun right now is in the main sequence stage. That is why all those fusion reactions are taking place, right? So right now our sun is in this stage. Later on, after many billions of years, it will enter the old stage. So this main sequence stage is where the fusion reaction processes take place. What are these? See, in this phase, main sequence stage, the core temperature reaches a point where fusion will commence, that is hydrogen being converted into helium. That is what is the source of energy also, right? Now, when will these form, these red giants or red supergiants? Please understand. Red giant will form or supergiant will form during the later stage of the evolution, when it runs out of hydrogen fuel at its center, right? When the sun runs out of the hydrogen fuel, not completely, but majorly, there will be still some hydrogen left, but majorly runs out, then it will be a red giant, right? Red supergiant, an enormous red giant is called a red supergiant. That means both of them are same. Red giant and red supergiant are same. The only thing is the red giant is relatively smaller and red supergiant is massively large. Why? Because the sun that was present was massively large. So the outcome is a red supergiant. Clear everybody? Clear everybody? The old stage basically comes where it runs out of a fuel, not completely but majorly. Please understand, not completely but majorly. That means you realize that hydrogen now is not present in large quantities anymore. Okay? Not present in large quantities anymore. And that is why you will realize that it reaches the old stage. So now you can answer that which stage is our sun present? It is present in the main sequence stage. When it runs out of the hydrogen fuel to a great extent, that means fuel is not present in a large quantity now, then it will enter the red giant phase. And right now our sun is in the main sequence stage. Clear? Next, if you see here, red giant over here can form later on planetary nebula, white dwarf and black dwarf. So what can we say? Red giant can later on lead to the formation of a white dwarf and black dwarf. We will understand what are they. While red supergiant leads to formation of supernova, and this supernova can later on form neutron star or the black hole. Neutron star or black hole. Now, if a question in the examination comes that black hole is an outcome of a red giant only, then that statement is wrong because it is an outcome of the red supergiant. Supernova can lead to the formation of neutron star. That statement is correct. Supernova can later form black hole. That statement is correct. Black dwarf forms white dwarf. That statement is wrong. Every single thing that I am mentioning here can be put in the form of a statement. Do you understand this? That is why please remember, every single statement that I am mentioning here can be asked. You know that this has been asked in civil services. The only thing that you wanted to or should have known is this particular slide. Every single year when 1 or 2 questions are asked, many or most of the people are not able to answer it because they do not know the sequence. They can put black dwarf before white dwarf, again wrong. They can put all these things in a wrong order, then they'll ask you. So please, this is one slide which I'm explaining you that will basically you can gain at least 2 to 4 marks in your examination. Clear? So let us complete this and I'll again come here, right? Okay. Last phase, supernova, neutron star and black hole. Now see here, white dwarf and black dwarf. These are the things that happen in the last phase. Last phase, देखिए. Supernova means an explosive death of the star. Do you remember when we were doing supernova hypothesis, I told you that there is explosion. That explosion basically leads to the death of the star. That is a supernova. What is a neutron star? What is a supernova? What is a neutron star and black hole? Let us see. Neutron star, let us understand this, is a highly dense and compact celestial object, forms after the core of the massive star undergoes a supernova explosion. When a supernova undergoes an explosion, there is a possibility that a highly dense, compact celestial object might be formed. If it is formed, then it is known as a neutron star. On the other hand, also formed from the collapse of the massive star having no physical surface. Now, there's a possibility the explosion leads to creation of nothing. That means there is something which has no physical surface, but it has very high gravity to an extent that even it can absorb light. So that is basically known as a black hole. Please understand it again. When an explosion takes place, there is a possibility that a very high, dense and a compact celestial body will be created, can be created. If it is created, then it is a neutron star. But there is a possibility where when the explosion of supernova takes place, then because of that explosion, you will realize that what is an outcome is something which has very high density, but it has no physical surface. And when the light is also going, light cannot escape from the black hole because of such a gravitational force. Then that is known as a black hole, which is still being studied. This is the thing. Supernova, explosive death. If explosion leads to a celestial object which is very compact and very dense, then it is a neutron star. If the explosion creates phenomena where there is no physical surface but extraordinarily high gravitational force, then it is known as a black hole. Clear, everybody? Next is white dwarf and black dwarf. White dwarf and black dwarf. Do you all remember? I had already told you about the hydrogen fuel and all those things. Now please see over here. White dwarf are extremely dense remnants of low to intermediate mass stars that are exhausted nuclear fuel and expelled out its outer surface. Sometimes what happens is these are the remnants of the medium or smaller size stars where they have run out of fuel completely. Remember, red giants were which had basically experienced a lot of shortage of the fuel, but still I told you some amount of hydrogen was present. White dwarf is a stage when complete exhaustion of the fuel is there. That means no fuel is present now. In that particular case, you can realize that what can happen? What can happen? The outer layer, this outer layer is expelled out. Expelled out. So this is what is remaining. This outer layer is expelled out. The residual heat little bit that was remaining because of the processes that had taken place, it gives an appearance of a white color, or let us say shiny surface. When that residual heat is also finished, then you can see nothing, then it is known as a black dwarf. So what is here? A red giant was one which had, let us say, to a great extent exhausted its fuel, but still some fuel was present. White dwarf is created when you will realize that complete exhaustion of the fuel is there, and very often the outer surface is expelled out, and the remaining heat that was present because of the heat generated because of the process of neutral fusion previously, that leads to it appearing in the form of a shiny surface. When that remnant heat is also exhausted, then it is known as a black dwarf. That is the last stage of a white dwarf. So can I say black dwarf comes after white dwarf? Can I say, let us see here, let us answer this. Okay. Red giant, black dwarf, white dwarf. Arrange them in the phenomena or the process in which it takes place. Okay, let's see. Option A, 1, 2, 3, 2, 3, 1, 3, 2, 1, 1, 3, 2. Answer this. A, B, C, D. Answer this. A, B, C, D. According to this, what should be the sequence? Red giant, black dwarf, white dwarf. Now, please understand, if you had not understood these concepts, they would be alien subjects for you. These would be alien subjects for you. Do you understand them? Now, because you have studied, these topics are so easy for you. Somebody said A, right? Somebody said A. I had told you, everybody, please remember, I will be doing a lot of practice with you. If you are doing this, you will be able to solve all the questions that come from this section, right? Clear? Clear? Is it clear to everybody? So what is the answer? See, the answer lies in your diagram that I had told you, or what I had drawn in the beginning only. See here. You have, let us understand the sequence once more. You have a nebula, gas cloud, that forms a protostar because of the heat energy. Then you have the T Tauri phase. Out of the T Tauri phase, there are two possibilities. One possibility is if the mass and the energy is very large, then you will have this stage, massive or high mass star, or in case it is medium or less, then this category, right? Our sun is this. These two phenomena then move ahead depending upon whether they are massive or less massive. The medium or the low mass will have red giants. Red giants later on forms the white dwarf and the black dwarf. The high massive star form red supergiant because they are much larger in size. They later on form supernova. Supernova can form neutron star or the black hole. Clear? Clear? So the answer over here is 1, 3 and 2. First you have 1, then you have the white dwarf, then you have the black dwarf. The answer is D. Is it easy? These are the types of questions that were asked. White dwarf, black dwarf, this star, that star. And please remember one more thing. Many people will say, sir, there are a lot of other statements that come and words might be used which are not able to understand. Beta, remember, if you have the basic things or basic concepts clear with you, you can solve the questions even then. And you will realize after this because you've understood the concepts. Clear? Okay. Now, we have done star right now. So let us understand a little bit about our sun. Questions are asked on our sun also. Now people will say, "Arey sir, why are we doing the basics?" Beta, these are the basics which are asked. Please remember one statement which I always repeat in my batches, YouTube sessions, offline sessions, wherever I go. You do not qualify this examination because you are able to solve few difficult questions. You qualify this examinations because you do not get the easy questions wrong. Understood? The easy questions come from your NCRTs, which the UDAAN lecture I am already covering here, right? Along with certain advanced concept which I am also covering here. So if you're doing this, I'm telling you, most of the questions can be solved in your examination through these lectures. I will be taking world geography, then Indian geography, then places in news after that world maps and Indian maps also. So till the time I cover all these 5 marathons, you will be in a state that you can, most probably if you have revised it, you will not be making mistakes. This is a guarantee from my side. You'll see the paper yourself, right? Okay. Bache, the thing that happens is, now please see here, you need to have information about sun. Like for example, your NCRTs do not mention in detail about the sun, but the UDAAN magazine mentions, the standard books mention. So I put them over here. Certain features, please understand. The radius is about 7 lakh kilometer. 1.3 million Earths can fit into it. You realize in the sun, our sun is so huge that 1.3 million Earths can fit inside it. It is so huge that 1 million Earths can fit inside. It is so huge. One more thing, they can ask you, our sun is a large size star. Is that statement correct? No. No. It is a medium size star. This is again very important. This has been asked in various examinations, UPSC examinations only. It is not a large size or massive star. It is a medium size star. That is why every single word that I have mentioned here, UPSC will create a statement out of it. That is why you should be, please do it very, very well, right? Okay. Now comes, it comes under the medium star to be more precise, right? Okay. Now comes temperature. If you see the temperature, you will realize that the surface temperature is about 6000 degree Celsius, whereas core is 15 million degree Celsius temperature. Composition, 98% of the sun is again hydrogen and helium. These are because of the nuclear fusion processes also taking place. Formation is again assumed to be close to 4.5 billion years ago, right? Next, rotation, counterclockwise viewed from the Earth's surface. If you supposingly, if you are from the Earth's angle, if you see, like viewed from above the Earth's North Pole, if you are standing on the North Pole from that side, if you are viewing the sun, it is basically, you will be seeing it is rotating counterclockwise. A question will come, does the Earth rotate? You will say no, it does rotate. That also counterclockwise. So please remember in this, in your mind very carefully, that the sun is also when you view it from the Earth, counterclockwise. Clear? Processes, nuclear fusion reaction is taking place. That means again hydrogen reacting to give helium and the energy is released. This is what nuclear fusion. You already study in general science, hydrogen reacting, again giving helium and energy is released. This energy being released is the amount of heat that you basically receive from the sun. Structure, now comes the structure. I will be explaining the structure. Till here all the features are correct to you, clear to you? What is the size? What is the temperature approximate? Composition, formation, rotation, nuclear fusion. These are the things that are clear. Now the questions which are asked in your civil services multiple times in your even CDS, PCS paper and all, that is the structural aspect. Structural aspect. Please remember, I am going to explain you these very carefully, understand them. Okay. There are certain layers which you need to understand, right? Clear? Now see here. Beta, you will be studying the planets, then I'll be telling you how the size is varied. We will understand that. Please understand. Okay, now see. If you go inside the sun, you have a core. Inside the sun is a core. Like you have the core in the earth, there is a core of the sun. This core, please understand, now we are not talking about the earth, we're talking about the sun. The questions are asked repeatedly here, so you should be aware of it. Core, it is the powerhouse. The temperature here is about 15 million degrees Celsius. Here, the hydrogen is being converted to helium. What is going on here? Hydrogen is being converted to helium. Clear? Clear? Then, outside the core is your radiative zone. This. This region is a radiative zone. Please remember, please understand, questions have been repeatedly asked. So you should be very well aware of these. Where does the, again question will come, hydrogen to helium reaction takes place in which part? Core, radiative zone, convective zone. When you haven't read it, you will write, okay, radiation hi hoga, radiation let us mark. That is why need to know over here. These are certain things which you do R&D and in the examination you are sitting and you are assuming, then you will get it wrong. I'm telling you. So the answer is core, right? So whatever I'm orally asking you these questions, you will it will appear like, sir, this is like spoon feeding or something like that. But remember that these are the questions which are asked in the exam. So radiative zone, first of all, next part is outside the core, you have the radiation zone. Energy from the core moves outwards through this layer. Now, from the core, in order to move out, it will move through this layer. It is in the form of radiation, photons or light. It is in the form of radiation, that is why it is known as a radiation zone. Outside the radiation zone is a convective zone. Outer layer of the interior. Heat energy moves via convectional currents. Hot plasma rises to the surface, cools and sinks. Please remember, this is again a very important layer. Heat energy moves in the form of convective currents. Over here, heat moves in the form of radiation. Radiation, right? Hot plasma over here rises to the surface, cools and again sinks. Somewhat that happens in the mantle of our earth, which we will be seeing. Similarly, concepts happen over here also. Hot plasma, hot gases basically rise. After rising, they cool, then again sink. It is somewhat like hot gases will again rise, come over it, then again sink. So what is the phenomena which is transferring heat in this particular zone? Convective currents. What? Convective currents. Is it clear? Is it clear? Everybody, are these three layers clear to you? Everybody. Core, radiative zone or radiation zone, and the convective zone. 3 points, 3 aspects clear? Why I mentioned it over here, there is quite a possibility what UPSC will do is, they will ask, the process of transfer of heat in the radiation zone is convective currents. No, it is radiation. Convective zone is convective currents. That is, the hot gases basically rise. Once they rise, they then again might cool relatively. Cooling does not mean that they are freezing. Please understand. Any body which is at, let us say, assumingly 10 degrees Celsius, and when it rises, it reaches, let us say, 7 degrees Celsius. There is loss of heat when you are comparing these two temperatures. Even slight fall in temperature can be considered cooling here relatively, because cooling is a relative concept. Right? Cooling is a relative concept. Heating is also a relative concept. That should be very clear to you. Now comes the layers which are other very important layers, which are outside. Now see here. Outside the convective layer, this is a thin layer. This is known as the photosphere. Photosphere, right? This again has been asked in civil services. This layer emits the light which we see on Earth. They can ask you, the light that we see on Earth is emitted from which layer? Most of you will say, "Arey, core is a region where the fusion reaction is taking place. From there only light will be coming out." No, it is the photosphere. So this layer emits the light which we see on the Earth. The reality, the interesting thing is, it is not a solid surface. It is not a solid surface, but a layer of gases about 100 kilometers thick. And the sunspot happens here. Where does the sunspot happen? Sunspot is not happening on a solid surface. It is happening on the photosphere, which is a layer of gases. Did you know this? No? Did you realize this? If I ask you for a sunspot, you will say some solid black thing is coming here. No. Those sunspots, first of all, are the cooler parts, right? Cooler parts. Please remember, this layer is a gaseous layer on the sun. It is not a solid surface. Light is being emitted from this layer. And the next part is that sunspots, the black patches that you see on the sun are the sunspots which happen in this layer. Because certain regions might be a little cooler, so that is why sunspots happen there. And sunspot happen in the photosphere. This is again, see, okay, when you see a sun, you will realize that there is no uniform color. There will be certain regions which are a little darker in color. Those darker colors we call as sunspots. Do you realize when you see your skin, the certain patches here, dark patches if present, you will say, wow, what are the spots on your skin? You will say that? Those are spots on the skin. Similarly, you will have certain spots on the sun also. Those spots are blackish color, a little darker color, because those are the cooler patches, cooler regions on the surface, cooler regions on this photosphere. That is why they appear a little blacker. So first of all, darker and cooler patches on the photosphere first. Secondly, it is not happening on a solid surface. They can ask you, first of all, let me frame a question, how your mind should work. With respect to the sunspot, answer the following, right? Okay. Let us see this. See, this is how questions are created. Understand these. Let me see how you answer. Answer the following. Which all are correct, right? Which all are correct, right? Let's see. A, 1, 2, 3, B 2 and 3, C 2 only, D 1 and 3. What is the answer? What is the answer? It is very, very important. Somebody is asking Vibgyor and all. Beta, I'll be explaining. It is GXU Wimmer. That is the short form which we will be doing when we will be doing the further chapters. Don't worry. Okay. There is a trick question that I had added here and many of you got confused. Again, read the statement carefully. Again, read the statement carefully what the question is asking. Read it once more and then answer. Let us answer this. Check. See again. Sunspot happen on the solid surface layer. Solid surface layer? No. This is wrong. The moment I have marked this wrong, I know wherever 1 is present, this is how you do questions. Now I know, see, it is very important question like this. You should know that any statement that is wrong, immediately cut the options here. So that means this option cannot be there and this option cannot be there. Agreed? Agreed? Based on this, I know that this statement is correct. Now tell me one thing. Light comes from photosphere, I know. But tell me, I said the source of energy of the light is the core. From where is the energy coming? The focus is not light. The focus is energy here. Did you realize this? Tell me, if the core is not functioning, can the photosphere emit light? Do you realize how I tricked you? Over here, I did not write light. I wrote energy. From where is the energy coming, which is basically leading to the light being there? If supposingly there is a tube light is present here, you can see my face. But if I do not provide the electricity, will the tube light work? Will the tube light work? The focus here is word energy. I said source of energy, then I mentioned light. So that means if the statement, from where is the nuclear fusion reaction taking place? Tell me. It is the powerhouse where hydrogen to helium reaction is taking place. What is it? Core. What is it? Core. The core is giving the energy. Later on, those things are forming. So what is the answer here? What is the answer here? Is this statement correct? Yes, it is correct. Beta, remember one thing. You need to remember or understand every single word that is being mentioned here. The focus is on source of energy. Light is a secondary keyword here. That is why whenever you are reading, that is why I am going to solve multiple questions here. You will learn the art of solving multiple choice questions. That is why, see, simply doing the content is fine, but these are how, this is the way how questions are created. Do you realize I created a question in front of you? I do not have any material here. That is why do these things when you are reading the content, understand the content. You have any queries, you ask me. Clear? Clear to everybody? Okay. Did you realize these are small things that questions are being asked and we are missing on these things? That is why I said NCERT, yes, UDAAN magazine, all those components I've covered here along with standard books. Now, let us see another thing. Coming back to the planets, we have studied the sun. We have studied how the origination took place. We have studied a little bit about other dimensions. These are that sun. Now, sun you have studied. Sun is clear. There are 4 planets here and there are other 4 planets here, right? And there is an asteroid belt here. There are certain concepts which are again repeatedly asked in the examination, right? Repeatedly asked in the examination. And you should know these facts. Now, from where has it come? The UDAAN magazines mention it. The NCRTs of classes like 6th, 7th, 8th, they also mention it. So that is why this has been incorporated in your in this particular lecture, right? Okay, right? What happened? Anything you want to ask? Okay. The planets which are between the sun and the asteroid are referred to as inner planets or the terrestrial planets. What are the terrestrial planets? Mercury, Venus, Earth and Mars, right? Why? Because they have again solid surfaces. Beyond the asteroid belt, you have the planets which are known as outer planets, Jovian or gaseous planets, right? Gaseous planet. Clear? Clear, everybody? Now, please understand Jupiter, Saturn, Uranus and Neptune. These are the 4 Jovian planets. Clear? Quickly tell me. Clear to everybody? Okay, let me ask you a question. Before I show you, out of the inner planets, because these are closer to the sun, the temperature of which planet is the highest? A Mercury, B Venus, C Earth and D Mars. Tell me quickly. 1 minute time. Let's see how many of you answer this. Quickly answer. Okay, somebody asked corona. With respect, let me tell you. Okay, corona. I think we missed this. Okay, just a minute. I think we have by mistake left these 2 concepts. Let me explain it and then we'll move ahead. Let us come back again. We have missed chromosphere and corona. Let us do that and then we'll move ahead. Okay, Venus. Okay, good. Let us come back for 2 minutes. Right, someone has rightly pointed out that I have missed chromosphere and chroma. Okay, let's come back here. Because I was creating a question for you, so I forgot. So don't worry. Chalo, come back. We have done photosphere. Outside the photosphere is a layer known as chromosphere. This is what? Chromosphere. Yes, somebody said, sir, we have missed this concept. We have moved ahead. So let us cover it. Chromosphere. Above the photosphere, it is a layer of gas, glows reddish. It is usually washed out by bright photosphere, but seen as red rim during the total solar eclipse. See, this is a reddish layer that is outside the chromosphere. Sometimes during the eclipse time, you will realize there is a reddish ring around the sun. Normally, it is not visible as such, but a reddish ring around the sun, which you see during the time of eclipse, that is basically what? The chromosphere, right? Normally, it is not visible, but during the time of eclipse, it is visible. That means a layer outside it. Last layer over here is the corona. Now, you know the corona very well. This is corona before the coronavirus actually came, right? This is a corona before coronavirus actually came. So that is a different thing. Now, this is the outermost layer, which is extending millions of kilometers outside. Millions of kilometers outside. Outermost layer extending millions of kilometers outside, hotter than surface, a faint halo of white plasma. Till now, the reason why this layer is hotter than the surface has not been identified. This is very ironic. That corona layer has a temperature that is higher than the surface. But today, if you ask, what is the reason? Scientists have not been able to mention the exact reason for it. They are possibly asking a lot of chemical reactions might be taking place, but that is not an answer. Some say that some fusion might be taking place here, then also that is rejected. So there are various views, but they have still been rejected. There is no correct answer to this. But yes, this corona is hotter than the surface of the sun. Clear? Clear? Okay. Let's come back here. 2 layers, Jovian planets. That means the outer or the gaseous planets, inner planets are terrestrial planets. When I asked you which planet has the highest temperature, you said Venus. Okay. The correct answer is Venus. The good thing is that this question was also asked in your KBC, right? I remember many years ago for 3,20,000. So had you been there, you would have basically won that, right? Okay. Before we understand, I will be explaining you each planet here. Please understand, I'll be explaining you each planet here. But before that, let us broadly understand what is the difference between the terrestrial planets, which is the inner planets, and the outer planets, which are the Jovian planets. See, I will be explaining which planets have how many moons, what are the dimensions associated with it. These have been asked in UPSC examinations repeatedly. What they will do is, many will say, "Arey sir, UPSC does not ask this." Remember, you have already seen the UPSC paper. They put 2-3 statements, and out of that, one statement is a very simple statement, which is present in your NCERT. And this is also present in your UDAAN magazine. So I've written all this by hand. So I'll request you to see and listen to this very carefully. This is like you are studying of something of, let us say, class 6th or class 7th. But the reality is, this will fetch you marks in your civil services. You know that very well, right? So do not consider any single book that is of 6th or 7th or any stage that questions cannot be asked from that. I'm told you earlier also. In the process of just telling that you are preparing for civil services examination, you start reading huge bulky books, 2,000 page book because you are preparing for civil services. Please remember, the one who has not done the basics well will not be able to qualify this examination. That is why this UDAAN magazine is very helpful. It covers the NCERTs as well as the standard books. That is why we are combining all these things here. Clear? Let us see here. Terrestrial planets are formed in the closed vicinity of the parent star. That means they are located close to the parent star, right? Formed at quite a distance from the location. That means they are quite far away from the sun. Clear? You will see that the inner planets are smaller in size. The outer planets are larger in size. You can be asked differences also, right? And difference question that was based on the differences between both of them have also been asked in civil services in the previous year questions. You can check them. They had asked you Jovian planets, they have more density or lesser density. So please be very well aware. The inner planets, they have smaller in size, these are larger in size. These have higher density, these have lower density because these are gaseous, right? Mostly rocky, these are mostly gaseous. Ring absent, ring present in all. Okay, now tell me one thing. Among all these 4 planets, ring is present in which planet? Okay, let me ask you, which planet has or have a ring? Have a ring. Okay. First, Saturn. Second, Saturn plus Jupiter. Third, Saturn plus Jupiter plus Uranus. Fourth, Saturn plus Jupiter plus Uranus plus Neptune. What is the answer? What is the answer? A 1, 2, 3, 4. What is the answer? Now, a very interesting point comes here. In the UDAAN magazine also it is present, and in the NCERTs also it is present. The answer is that all the Jovian planets have ring. The only difference is that Saturn has a ring which is clearly visible. Jupiter also has a ring. Saturn also has a ring. Uranus also has a ring, and Neptune also has a ring. Many people feel Jupiter does not have a ring. No, the ring is present is so feeble that it is not possibly clearly visible, but all these 4 planets have ring. even the NCRT mentions, even the UDAAN magazine mentions. Yes, but you can take for NDA also. NDA also these questions come. So answer is 4. Did you learn? That is it. These are the small questions that UPSC asks. What they will ask? They will ask you, let me twist the question. Let me twist the question. Saturn is the only planet which has a ring. One statement. Then they will ask you certain other statements and ask you which is the correct point. You will say, yes, Saturn has a ring. I have seen in my book. Oh, clear. No. Let me twist the question again. Saturn and Jupiter have a ring. Okay, chalo, let's ask. Okay, let me ask you. Similarly, other statements are there. Is statement 1 correct? Because I've said all 4 of them have. Is the statement 1 correct? I said Saturn and Jupiter have a ring, but other planets also have. So is this statement correct? Quickly tell me, is this statement correct? Saturn and Jupiter have a ring, but I've told you all the 4 have. So is this statement correct? Quickly, everybody, yes or no? Yes or no? Is this statement correct or not correct? Tell me. You won't believe, I am taking a live lecture and आपका नाम क्या है?
राहुल.
हाँ?
राहुल.
After every half an hour, he is bringing tea for me and whatever I read. जो भी मुझे जरूरत पड़ती है, राहुल भैया जो है हमारे लेकर आ रहे हैं. आपको लगता है ना, when we are giving this lecture, you think कि हम लोग पढ़ा रहे हैं, चीजें कर रहे हैं. भैया के बिना एंड सब के बिना we cannot actually take our lecture. तो थैंक यू भैया, आपको सारे बच्चे हैं, आपका हाई कर दीजिए उनको, आपके हाथ में रहे. थैंक यू राहुल भैया ना. हाँ जी, थैंक यू भैया, थैंक यू सो मच. ये वाली है. तो मेरे चाय पड़ी थी तो ही टोल्ड मी नहीं, गरम वाली चाय लीजिए, दिस इज बेटर. थैंक यू भैया. सो ठीक है, चलिए. नाउ लेट अस कम टू दी आंसर हियर. रिमेंबर, दिस इज द गेम दैट यूपीएससी प्लेस. ठीक है, यूपीएससी प्लेस. It says Saturn and Jupiter have a ring. Does it say that only Saturn and Jupiter have a ring? First statement is, I have told you already from the basic knowledge of UDAAN and NCRT, you know that all of them have a ring. Whether they are visible clearly or not visible is a secondary part. We know they all have a ring. It writes Saturn and Jupiter have a ring. I say yes, it is true. It does not mention that only Saturn and Jupiter have a ring. Had it mentioned only, then it would have been wrong. That is why, please remember, extreme words, only, except, without, these words have to be very categorically taken. Right? So this statement is correct. It is not wrong. Had it mentioned only, then it would have been wrong. These are the please, UPSC is testing you on 2 levels. First, they're testing you whether you have the knowledge or not. Secondly, they're testing whether you understand what it is trying to say. So this statement is correct. See, you would realize that I am telling you from the perspective of how to solve the questions also, in every single point what I'm explaining. This is the art of learning how to solve the multiple choice question. That is why all those who are preparing in 28, 29, okay, whatever year you are preparing, this is the art that you need to learn if you want to solve the questions. Clear? So we have done with the difference. Can I go to the planets and study now? Let's see. Lot of questions are asked with respect to the planets also. Chalo, I'll ask you one more question before I move ahead. Supposingly, this question has been asked in Uttarakhand PCS, Uttar Pradesh PCS and UPSC in 1990s and 2000s. So I'm asking you one question. Supposingly, these planets are present. Can you see all these planets? I can hold these planets like these. Supposingly, I have a bowl of water, a very huge bowl of water. larger than these planets, and I put all these planets one by one into that bowl of water. Understood what I am doing? I take Jupiter and put it in water. I take Saturn, put it in water. I take Uranus, put in water. Neptune, put in water. And all these planets one by one in water, right? Out of these planets, which planet will not sink? Have you understood what I've said? I put these planets one by one in a bowl of water. Let us assume I have a huge bowl of water. Which planet among all these will not sink and it will float? Yes, बच्चे study भी देखिए. Yes, absolutely you can. Very relevant, right? Okay, somebody saying Saturn? Absolutely. So what do you learn out of this? Saturn has a density that is less than or very less density, less than water, yes? Yes. So what will happen? It will float. It will float. No, not Jupiter. It is Saturn. One more thing that you learn, Saturn is the least dense planet. Least dense planet. Now let us see this. I'll be telling you this, don't worry. Density is less than 1. That is why it is least dense. We will be studying this, don't worry. These are the points that you should know. Mercury. Mercury is terrestrial, it is rocky. These are the points through which questions are created. Mercury has no moon, 0 moons. One revolution is equal to 88 days. That means in 88 Earth days, that means what we calculate as 1 day, in our 88 days, it will revolve around the sun. It will revolve around the sun. Why I have mentioned 88 Earth days? What we have 24 hours now, 1 day. Similarly, into 88 will lead to one revolution for what? Mercury. Rotation is 59 Earth days. Do you realize in 59 days, it just revolves once? Do you realize this? 88 days for one revolution, but for rotation, 59 days. It is closest to the sun. It has high density. Ice deposits formed in the polar craters. Now, very interesting. This is a recent research that has been found. Polar deposits, polar regions have found some ice deposits there. Now, you will be saying, sir, it is not possible. It is not possible. But yes, it has been found. Anybody can tell me, let us go into logic for 2 minutes. How is it possible that being so close to the sun, it is having ice deposits? Can anybody tell me this? There is a reason, there is a answer within this particular section I have written. Right? Mercury is closest to the sun, right? Mercury is closest to the sun, but I am saying it has certain ice deposits. How is it possible? Can anybody give me the answer? The answer is within this content which I have written here. Can anybody give me the answer? Do you realize the rotation of the earth is the answer? In 59 days, it is, see, earth rotates in 24 hours. This whole circle, rotation completes in what? Rotation completes in what? 24 hours. This rotation is only completing in 59 days. The slow speed of rotation means that the other part mostly is away from the sun. Away from the sun. So it is not receiving sunlight. So the temperature will be relatively much cooler. So the possibility of ice existing can be there. So when the other part turns, again the temperature is less, very less. This is the answer which was recently found in one of those science magazine, which you basically all these studies come. So this can be asked in your preliminary examination. First of all, Mercury first statement has ice deposits. You will say no, possible, not possible. So you will mark it wrong. No, it is correct. Second, the reason behind it is that of the rotation of the speed. Assertion and reasoning question come. Assertion and reason. that that reason is the answer for the question. So these are the questions that are asked. That is why concepts are easy. The questions which are asked are tricky. So for the difficult questions also, and every question, you need to know the basic concepts. The one who knows the basic concepts, I am guaranteeing you, you will not fail your preliminary examination. Venus, it is terrestrial. Venus does not have any moon. One revolution is equal to 225 days. Now understand one more thing. Rotation 243 days, it is the slowest, but it is also the hottest. The reason behind it is, now somebody will say, sir, because Venus is even slower than Mercury, it should also be relatively cooler. The reason is something different. The reason for the high temperature is thick carbon dioxide atmosphere with sulfuric acid clouds. These basically trap a lot of heat, and that is why it is the reason is that it has very high temperature. Density is high. So the slowest planet with respect to rotation is Venus. Now the question will again come, sir, it is taking this much time, it is taking more time, so it should be cooler. But the reason is the atmosphere that is present of carbon dioxide that counters the slow speed of rotation, that leads to high temperature being present here, because the greenhouse phenomena which we see on Earth, a similar phenomena of a very high degree happens in Venus. And that is why you will realize that the heat that is trapped is not able to escape also, and that basically again amount of heat that is present here, you will realize that it will lead to very high temperature over there also. Clear? So this is the reason for Mercury. Clear? Earth terrestrial density is now density of Earth is 5.51. Highest density is of Earth. Very important points. This is the slowest planet with respect to rotation. This is the highest density. It has one moon, we already know. One revolution, 365.25 days. Rotation is 24 hours. Life is present. Mars terrestrial density is 3.9. Moon, it has two moons. Please understand, in the UPSC recently, do you realize the questions are asked, planet and the moon's name was present in front of it. That means you need to know which moon belongs to which planet. Remember that? Questions are asked, most of the candidates were not able to answer that because they did not know the name of the moon. Please remember, whatever I am doing now, these things also, these out questions will be created out of this. So Mars has two moons, Phobos and Deimos. What? Phobos and Deimos. Had I mentioned these two names before I taught you, possibly you would have not been able to identify whether these are moons of Mars or Saturn or Neptune, whatever. So you should be very clear. These are the moons of what? Mars, Phobos and Deimos. One revolution is 687 Earth days. That means twice that of Earth. Rotation is 24.6. That means almost equivalent to that of Earth. It is known as a red planet. Why it is known as a red planet? Because iron oxide is present on a large scale or large number, large quantity. That is why it appears like a red planet, because of the iron content that is present. Are the inner planets clear to you? Are the inner planets clear to you? Quickly tell me. Inner planets done? Over here, what I have marked here is something that you need to remember. Whatever I have marked here in red right now are certain things that you should be aware of. Rest of the things is common, everybody knows. These brackets that I have marked in red are something that you should keep in mind. Questions will be created out of them. Okay, right? No, beta. Moons are, again, please remember, moons of different planets can be of different sizes. They can have different composition, right? Different composition, different sizes. Okay. Now comes Jupiter, Saturn, Uranus and Neptune. Clear? Clear? Shiva, 22757. Beta, I am live in front of you. Right? So, I am live in front of you. He's thinking whether it is live or recorded. I am live in front of you and I'm answering the queries also, whatever you are asking. Right? Clear? What is the name of Earth's moon? Beta, it is moon only. Right? Okay. The name of Earth's moon is moon. Jupiter, it is a gas giant, right? Where can I, beta, PDF you can get from the PW app. I've already mentioned in the starting. You will get it. Don't worry. I will post it in my Telegram account also. It is a gas giant. That means it's a gaseous planet. Density is 1.33 grams per centimeter cube. That means even if you put it in the bowl of water, it will basically sink, right? Moons, it has a very important moon which is known as Ganymede. Let me highlight it again. Ganymede. Clear? Clear? Revolution takes 11.86 Earth days. Rotation 9.9 hours. Just imagine how quickly it rotates and revolves. Speed of rotation is 45,300 kilometers per hour. It is the largest planet and it has the strongest magnetic force that is present there. Clear? So, what have you learned till now? I will be creating an MCQ after 2 minutes, right? I'll be creating an MCQ, right? Okay. Saturn is also a gas giant. Density is 0.69. See, wherever you do not have to remember the densities, please remember. Two densities you have to remember, not by facts, but by knowledge, that Earth is the most dense planet and Saturn is the least dense planet, where Saturn has a density less than 1 grams per centimeter cube. So, if there is a huge bowl of water, Saturn will not sink. You do not have to remember any other density. Please remember. These are the two things. I've just written the density so that you should have a brief idea. Nothing other than that, right? Okay. Largest moon of the Saturn is Titan. Titan. Revolution 29.5 Earth days, rotation 10.7 hours, speed is 36,800 kilometers rotation, and it has a prominent ring. When I say prominent ring, that means it is very clearly visible. Rings are present in all of them, remember that. Uranus is an ice giant because ice content is present majorly over here. Density is 1.27, moons are 27. Now, one more thing. Over here, Jupiter has 95 plus moons. What do I mean by 95 plus moons? Scientists have said there, because see, initially if you see the oldest of the NCRTs, possibly you will be seeing 16, 17 moons. At present, there are 95 plus moons. That means a lot of moons which we haven't discovered, but they are present there. Now, you cannot remember every moon. You need to have a brief idea. Saturn has 140 plus moons. Uranus has 27 moons. Revolution 84 Earth days, rotation 17 hours, axial tilt is 98 degree. Remember, please remember this very, very well. This is a very unique feature that you should know. Can I say the axis of the Earth is like this and it is rotating like this? Can I say it is like this is the axial tilt and it is rotating like this? Can you understand this? In case of Uranus, the axis tilt is like this and it is rotating like this. What does 98 degree mean? In Earth, it is like this, slightly tilted. For Uranus, it is like this. And it is then rotating. Clear, everybody? Clear? Axial tilt is 98 degree. Coldest planetary system, methane gives blue-green color to it. It is the coldest planet. Methane gives it a greenish color. Neptune is again ice giant, again rotation revolution. It has 14 moons and largest is Triton. Chalo, let me create a question for you. Let us see whether you can answer it or not. Ready for the quiz? Match. Let us see. Match the which among the following are correct? Which are correctly matched? For this you need to know, all of them. Yes, Kaushik Kumar ji, it will be more than sufficient. Yes. For this, you need to know, nahi, please understand, what does it mean? How many of them are correct? You need to know the number. It does not mean that only one is correct. That means you have to calculate how many of them are correct and then give the answer. Right? Then give the answer. Please do not misunderstand the question. Right? See here. Is Uranus correct? Is Uranus Triton? No. That means this is wrong. This is wrong. Yes or no? Saturn is Titan. This is correct. Mars is Phobos. This is correct. Jupiter, this is correct. Only 3 options are correctly matched. 1 option is wrong. So the answer is 3. C. Understood? That is why these are questions which are coming in the examination and you get shocked from where these questions are coming. These are basic knowledge. These are basic knowledge. Those part of the elements which you, topics which you people do not explore also. Clear? Clear? In the UDAAN it is also present. In certain books, that is added here. In NCERT they do not update it because it is very old. So this is all updated content. Okay. Sun done, inner planets done, outer planets done. Little bit idea of certain other concepts which you should know. Right? Certain concepts you should know. Clear? Okay. You would have seen that there is an asteroid belt that is present here. Right? There is an asteroid belt that is present here. Now, questions have arisen that how is it that between this 2 set of planets, this asteroid belt is there? There is a possibility that what is said that possibly a planet existed here. Okay. So this is my exams PYQ. Bache, see, it was created in front of you. Do you remember this? I do not have any source right now. I am creating the PIQs out of the content that I have written in front of you. And this is how the examiners are also going to create the content. See, one of the candidates is saying, this was exams PYQ. This is how questions are created. So if you stick even to this properly, Indian geography, world geography, or the mapping series I do, I'm telling you, you will be able to do most of the questions in your examination very easily. Clear? So I'm creating the content from here only. So please understand. Okay. Between Mars and Jupiter, this belt is there. Rocky material, metallic rocky material are present here. There are a lot of queries with respect to the question that from where has this particular belt come? There could have been a planet also here. So why is this rocky belt present? See, the scientists have basically said that possibly a planet existed here which disintegrated, and because these particles that are present are remnants of that planet. This is again a basic view that is accepted by most of the scientists and geographers also. So that is the reason why this rocky metallic substances, very large scale sizes to small sizes are present here. Possibly a planet existed here, right? Which we do not have right now any knowledge about, whether it was there or not exist. These are views. But this is a strongly accepted view that possibly a planet existed which disintegrated, and that is why these rocky metallic disintegrated particles are present, right? Situated between the orbits of Mars and Jupiter. This is also one of the questions which is asked. Mars and Jupiter. Asteroids are rocky, metallic and celestial bodies. They are thought to be the remnants of a planet that disintegrated, right? Beta, if you do this, this is more than sufficient, Shiva, because I have covered every dimension. So if you do it, provided you do it properly. There's a good question that is asked by a candidate. Say, is it enough? Do you realize what I'm teaching you? You need to understand and then revise it. Then it is enough. But if you just read it upar say like this once or twice, then it is not enough. Questions will be created out of this. But you need to revise it many times, many times. Then it will be more than enough. Okay, chalo. Two other concepts that you should know. You have studied a asteroid belt, that is a rocky celestial bodies that are present between Mars and Jupiter. Similar bodies are present that we know of. Let us see this. So remember, this is the sun and these are the 4 planets. This is Mars. This is our what? Asteroid belt. Outside the asteroid belt, you have the 4 planets. See here. Supposingly, this is the sun. This is Mars. This belt that is there is the asteroid belt. These are the 4 gaseous planets. Outside the gaseous planet also is a belt that is present. This belt is known as the Kuiper belt. What? Kuiper belt. So they can ask you a question how? I will be again creating an MCQ, so understand this concept. Understand this concept. I'll be again after this creating a question because there is a possibility of them asking a question on this. Outside our solar system, there is a belt which is known as a Kuiper belt. It is a remnant of the asteroid belt left over from the dawn of the solar system. Possibly they say, see, we say that asteroid belt was created because it was disintegrated. Some planet might be existing and it disintegrated. But similarly, there might be various other planets and bodies that existed which might have disintegrated during the time of the beginning of the solar system. That is why such types of bodies are present outside it. It is known as a Kuiper belt. Clear? That means outside the solar system. Next. Now please understand, this is what? The asteroid belt. This is what? The Kuiper belt. Outside that, if you go far away, millions of kilometers, then there is what? Oort's cloud. What? Oort's cloud. This is very bubble filled with icy space debris. That means again you will realize there are icy debris, space debris, particles that are present here. We have less knowledge about it, but again varying composition. Again, like asteroid belt, we have the particles that are present, but there is ice particles also that are present there. So this huge belt-like structure over here is known as an Oort cloud. Now let me create an MCQ. A, B, C, D, which is the answer? Quickly, everybody. Let's see how many of you are able to answer this. asteroid belt, Kuiper belt, Oort's cloud. Quickly, what is the answer? Now over here, UPSC has used, right? UPSC basically might not use a statement directly, but it might use a statement indirectly. What is a red planet? Mars. What is the largest planet? Jupiter. Asteroid belt is between Mars and Jupiter, so the statement is correct. Kuiper belt lies beyond Neptune. Yes, it is correct. It is outside Neptune only, much beyond the solar system, so it is correct. It is rocky as well as icy. Yes, it is correct. The answer is A. So, if you haven't, somebody is saying only A. Somebody is saying what 1 and 2. No, Oort's cloud has rocky as well as icy particles. I told you. So please remember, the answer is A. If you had not read what is Oort's cloud and all, you possibly would have not been able to write the answer also or mark the answer. That is why you should be well aware of it. Clear? Okay. Comets. Again, there are certain concepts like comets, meteors. Questions are repeatedly asked on them. And what are meteoroids, meteors and meteorites? The differences among them is also very important for your understanding. Clear? Okay, somebody is asking, Oort's cloud has rocky as well as icy crystals. Remember this, that in these regions, remember, the particles that are present are made up of ice. Icy particles are also present. Do you realize I had also mentioned here in the solar system also, ice giant. Ice is present here also because the distance from the sun is very large, they are very far away from the sun. So the temperature is going to be cool, right? Ice is present here also. Sir, in space there is no. Beta, tell me, comets when they come, do comets not have ice crystals? Who said water is not present? Who said? It is present. Neptune is an ice giant. It is present. So that is why I'm saying that if you study Earth, you are in Earth does not mean the other planets are not going to have water. I said Mercury also has. Yes. On moon surface also craters having ice crystals have been found. You know that? Chandrayaan found water. Chandrayaan 2, yes or no? So please, if you say that there is no water, then that is a wrong statement. Water is present. Understood? It is not necessarily drinkable. That is a different scenario. See, one of the major findings of Chandrayaan 2 was water. Yes. Over here also ice. The question, this should be very clear. Water is present here also. Water is present here also. Okay. Okay. Now see, over here I told you icy crystals are present here also. So that means it is here. There is no problem here. Chalo. See, icy space debris. So please, bache, every single thing is mentioned here. So please be very careful whenever you are reading this. Chalo. Comets. Now comets are basically icy bodies made up of frozen gases, rocks, dust that range from width from few to tens of miles. So these are basically what? Icy particles that are moving, let us say, from far away distance. Many of them basically come from the Oort's cloud region also, right? They keep on moving in specific, let us say, proper direction also. They have an orbit also where they are moving. They just have a tail also like this because of the movement. You realize that a tail-like appearance comes. This is a dust tail, and they're icy particles. So these are comets. Then you have meteors. When you study about meteors, there are 3 words that you should know. What the problem that people face is they tend to get confused among these. First of all, meteorites, R-I-D-S. These are small fragments that break off from the asteroid when they collide with one another. Supposingly, you know that in the asteroid belt, a lot of particles, rock particles are present. they collide with each other, and because of the collision, the energy that is gained, they move in some other direction. They might come towards the earth also, quite possible. So when small fragments that break up from the asteroid belt, those particles are known as meteoroid, ROID. Clear? Meteoroid. Now, please understand this. Somebody saying, sir, English mein padhao. This channel is bachche, this channel is English, so this is an English channel, please. For that, you will have to refer to other channels. Meteoroids. Because of the collision of the particles in the asteroid belt, certain particles might move in some direction out of the asteroid belt. Those are known as meteoroids. What are meteors? Shooting star, when the meteoroids enter the atmosphere, they burn due to friction. Please remember, meteors will be the ones, they will enter the atmosphere of the earth, but they will burn and disintegrate in the atmosphere. They will not reach the surface of the earth. But meteorite, RITES, are the ones, if the meteoroid does not burn in the atmosphere completely and it manages to reach the surface of the earth, then it is known as meteorite. So diagram is, this is meteoroid, ROID. This comes in this, earth enters the atmosphere. This is what? Atmosphere. Over here, most of them will burn. Most of them will burn because of the friction, and they basically burn in the mesosphere, right? Absolutely. But you will realize that some of them might not burn completely and hit the surface. While they are burning, that is why we see shooting stars, because they are burning during that time. But some of them manage to hit the surface. Then if it hits, it is known as meteorite, RITE. Clear? Clear? Clear, everybody? Yes or no? Is it clear? So, now the next part is the moon. This moon, again, right? Thank you, Lavina ji, if you're understanding. UP boards, okay, that is good. Okay, that's nice. People from the board examinations also there. So it's useful for you also, absolutely. Are you able to understand what is the difference between meteoroids, meteors, and meteorites? Chalo, shall I give you a way of remembering it, everybody? Shall I give you a trick, everybody? Most of you get confused between meteoroids and rites, right? Do you want a trick? Tell me one thing. For you to talk about, I want fundamental right, you have to be on the surface of the earth. I want fundamental right. So you will say, I want right, RIT, right. So you have to be on the surface of the earth. So RITE means it is hitting the surface. It is hitting the surface. So by default, you can remember the other two also. For you to be asking for certain rights, I want fundamental right, I want this right, I want right to speak, you have to be on the surface of the earth. So that means RIT means that is hitting the surface. Clear? You will remember this thing, because most of the people get confused between right and rights. Okay? So this is a way you remember it. Clear? Okay, let's move ahead. Now comes the moon. Now moon is the only natural satellite. Please remember that when we talk about satellites can be natural also and artificial also. You realize every single day multiple satellites are launched via various rockets vagera. You know that ISRO and various other agencies are launching the various rockets. So, but the natural satellite of Earth is only one, that is moon, right? Now, again I have made a diagram. The question that comes is, how was the moon created or formed? Please remember, see, it is generally believed that the formation of moon is an outcome of a giant impact called the Big Splat. If you ever read the NCERT, right, that is also nice. Some Priyanshu is saying last write is done on Earth. Absolutely, you can remember that way also, right? Big splat word is mentioned in your NCRT. It is mentioned in your UDAAN magazine also, and this has been asked in the civil services exams also. Multiple, particularly in the NDA, CDA, CAPF also, and UPSC also. Big splat is basically the impact which happened where a huge body basically hit the earth, and because of that moon was formed. So big splat is associated with the formation of the moon, right? Now see here, a body of the size of 1 to 3 times that of Mars collided into the earth and blasted large part of earth into the space. And this basically, remember how it took place. See here, though I've shown it from a small body, but it was much larger. A huge body came and it hit earth. Can you just imagine when it would have hit earth, complete again, everything would have just blasted, melting of the substances that were present there would have happened. So what would have happened? Because a large amount of particles would have basically come out. These particles would have started moving around the earth, and slowly accretion would have happened, and the moon is present as it is today. Is this diagram good enough to understand? So can I say this can be seen as a aspect of a big splat, right? Clear? So you know what has happened. See, I've created this diagram so that you can remember and visualize what has happened. Clear? Now see, blasted portion continued to orbit in the earth and formed the present moon 4.4 billion years ago. So this moon that was created is again 4.4 billion years ago. Till present, it is going on. Clear? 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 Let's move ahead. Because we are doing moon, right? Because we are doing moon, let us understand the concept of eclipses also. Now see, an eclipse happens. See, when an eclipse happens, when a planet or a moon gets in the way of the sunlight. Now these are again basics. We have what is the position of the earth, moon and the sun relatively. Based on that, eclipses are found. Now the eclipses are basically of two types, lunar and solar eclipse. You should have a brief idea. Lunar eclipse happens when the earth is between moon and the sun. So what happens is, earth will cast a shadow on the moon. What will happen? Earth will cast a shadow on the moon. This is known as lunar eclipse, when the earth's shadow is cast on the lunar surface. This is known as what? This is known as what? Lunar eclipse. That means eclipse is on the moon. The moon is a shadow is being casted on it. This is known as lunar eclipse. Clear? These are very basic things, but remember, when you're in the examination, if you haven't read them, you get confused. Right? Done lunar eclipse, solar eclipse. In this case, basically, the moon is casting a shadow on the earth. Sometimes you realize that during the daytime also, because during the time of a solar eclipse, there is darkness because the moon is casting a shadow on some part of the earth. So when the moon passes between the earth and the sun, partially or fully obscuring the sun's light from reaching the earth. So that means when the moon is between earth and sun, a certain regions will be experiencing a shadow that is casted on that region, and during that time you will realize that region will observe for a few minutes only, a few seconds, you will realize darkness. So that is basically referred to as a solar eclipse. Clear to everybody? Clear to everybody? Basic concepts, because we are doing moon, so I have completed this also. Okay, now bachche, remember one thing. Okay? Okay, somebody wants me to repeat it. Beta, eclipse happens when a planet or a moon gets in the way of the sunlight. Major concept is, right? Clear? Beta Siddhanshu will get it done, don't worry. Let us focus on the lecture right now. Now see, eclipse basically means that when the planet or a moon get in the way of the sun's light, right? Sun's light. Now, relatively, whether the moon is between the earth and the sun, or earth is between moon and the sun, that will depend. So, based on that, lunar and solar eclipse are there. Lunar eclipse is when earth is between moon and the sun rays are coming here, see. The sun rays are coming here. But do you realize this region will not see, sun rays will not be visible or sunlight will not be visible. Why? Because the shadow of the earth will be casted on it. So this is known as lunar eclipse. On the other hand, when the sun rays are coming, you will realize the sun rays are hitting here, a shadow will be casted on this part. So this will experience darkness for some time. Blockage of light is there. So what is happening? This is known as solar eclipse. Okay. Beta, now see here very carefully. See here very carefully. These two things which I am doing right now are one of the most important part. They are present in your NCERT also. Along with it, UDAAN magazine also, and asked in civil services examination repeatedly. Evolution of lithosphere. Lithosphere, that means the crust and the upper part of the mantle. We'll be doing ahead, don't worry. Lithosphere and evolution of the atmosphere. I will be doing these things at atmosphere. I'll be doing in climatology also, don't worry, but you should be aware of this. Now, let's see. Evolution of lithosphere. I put it in a diagrammatic flowchart manner, right? Flowchart manner, why? Because if you visualize in this form, you will remember it in your life, right? See, Earth was in a volatile state during the primordial stage. Please remember, volatile stage, that means high heat, amount of energy is present here in the initial stage. You will realize with gradual increase in density, the inner temperature increases. As there was more accretion and accretion took place, density increases, and they said the temperature also increased because of the accreting material coming. What happened because of that? Because you saw accretion took place. Now accretion is hitting, then again temperature is also rising, right? You will realize when this accretion is taking place slowly, because the temperature has risen to a great extent, so heavier materials will sink inside, lighter will move upwards. This happened. After that, what happened is a big splat. Big splat was where a large body basically hit the earth. So due to big splat, again the heat or the temperature increased tremendously. Sorry, just I think I have, no, it is fine. Differentiation took place. Differentiation, you can basically say that crust formation would have taken place, but then big splat happened. Big splat happened. After that, what happened? Temperature rose. Temperature rose, and again slowly cooling would have taken place. Then again you will realize the heavier particles would have gone inside and the lighter ones on the upper surface. And that is why you know as crust, mantle and core. Core has outer and inner parts. This is how lithosphere was created. Clear, everybody? Again repeating, in the initial stage, let us say, Earth was in a volatile stage. With a repeated accretion that took place, hitting of the material or joining of the particles, you realize density increased, temperature increased. Differentiation of the layers happened where the heavier particles went inside and the lighter ones basically outside. Obviously, you realize with time, solidification, condensation would have taken place and upper crustal part would have formed. But then big splat happened. Big splat again rose the temperature to a great extent. After that, what happened? You would have realized that again the phenomena of differentiation of material. Differentiation means the heavier particles will go inside and lesser, denser particles will be on the upper layers, right? This is how the crust lithospheric layer later was formed. So this crust plus the upper part of mantle is a lithosphere, which we will be doing after a few minutes. We will be covering that part. Till here it is clear. Now comes the evolution of atmosphere. Question has been asked on these topics also. You should understand this is mentioned in NCERT also and UDAAN magazine also. When I say primordial atmosphere, primordial means the initial stage, right? The most initial stage of the atmosphere. At that time, what was present there? Stage 1. Primordial atmosphere. Primordial atmosphere basically comprised hydrogen and helium. What? Hydrogen and helium. So if in the examination, if it comes, the primordial atmosphere comprised hydrogen and helium, right? Right? Sir, you haven't taught structure. Beta, that is why we have covered all these things. Please, just to correct you, there are certain new things of UDAAN and all these things have been covered here. That is why I'm telling you, listen to these, right? We have covered all these things here. So listen to these. There are a lot of extra stuff also, as you have rightly said. When we were doing the NCERT series, there was different material also present here. Over here, we have added a lot of things along with UDAAN magazine. So please cover it from here. That is why this lecture is being covered, na? So please use this, right? Chalo. When I'm saying primordial atmosphere, you will realize that initially it was hydrogen and helium. Now what happened is, you know that Earth was located close to the sun. So solar winds basically were impacting the Earth and the other planets more. So the solar winds, these are what? Yellow. These are solar winds. Solar winds basically led to or just removed the hydrogen and helium from the surface, right? So loss of primordial atmosphere due to the solar winds. This has been asked in civil services. What was the reason for the loss of the primordial atmosphere? That means the initial atmosphere. The reason was solar winds. Clear? Everybody clear? Any problem? Now, when the initial solar winds have removed the primordial atmosphere, the next step that will happen is, how come other gases have basically come or surrounded the Earth's atmosphere? The other phenomena was degassing. 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 What is it? Please understand. You realize that Earth was again volatile state, because you know, you have already seen that because of the big splat and all, temperature rapidly rose, right? Slowly you will realize that there will be cooling of the Earth. Cooling of the Earth will happen. When the cooling of the Earth will happen, gases will be released and vapor, along with that vapor will be released. Okay, somebody is asking me to repeat it. I will repeat it. Initial stage, you will realize that when the Earth was basically in the primitive form, not formed properly, the primitive atmosphere was hydrogen and helium, right? Supposingly, this is a surface. Hydrogen and helium gas are present. Solar winds came and they basically removed the initial atmosphere. Now you do not have a proper any atmosphere that is present. So that is stage 2, right? Stage 2. Stage 3 is degassing. In this stage, what happens? I told you the Earth was volatile. Slowly it would have cooled. During the cooling process, gases were released and vapor were released. During this time, you realize gases like nitrogen, carbon dioxide, methane, ammonia, and little bit of free oxygen were released in the atmosphere, right? So what happened? These gases were released in the atmosphere. Degassing led to water vapor, nitrogen, methane, carbon dioxide, ammonia, and free oxygen entering the atmosphere. Everybody clear? So in this stage 3, these gases have come to the atmosphere. Now comes the next stage, which basically modifies the atmosphere composition after this. Everybody, till stage 3, it is clear or not? Till stage 3, clear or not? Clear? Clear? Primordial atmosphere, hydrogen, helium. Second step, loss of primordial atmosphere because of solar winds. 3, degassing. Just tell me one thing. Whenever you eat outside food, your tummy has a lot of gas. How do you degas? Do you fart? By farting, do you degas? Yes or no? When your parents are sitting along with you, when you fart, you degas, then gas is removed from your body. Yes or no? So that is degassing. Similarly, the earth was also farting and it removed certain gases. Simple way, can you remember this? Degassing, gas removed. So what was there? Because earth, because you realize that uh, earth was cooling during that time, right? Earth was cooling during that time. So during that time, cooling phase, gases are released. Water vapor is also released. All these gases came. So it surrounded the earth. Yes, your farting is equivalent to degassing of the earth. Will you remember this? I think you will never forget this. Now, next step. Next stage is, right? Next stage is modification of the atmosphere further on. Modified by photosynthesis. Please remember, right? You will realize this, that water vapor was released. Now, this will slowly form what? Clouds. Right? Slowly formed clouds. Yes, earth was farting. That is the best example to remember, right? Now remember that when water vapor again was released during the process of degassing, clouds would be formed, and you will realize that later on rain will also happen. So rainwater got filled into the depressions forming oceans. If you see the Pacific, please, when you see the earth now, the shape appears like this, right? It is because you see the water surface also. If you realize the Pacific Ocean, it is not a proper shape. पता है? It is like a crooked type shape. These depressions have been filled by water. That is why it appears like a proper shape. So what I'm trying to tell you, there were a lot of depressions, not an even surface. It was not an even surface. Water vapor cooled, condensed, and in the form of rainfall, basically, you realize that the rain happened. It basically filled the depressions that were present on the surface of the earth. So rainwater got collected into the depressions forming oceans. Ocean formed 500 million years from the formation of the earth. Within 500 million years, the depressions got filled and oceans were formed. 3,800 million years ago, life began to evolve. Slowly, where did the life initially began? In the oceans. Please remember, the life did not begin on the surface of the earth on land. It began on the oceans, inside the oceans. So life was initially confined to the oceans. Now, these oceans, please remember, oceans began to have contribution of oxygen through photosynthesis. Now, plant life was there. Now, these plant life, what did they basically began the process of photosynthesis? These photosynthesis basically led to the water having more concentration of what? Oxygen. When the oxygen content in the oceans increased, later on you realize that content was basically given to the atmosphere. So what happened? Oxygen began to flood the atmosphere. And then you realize atmosphere also had what? What? Oxygen. So this basically led to oxygen being present in the atmosphere also. Is it clear? Clear? Okay. I am giving you 5-6 minutes break. Meanwhile, I'm giving you the break. I will be doing certain questions on time also, latitude also. Very briefly, it is here. 5-6 minutes break, because you're going to understand certain topics of time calculation. Along with it, please remember, after this, I will be doing the PYQs. There are certain questions here. After that, I will be starting with the PYQs. Please remember, where are the PYQs? PYQs, right? So 5 minutes break. After this PYQs, I'll give you 10 minutes break. Don't worry. So let's give you 8 minutes break. Meanwhile, please enroll. There is in the description box, there is an option for enrolling. Click on that, enroll it, because you will be able to access these notes after the class gets over. Right? Clear? Done? 10 minutes break, then I'll come again. 8 minutes break. Sudhanshu is saying, sir, on the basis of micro themes, I started. Beta, dekho, see, remember one thing. What you were saying is, see, when we talk about micro themes, yes, there are certain things that are repeated, agreed. One more thing is that today's time, you cannot miss on the topics of NCERT and the UDAAN thing that we have covered, UDAAN magazine. Because today's civil services preliminary examination is such that they can ask you any question. Micro themes means that division on certain small topics that you have taken. Yes, good enough. But you should cover all these standard, these NCERTs and UDAAN magazine. If you have done, you will be in a very good state. Clear? Okay. Let us continue. Coming back, again, let's begin. Latitude and longitudes, these again are topics which are very, very critical. Questions can be asked on them, and I will be again preparing for CDS with it in much more than enough. If you're preparing for CDS, nothing will come outside this, right? Even in civil services also, you don't need to worry, so don't chill. Just give me a minute. One more thing, I got a message from my team also. Please remember, after this session, as I've told you, you will not only be getting the notes, उसी के साथ साथ you will be getting a free test also. Please remember, give a free test also after the class. Possibly you can give tomorrow also. There is no problem. Today I will request you to go through the session, revise it, those who want, because many of you will be seeing in a recorded format also. Agreed? After the revision, give the test. Then you will realize how much you have learned in this session. Agreed? The team has created a test also absolutely free of cost. I'm telling you, bache, these tests are there. Make the best use of it. Clear? I'm doing the questions here also. You will be getting the test tomorrow. Give it tomorrow. Give it on Sunday. What? Not Sunday. Sunday to there is Thursday. There is second marathon. Give a day. Give it on Wednesday. Enroll it today. Enroll yourself today so that your link is activated. It is completely free of cost. The link which is given where you enroll, when you enroll it, you will get the free test there also. So every single person should enroll it. When there is the next break I'll give you, then enroll it. Enroll yourself, right? Okay. Beta, just imagine that there is an earth over here. Can you see I've tied the earth with such ropes, right? I've tied the earth into the rope over here, right? Clear? PW team, thank you. Love from Tamil Nadu. Bache, lots of love from our side. I tell you, whenever I get free, I want to visit. I have been to Karnataka. It's a beautiful place, beautiful state. Tamil Nadu is what I've never visited. We would love, again, Nikhil sir and I was talking that we will have the yatra for the southern Indian states. We'll like to visit to Tamil Nadu, various parts. Sir is from basically from Kerala. Want to visit Kerala also, Karnataka, Andhra. A lot of my friends are from Andhra, so we love to visit all the southern states. Again, beautiful places. We love the temples there. So whenever we visit, we will be definitely meeting all the people here also. We love our people from the southern part of the country. Very nice. So we'll be with love to the people from Tamil Nadu, Karnataka, and Andhra Pradesh, to Kerala, whichever place you are, right? For that matter, all states are equally important for us. But yes, we get a lot of love from the southern states also, and we really like it, right? Okay. Now see here, do you realize that these are certain lines which I have tied the earth into, like this, like this, like this, right? Right? You've seen these lines. Now, if you see these lines, do you realize that they are like complete circles? Do you realize these lines which are running from this direction to this direction, these are complete circles. Then there are certain lines which are starting from this point and going down and meeting the south pole. Now, how you can remember them? Please remember, there's a Hindi word, leta hua. Okay, somebody's birthday. So, Sandhya Yadav ji. But today's a birthday. Many, many happy returns on the day. May God bless you with all the good things in life. God bless and work really hard. You will achieve your goal. These ropes which I had tied, in Hindi, there is a word leta hua. Leta hua matlab sleep. Leta hua. Can I say leta hua latitude? Leti hui? Can I say leta hua latitude? Clear? Yes or no? So these are latitudes. They are lying like this, right? I'll be explaining you, don't worry. The others over here, which are running from north to south over here, these are what? Longitudes. Clear? Clear? Now let us study one by one. See, if you study, these are certain things which can be asked in your papers also, right? Okay. When did the class resume? Just 1 minute back. Don't worry. You haven't missed anything. You have started from this only. If you see the polar circumference, that means, let us say I tie a rope. Let us assume, let's see. Okay. Let us see, this is the Earth. Oh, my makhanas have come out. Okay. No. Let us see, this is the Earth. If I tie a complete rope, right? Tie a complete rope. This will be the circumference, polar circumference. This is 40,008 kilometer. If I tie a rope around, that is what is known as equator. It is known as equatorial circumference, which is 40,075 kilometer. Right? What do you observe here? What do you observe here? That the equatorial circumference is little more than the polar circumference. This is because of the bulging that take place at the equator, right? So that is why you realize this equatorial circumference is little more than the polar circumference. Polar circumference is 40,000 kilometers. Equatorial is 40,075. A difference of, again, few kilometers only, right? So what does this mean? What does this mean? That the circumference is not equal with respect to polar and equator. Clear? Now let us see the distance. We want time zone in world problem. Yes, I have a query questions also for that. Don't worry, we'll do that. If I see the direct distance from this point till this point, it is 12,714 kilometers. From this point till this point, 12,756 kilometers. This was a circumference. This is a direct distance. Clear? Clear? Okay. Let's move ahead. This is the basic thing that you should be knowing. We will be solving the time question also. Don't worry. The shape of the Earth, because of this bulging, is known as oblate spheroid. What? Oblate spheroid. Clear? Okay. Now comes latitude. Please understand this. Latitudes are full circles. Do you realize? Do you realize? Please say how to enroll. Bete, when I'll give the break, I'll tell you. There is a description link is given. Right? Where the comment section starts, there is a description link over there also. Click on that. There is a enroll. You can enroll there. Clear? Latitudes are full circles that remain parallel to each other, and it is called parallel of latitudes. Do you see here? These are parallel. Do two latitudes meet each other? Do two latitudes meet each other? No, they do not meet. Do longitudes meet? Yes, they meet at a point, but latitudes do not meet. There are full circles. They are a full circle. Yes, what are they? They are full circles. Which is the biggest circle? Right? Which is the biggest circle? Right? That is the equator. That is the equator, largest. As you keep on moving upward, the circle size will decrease. At the pole, it is just a point. At the pole, it is just a point. Right? Now, see here. Latitudes are full circle, that is why it is important, and remain parallel to each other. They are parallel to each other, that is why they will never meet. That is why they are known as parallels of latitudes. Now, let us understand. Longitudes are angular distances measured north and south of the equator. Let us see this word. Everybody see here. Let us see, supposingly this is the equator, right? And let us assume this line is, let us assume 66.5 degree north. Let us assume randomly. Let us say put it 60 degrees for the time. 60 degree. The question arises, sir, why this is called 60 degree? Understand this. Supposingly, I take this line, that is the equator, and I draw an angle here. The angle that is formed here is going to be 60 degree. That is why this latitude is 60 degree. This is what? This is what? The North Pole. It is 90 degree. Why it is 90 degree? The reason behind it is 90 degree is the angle that it is forming here with this plane is 90 degree. That is why this point is 90 degree. Did you understand that? How the latitudes are basically said to be 10, 20 degree, 30 degree, 40 degree, 90 degree. It is because of this calculation. Clear, everybody? You should know this. Done? Okay. They run east to west. How are they running? They are running from east to west. But how do you label them? North and south. This is very important. See here. I have mentioned north here. This is 0 degree. This is, let us say, 30 degree north. This is 90 degree north. Why? Though it is running from east to west, it is increasing upwards and downwards. That is why we will be putting north or south here. The ones which are below the equator, we will put 30 degree south, 70 degree, let us say, south, and the ones above the equator are put north. So they are measured in the form of north and south positions. Clear? Though they are running east and west. Clear? Done? Okay. The important thing is the distance between each degree of the latitude is around 111 kilometers. If I take two latitudes here, the distance approximately is 111 kilometers. Now please remember, this is not the exact distance, it varies. The reason is you realize that as you go close to the poles, it is more tilted in this way, so the distance will increase a little bit. So distance between two latitudes near the pole is little more than that close to the equator. Little more close to the equator. See here, at the equator it is 11.7, around the equator it is 1110.6. So the average approximately comes to be 111. You can be asked the distance between the two latitudes near the equator is less than that of the poles. Yes, it is correct. Clear? Clear? So that is an average value. This is clear? Clear? Okay. Now, there are certain notable lines. Please understand. Equator is 0 degree. Tropic of Cancer is 23.5 degree north. How has this come? Can I say this is 23.5? Can I say this is 66.5? Can I say this is 90? Yes? No, this clear hai? Clear hai? 90 degree north is North Pole, 66.5 degree north is Arctic Circle, 23.5 degree north is Tropic of Cancer, 0 degree is equator. 23.5 degrees south is Tropic of Capricorn. What? Tropic of Capricorn. Antarctic Circle is 66.5 degrees south and 90 degrees south is the South Pole. Clear, everybody? These are the important what? Latitudes. Important latitudes that you should be aware of. Now the question comes is, sir, bachche, please remember, UDAAN magazine also covers, but I have gone little bit beyond that. There are certain NCRTs of class 6th and 7th and 8th, the old ones, which basically mention about the countries through which these equator or Tropic of Cancer cut. Do you want to see them? Shall we see? And little bit numerics also, mnemonics also, how you can remember them. See, just have a look at them. In the examination, the question has been asked. In the prelims and UPSC also. Let us see if you can remember good enough. Otherwise, again, depends. Because I had remembered it, so possibly I'll help you to also remember it. Now see, whenever I talk about the equator, it divides the earth into two hemispheres, that is northern and southern hemisphere, right? Now, I have mentioned in front of you the countries to which equator cuts, right? Equator cuts. There are 13 countries that the equator is cutting, right? Gabon, Ecuador, Colombia, Kenya, Uganda, Somalia, Maldives, Kiribati, Indonesia, Congo, Democratic Republic of Congo, Brazil, Sao Tome and Principe. How you can remember that? See, मिस किरिबाती GRE क्लियर करके ब्राजील से यूके चली गई. दिस इज हिंदी नाउ प्लीज. दिस इज द वे आई कुड रिमेंबर इट. मिस किरिबाती, M, see here, M for Maldives, I for Indonesia, S for Somalia, S for Sao Tome and Principe. Kiribati is itself a country. GRE, G for Gabon, R for Republic of Congo, E for Ecuador. Clear करके C for Colombia. Brazil itself is there. SE, UK. UK में क्या आ जाएगा? U for Uganda, K for Kenya. चली, you can put here Congo गई. मिस किरिबाती GRA क्लियर करके ब्राजील से यूके चली गई. Now, rather than not knowing anything, possibly if you have read it twice or thrice, you will be able to recall it. Clear everybody? Because you know the mnemonic. If you remember the mnemonic a little bit, you will remember the countries also. Miss Kiribati GRE clear करके, GRE clear करके ब्राजील से यूके चली गई. Clear? Is it clear everybody? The 13 countries. This is what the mnemonic that is there. How to remember it. Done. Rather than not knowing anything, it is better to know it. Clear? Okay. Done. So there are 13 countries. 13 countries. Clear? Why I have added this, please remember. The reason behind it is in today's time UPSC can ask anything. Clear? UPSC can ask anything. And it is important that you do such things because see, it is the war, this UPSC is a war of, let us say, few marks only, whether you are in or out. Okay, let's see next. Tropic of Cancer. The northernmost part where sun is directly overhead, we'll see this. This is 23.5 degree north, right? 23.5 degree north. Equator crosses lakes and rivers. Beta, I will be doing mapping, where I will be telling you all those things, right? I have session of world map and India map also later marathons. We will be covering those parts over there. Clear, bache? Okay. There are 17 countries which Tropic of basically Cancer crosses. Western Sahara, China, Egypt, Saudi Arabia, Taiwan, Oman, Niger, India, Algeria, Mexico, Mauritania, Mali, Myanmar, Bahamas, Bangladesh, UAE and Libya. How you will remember this? How you will remember this? World Cup in Estonia, M4 versus Bulbul. B bull लिख लो. World Cup in Estonia, where M4 is fighting with Bulbul. World W for Western Sahara, C for China, Estonia. Please remember one thing. Estonia itself as a country is present, but you do not, it is itself not a country which is cutting Tropic of Cancer. Over here, E is Egypt, S is Saudi Arabia, T is Taiwan, O is Oman, N is Niger, I is India, A is Algeria. समझ में आया? World Cup in Estonia. Then comes M4. Mexico, Mauritania, Mali, Myanmar. M4. Bubul. B for Bahamas. B for Bangladesh. U for UAE. L for Libya. क्लियर? वर्ल्ड कप इन एस्टोनिया, M4 वर्सेस बुबुल. बुलबुल बोलना है तो बोलो, whatever, बुबुल, right? See, I coincidentally remember, I always remember these mnemonics, and these were the ways I could, people when used to ask me, how can you tell these countries which are present there? See, there are techniques I remember, but the reality was, it was the mnemonics based on which I used to remember all these things. That is why normally for a human being to remember these 17 countries, it is impossible. But when you do such things, you can remember the most complex of the concepts also. So that is why I've shared with you in front of in the YouTube channel, so that other people also can make the best use of it. Clear? Okay. Now comes Tropic of Cancer, the southernmost point where sun is directly overhead. That means 23.5 degrees south, right? Tropic of Cancer crosses. I will be creating an MCQ on this. Remember this, right? 10 countries: Argentina, Brazil, Chile, Paraguay, Namibia, Botswana, South Africa, Mozambique, Madagascar, Australia. ABC production said no boy should miss maths. ABC production said no boy should miss maths. Clear? Clear? Now see here. ABC is Argentina, Brazil and Chile. ABC is Argentina, Brazil and Chile. P is Paraguay. Clear? Clear? Capricorn, yes, yes. I said Capricorn only, beta. Tropic of Capricorn only, beta, not Cancer. Cancer was 23.5 degree north. This is 23.5 degree south, Capricorn. Okay? Capricorn, 10 countries over here. It is cutting 10 countries or crossing through 10 countries. Clear? Okay. A is Argentina, Brazil, Chile. P for production, Paraguay. N for Namibia. B for Botswana. S for South Africa. M Mozambique. Maths में MNA, Madagascar, Australia. Clear? Clear? Exactly. Everybody clear? Clear? So this is Tropic of Capricorn. Done? Let's move ahead. Arctic Circle. Now, this is very interesting. Question on Arctic Circle, UPSC asks after every few years in order to test the candidate. Now, it is 66.5 degree north. Now, what are it cuts through 8 countries, because this is one of the very important topics for UPSC. Why? Because of melting of the ice, because of the disputes that are coming up, the Arctic Circle concept is relatively more important here. So, you should know this. Greenland, Finland, Iceland, Sweden, Norway, Canada, USK, that is Alaska part of USA is cutting. So, not the complete USA, Alaska part, and Russia. See, green fish, green for Greenland, F for Finland, I for Iceland, S for Sweden. F, the ones which are capital are the ones which are mnemonics, right? Green fish went to Norway by car. C for Canada, A for Alaska, R for Russia. Green fish went to Norway by car. So you will remember when we were talking about Arctic Circle, Greenland, yeah. Green fish went to Norway by car. Green for Greenland, Finland, Iceland, Sweden. N for Norway, car is Canada, Alaska and Russia. Clear? Clear? Okay. Now, Antarctic Circle, you know, it is not cutting any country as such. It is just the Antarctic continent, so we do not have any countries over here. 66.5 degrees south. Clear? Okay. Now, let us see Tropic of Cancer, whichever places or states it cuts in India. This can also be asked, though I will be covering this in Indian geography. But we can, because we are doing Tropic of Cancer, let us cover it. Tropic of Cancer is cutting. Tropic of Cancer is cutting how many states? 8 states. Gujarat, Madhya Pradesh, Chhattisgarh, Jharkhand, West Bengal, Tripura, Rajasthan and Mizoram. All these states are being cut by the Tropic of Cancer in India. So you should be well aware. Now let me see it in this way, right? Let us see this. Maitri Bharti beta, when we will be doing the world mapping thing, which I will be doing a marathon, over there I will be doing all those things. I'll be doing the parts of Antarctica also, so don't worry. Now see, these are the 8 states through which the Earth is, the Tropic of Cancer is cutting the Earth, the part states of India. Clear? Gujarat, you have Rajasthan, you have Madhya Pradesh, you have Chhattisgarh, you have Jharkhand, you have West Bengal here, and then you also have Tripura and Mizoram. Clear? Now, important thing over here. These are the points, or let us say, you can say, take it as the capital also of all these states. Beta, do you realize something over here? Very interestingly, what UPSC can ask you. One thing is UP can ask you which among the states are basically being cut by the Tropic of Cancer. These are the points, right? These are the points. But they will ask you, they can ask you these states, these cities also. This is mentioned in your NCERT ka map that is there. It is also mentioned in UDAAN. What do you notice here? Jaipur is what? Jaipur is what? It is located in Rajasthan. Rajasthan is being cut, right? So UPSC will not ask you random questions. It will ask you, among the following cities, which city lies above the Tropic of Cancer? Now see here, everybody. If I ask you a question here, which cities lie, let us say, above Tropic of Cancer? So first is Jaipur, I put. Second is, I will putting, let us say, Ranchi. Third, I have put Agartala. Fourth, I have put Kolkata. Fifth, I have put Aizwal. Right? Option A. Right? Option A is 1, 2, 3 and 5. 3, 4, 5. Let us say 3, 4, 5. B is 1, 3, 5. C is 1, 2, 3, 5. D is 1, 2, 5. 1, 2, 5. Tell me what is the answer here. Which cities lie above the Tropic of Cancer? What is the answer here? Above the Tropic of Cancer. We have Jaipur, we have Agartala, we have Aizwal, right? Okay, 1, 3 and 5. Most important observation is Ranchi lies on the Tropic of Cancer. This is a unique feature of Ranchi. I had asked above. Had I asked which among the following cities lie on or above the Tropic of Cancer? If I change the question, please remember, if I change the question, which cities lie on or above the Tropic of Cancer, Ranchi will be included in that. Ranchi lies on the Tropic of Cancer. This is a unique point over here. Remember that always. If in this question they change it to, which cities lie on or above the Tropic of Cancer, then you have to include Ranchi because Ranchi lies on Tropic of Cancer. Clear, everybody? Everybody clear? Okay. Another question that they can ask you, which among the following cities are the southernmost? Is the southernmost? Do you realize out of these, Raipur is the southernmost? Northernmost is Jaipur. This is in the map that you need to observe. This is known as map study. I'll be doing in the India map also, don't worry. Clear? Clear? Countries, that is what I'm doing. Whatever we are doing, that is more than sufficient, right? Clear? Okay. Chaliye, let us see this once more. All the concepts clear? Are the concepts clear? Okay. Now, Generally, when I show you this photograph, you see Earth in this format, right? You assume that Earth is rotating like this, right? You know that this is not the truth. Earth is not in this state. It is tilted, right? See here. Earth is not rotating in this state. It is little tilted and then rotating. See here. We assume that Earth is like this and it is rotating like this. No, it is tilted and rotating like this, right? Clear? This is known as the tilted axis of the Earth. Tilted axis of the Earth. Now, this axial tilt is 23 degrees 44 minutes. This shows the axial tilt of the Earth. Clear? So the pink line which you are seeing is what you generally see in your books or just to teach small kids and all, but the actual tilt is this. This is clear? Okay. Now, you know that very well because of this tilting of the axis. You know that you have a lot of solstices and all. Now see, come here, everybody. A very interesting question that I'm going to ask you. Everybody, listen to this. Is a trick question. Though the answer is not directly given here, you will be getting the answer as I move ahead. Everybody see, this is the time when the Earth is tilted like this, right? Do you realize this is 21st June? On 21st June, the sun rays are directly on the Tropic of Cancer. Can I say this? What is this? This is Tropic of Cancer, this is equator, this is Tropic of Capricorn, this is Antarctic Circle, this is Arctic Circle, right? So the sun rays are directly on the Tropic of Cancer. Agreed? Agreed? Right? Clear? Quickly tell me. Is this clear? Because had Earth not been tilted, directly it would have been on equator, but it is tilted like this. So the distance, so this region tilted over here means this region, Tropic of Cancer, is closer to the sun rays. Agreed? This, when the sun rays are directly on the Tropic of Cancer over here, we call it as a summer solstice, which is on 21st June. That is why on 21st June, in the northern hemisphere or close to the tropic, in the northern hemisphere, you experience the longest day also. Clear? Let us see the reverse condition. Over here, this is Tropic of Capricorn. This is equator. This is Tropic of Cancer. This is Arctic Circle. This is Antarctic Circle. During the time of the winter season, which let us not call it winter, during the time of December. Okay? During the time of December. Do not mug up. Remember this. Do not mug up. If you mug this up, you will never be able to understand this. I will repeat it again, don't worry. You do not have to mug up. Understand. Please remember, you can not mug up everything in the world. These are basic concepts. I have used the same diagram that I have drawn here. This same diagram, I have minimized it and put it here. There is nothing new. Do you realize this? This is the diagram which I have put here. This is the same diagram that I have put here. Nothing new. See here again. Arctic Circle, Tropic of Cancer, Equator, Tropic of Capricorn, Antarctic Circle. What I am doing here? Arctic Circle, Tropic of Cancer, Equator, Tropic of Capricorn, Antarctic Circle. Same thing. So, the direct rays are on Tropic of Capricorn. Clear? This is known as winter solstice, which is 22nd December. 22nd December. Now, please understand, are these two diagrams on summer and winter solstice, are these clear first of all? Quickly tell me. Are the summer solstice and winter solstice clear to everybody? Anybody who hasn't understood? Clear? Now, first of all, I will answer all those things. First of all, have you understood what are the naming? I'll explain you. What are the namings? I'll explain you. Is this clear? Is this clear? Okay, now see here. When I say summer solstice, it means during that time, See, we are talking with reference to northern hemisphere. Now, please tell me, I will answer this also, please understand. 21st June, I have said summer solstice because it is summer in the northern hemisphere. When I'm saying winter, when I'm talking about winter solstice, it is winters in the northern hemisphere. What is the reason that the naming has been done according to the northern hemisphere, not according to the southern hemisphere? Can anybody, have you noted this? You know that if it is summer in the northern hemisphere, it is going to be winters in the southern hemisphere. If it is winter in the summer, if it is summers in the southern hemisphere, it is going to be winters in the northern hemisphere. You know that. But the naming has been done according to what? The northern hemisphere. Do you agree to this? Have you noted this fact? On 22nd December, it is winters in the northern hemisphere, but summer in the southern hemisphere. Yes. Australia celebrates Christmas during the summer time. The reason behind it is that majority of the population and the land is in the northern hemisphere. So conventionally, they have emphasized the naming has been done based on the northern hemisphere because majority of the population is in the northern hemisphere. Southern hemisphere is majorly comprised of water. Okay, we have certain countries like continents like Australia, Antarctica also, and New Zealand, but again the population is relatively very less. That is why we follow the convention of the northern hemisphere. Did you understand this? Clear? Because many people would have thought why it is named in such a way. Okay. Very interesting thing. If anybody answers this, then I think possibly you have your basics correct. Okay. Please understand, you are all living in northern hemisphere, right? We will be doing the point which I am going to explain you after some time, but I want to ask you before I have explained you. Okay. The distance between the earth and the sun, let this distance be S, let this distance be W. Tell me one thing, just tell me this. Earth is closer to the sun during the summer solstice or during the winter solstice? Can anybody tell me the value of S is more or value of W is more? Let this be distance in kilometers. Use your common sense and tell me. This is something that is mentioned in UDAAN magazine. This is mentioned in NCERT, right? If statement comes, S is larger than W, this statement is true or false? Okay, some are saying S is more, some are saying W is more. Come on, tell me. Let us see how many of you have read this or have observed this or know this. Okay, now let's answer this. Please remember, the irony over here is that during the time of the summer solstice, the distance of S is much more than W. Note this very well. During the time of the summer solstice, the distance between the sun and the moon, this distance is much more than this. Why? Please understand. This is how nature has created it. Why? During the summer time, when the sun is facing directly over the tropic of Capricorn, the distance is more. That is why you are able to survive, because majority of the population is also living in northern hemisphere. If the distance would have been less, the temperature would have been very high. That is why in the northern hemisphere there is no extremes of summers and extremes of winters. The distance S, that means when it is over the tropic of Capricorn, the distance is more. Please remember, I'll tell you how. Earth is not in a perfect shape. The shape is like this. Do you realize this? Please see this. The shape is like this. When the earth is over here and when the earth is over here, this is the elliptical orbit that you have. It is not a perfect circle where you are moving. That is why, do you realize Australia has extremes of climate? It has extremes of summers, climatic condition also, and winters also. But northern hemisphere experiences relatively stabler environment. One aspect is tilted axis, another is the elliptical concept, which we will be doing after some time, right? Okay, this is one thing that is again UPSC has asked people in their examination. So remember, that is why northern hemisphere, though having summer, does not have extremes of summer, because the distance between the sun and the earth is much more than in case of W. Clear? Okay, doesn't matter. I will explain this when I will be doing the concepts. Aage bhi, don't worry. I'll be explaining you. Okay. During the time of 21st March and 23rd September, the sun rays are directly on the equator. So these are known as equinox. Equinox means equal night, equal day. Equal night, equal day means because the sun rays are directly over directly over the equator, so the days and nights will be equal. Similarly, over here also it is directly over the equator. That means 23rd September and 21st March are equinoxes. Equal day, equal night. During the winter solstice, the day will be longest in the southern hemisphere, the day will be shortest in the northern hemisphere. Agreed? Here on 21st June, the day will be longest in the northern hemisphere because directly over the Tropic of Cancer. It will be shortest in the southern hemisphere. Clear? Everybody clear? Okay. There is no perfect equinox. Obviously, we know that, right? We obviously know that. It is simply, again, everything is not perfect. When I have made this diagram, you know, I have not considered the elliptical position, right? We cannot put everything in one diagram. We have to explain one by one, na? Then only you will understand. Okay. Now comes longitude. Is the latitude clear to everybody? Everybody, latitude clear? Okay. These are semicircles of equal length and they are farthest apart at the equator and closest as they meet closest during close to the poles. See, latitudes are what? From North Pole to South Pole. These are lines which are running. Why are they semicircles? Because one point to other point, on the other hand, there is another circle behind them. So they are farthest away at the equator, closest at the poles. So they are not full circle, first of all. They meet, right? They always meet. They are closer to each other at the poles and farthest away at the equator. These are longitudes. Clear? Now, this is what? See, longitude. This is what? Longitude. This is what? Longitude. Clear? Now, let us understand how the degree is calculated in the longitude also. Now, see here. Please remember, the 0 degree longitude is called the prime meridian. What it is called? Clear? I will be doing perihelion, ephelion, all of those concepts will be explained. Then I will explain again the concept of summer and winter solstice, because right now I am not doing that. I will be covering that point. Don't worry. Clear? See here. This point, till this point, this 0 degree is known as the prime meridian, which is taken as a reference point through which you basically study the longitudinal concept. Clear? Everybody clear? Now see, there will be certain longitude will be on the west of it and certain longitude on the east of it. Can I say this is 0 degree, this longitude is on the east of it, whatever be the angle? Let us say if I say this is 10 degree on the west east of it, so can I call it 10 degree east? Can I call it 10 degree east? The longitude which is on the west, can I call, let us say this is 10 degree. Can I call it 10 degree west? Can I call it 10 degree west? Clear? Yes or no? Yes or no? Clear, everybody? I told you how the angle is calculated in the latitude. But do you want to know how longitude is also calculated? Do you want to see this? See here. supposingly, for 2 minutes, let us assume, let us assume, this is a prime meridian, 0 degree. For 2 minutes, let us assume this is a prime meridian. Clear? And this is supposingly, let us assume 30 degree west of, let us say 60 degree west. This is a center of the earth. Right? Can I draw a line to the center of the earth and then let us say draw a line over here? The distance, this angle between them is known as the longitudinal angle, which is 60 degree. That is on the west of it. If I am taking this line as a prime meridian for 2 minutes, this line is 60 degree west, right? So this is 60 degree west because if I draw a straight line to the center of the earth and then draw a line over here, the angle between both of them is going to be 60 degree. Did you understand? This is the interior. I'm taking it to the interior. Clear? Yes or no? Clear, everybody? Is this concept clear to everybody? How I have calculated the degree of longitude? Everybody, quickly tell me so that I can move ahead. Quickly, clear? 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 Do you realize the length of, see please, we'll talk about the length just a minute. Do you realize this whole, how I've calculated it? Anybody has any problem here? Yes, arc, absolutely. See, if you take an apple and you take a cut inside and take out a piece, that angle is basically what? Longitudinal angle, right? Clear, everybody? Okay. Now, you should understand one thing. One more time, okay? So let us take an example. See, I have a makhana which I cannot basically, today this is the surface. This is supposingly the core, let us say. Core hai ye, theek hai? This is the surface. This is 0 degree, that is longitude, that is prime meridian. I want to know what is the degree of this longitude, right? I draw a straight line to the interior. From there, I draw a direct line which connects this. The angle between both of them is known as the longitudinal angle. Clear? If I had an apple, I could possibly use this, right? Clear? Yes? Okay, yes. Now, please understand, prime meridian is 0 degree. A line that is exactly opposite to 0 degree is the international date line. Please understand, everybody. Please see this. This is a map. If I fold this map into a globe, the line exactly opposite of international date line, the line exactly opposite of the prime meridian is going to be international date line. That is 180 degrees. What? 180 degrees. Clear? Everybody, the line which is opposite to prime meridian is known as international date line. Now you know that very well. I'll be explaining you that longitudes are very, very critical for calculation of the time or time zones or time of a place, right? That is why if you realize any longitude on left and the right side is present, there will be variation in the time. So international date line is not a straight line. All other longitudes are straight. That means touching from north to south, they do not curve here and there. But international date line is twisted and turned. Why? Because if supposingly there is a country which is lying on, let us say, east and west of the international date line, there will be variation in the day, right? Variation in the day. So that is why it is curved in such a way that there is no time variation in day within a country also. So in order to have a proper time management, it is zigzag. Like for example, let us assume there are certain islands here. Now over here, there will be some other day, there will be some other day over here. So to avoid that, they have created a zigzag line. Clear? Understood? Okay. Prime meridian passes through Greenwich, London. It divides the earth into eastern and western hemisphere, right? International data roughly follows a 180-degree meridian. Crossing this changes a calendar date by 1 day. That means when you cross this, right, to avoid variation in a day, to have a proper time zone, that is why it is zigzag. Now the question will come in the examination, which all countries are cut by the prime meridian? This can be asked. So it is Burkina Faso, Spain, France, Ghana, Algeria, Mali, England, Togo. BSF game in Togo. Can you remember this? BSF game in Togo. BSF is Burkina Faso, Spain, France, Ghana, Algeria, Mali, England or Togo. Clear? Clear? Can you remember this? BSF game in Togo. So you will be remembering all of them. Okay. Now please remember, there are certain rules which you need to understand for the time zones. Time zone and time zone calculation. See here. Over here I have drawn this. Why? Because if I fold it, international date line, like this is for example, the prime meridian. This part and this part, if I fold it, in the back is international date line. So if I draw over here, it is just one and the same thing. On both sides I have drawn, because when you fold it, it is globe. It will meet at the same point. Earth rotates anti-clockwise direction, that is from west to east. From west to east. Clear? Done everybody? Now see. One full rotation, please tell me, is 360 degree. Understand this. Anybody having any problem to let me know. One full rotation is how, what is a degree? 360 degree in 24 hours. So in a way, can I say the earth is rotating 15 degree in 1 hour? Can I say earth is rotating 1 degree in 4 minutes? So can I say the difference between between a degree change is 4 minutes? A time difference between this longitude, let us say, and this longitude. Let us say this is 10 degree longitude, this is 11 degree longitude. There will be gap or difference of 4 minutes. Can I say this? 1 degree change is equal to 4 minutes. Have you understood this? Have you understood this? Now see here. As the earth rotates eastwards, the places in the east experience sunshine before the west. Let us assume this. Everybody see here. As it is rotating anti-clockwise, now see here, supposingly there is a place here. There is a place here. Let us say chalo India. And let us say New York. Now this is 82.5 degree, let us say east. This is, let us say, whatever, 60, 70 degree, whatever, degree west. Can I say the sunshine will be experienced on India before it goes to this part? Why? Because the way earth is rotating, as earth rotates eastwards, the east region will experience sunshine before any region that is west of it. This is very, very important. Very, very important. That is why, do you realize sunshine in Arunachal Pradesh is prior to that of Gujarat? How you need to remember it? See, Arunachal Pradesh experiences sunshine before Gujarat. That means eastern part is going to experience sunshine before the western part. Can you remember this? So any part which lies west of any region will experience sunshine after the eastern wala region. So can I say this is, let us say, this is, let us say, 10 degree east and this is 15 degree east. Can I say this will experience sunshine before this region? So can I say this will be few minutes or whatever the distance ahead of this time? This region, this 10 degree east will be ahead of this time? Yes or no? Because पहले सनशाइन हो रही है, सनशाइन इज कमिंग पहले, so the time will be ahead. The moment you go up, please understand this, though it is east written, but it is west of this latitude, longitude. Please understand, both are written east, but relatively if you see, 15 degree is west of 10 degree, na? Yes or no? Let me take an example. If supposingly it is 10 degree east, it is 1 p.m. right? 1 p.m. Clear? What is the gap between these? 15 minus 10 is 5 longitude, or 5 degree. What is 1 degree? 5 into 4, 20. Can I say 20 minutes? Can I say, क्या होगा आंसर? This will be 20 minutes behind, yes or no? This will be 20 minutes behind, yes or no? If it is 1 p.m. here, this region will have what time? Anybody can tell me? You will have to reduce 20 minutes from 1 p.m. So this will be 12:40. 12:40? Yes, 12:40 p.m. because sunshine is early here. So this, if you go west, what will happen? That region is behind the region which is here. So moment you go west, you will minus the time. If you go towards the east, you will add the time. Can I say this? Can I say this? Everybody, this is very, very important. I will be doing certain questions. Don't worry. Those who haven't understood, I'll explain it again. Don't worry. 360 degree, 24 hours. 15 degree, 1 hours. 1 degree, 4 minutes. Clear? Okay. Now, important thing is, adding to this, 0 degree longitude, which is the prime meridian, is taken as a standard point. Is taken as reference. If you are calculating a time for a region which is relatively east, you add time. If you calculate with respect to west, you subtract time. How you have to remember? Arunachal Pradesh is in the eastern part of India. Gujarat is in west. See, we have kept one time zone because the reason is that it was discussed that we should not have time differences. Otherwise, in various countries, you have time differences. Clear? We have taken 82.5 degree east as a standard time zone. So for India, everywhere the time is same. But you know that in other countries, that is not the same, right? So there is sunrise in, let us say, in Arunachal Pradesh is different from this. Let me ask you a question now. Okay. Everybody, can I ask you a logical question? Let me ask you. Okay, let's see. -90 is the time is 3 p.m. What is the time at 100 degree east? Calculate the local time, sorry. Calculate the local time. Calculate the local time quickly. Calculate the local time. Okay. First of all, you need to understand when I said local time, that means the time that is accepted by that region. Do you realize both the longitudes are lying in India? So if there is 30, if it is 3 p.m. at 90 degree, it is going to be 3 p.m. at 100 degrees also if I calculate the local time. Yes or no? Tell me. I did not say time. I said local time. The difference between time and local time is time over here refers to longitude. Local time means what people accept it. Indian Standard Time is a local time for India, right? So 90 degree is in India. It is 3 p.m. here. 100 degrees also in India. It is also 3 p.m. there. Just now I told you Arunachal Pradesh and Gujarat. There is a... Do you realize how I asked you this? See, I told you. I asked you, I specifically wrote local time. Local time means what? What is accepted by the people, right? I did not ask you time. Had I written time, then it would have been different. Okay? Do you realize the type of mistakes possibly you people are committing? Prank ho gaya. So, if it is right now, if I see the watch, it is 1 p.m. It is 1 p.m. in Kashmir. It is 1 p.m. in Arunachal Pradesh. It is 1 p.m. in Gandhinagar. It is 1 p.m. in Andaman Nicobar Island also. Yes? And these are questions which you should be very well aware of. ठीक है? और जो जिन्होंने 2:20 बोला है, चलो कोई नहीं. And so what is required in the civil services? The requirement of civil services is not that you should rectify things or rote learning. You should be smart enough what the question is being asked. Clear? Clear? UPSC can very well ask you as one of the statements. What they are testing, first of all, they will test the longitudinal span of India and then all these things also. Okay, let's move ahead. So see here, Indian Standard Time, which is taken as 82.5 degree east. That means we have accepted this longitude as a standard for the complete country, right? For the complete country. Now tell me one thing, 82.5 degree, can I say it is how, if I say 82.5 degree east, this is what? 82.5 degree east. Can I say the time difference between these two will be 82.5 into 4, which will be 330 minutes, which is 5 hours 30 minutes. Can I say the distance between the time difference between London and India is 5.5 hours? Right? Practically there is a difference, exactly. But UPSC has tested this candidates once and twice in the previous years. That is why, please remember, UPSC is also very particular when it asks the question. They ask you question based on time differences of US with India and all. So that is why, please be very careful. I said local time. What does local time means? The time of that region. That is why every single word of English that is mentioned here becomes critical for you. Okay, anyhow. Can I say that means, first of all, it is in the east. So can I say it is ahead? So if it is 1 p.m. at the prime meridian at the Indian Standard Time, can I say it will be 6:30? 6:30 p.m. Can I say this? Yes or no? Okay. Till now, nothing important has been taught. Hope better coming. बच्चे फिर पता what happens is possibly when we realize that possibly other candidates are preparing well for the civil services, possibly some are not. Mr. Tambu, then I can obviously say this, right? When we see comments, we can obviously say then only some people are preparing for civil services properly. Some people like Tambu are not preparing properly. Okay, right? That is why I say why some people qualify and some do not. Right? So remember one thing, if you want to learn, you can learn from anybody. Right? If you do not want to learn, you can learn from nobody. Clear? So always remember this. If you are here to gain knowledge, open hand, we are there to help you out. If you do not want to gain knowledge, you will not gain from anybody. And the unfortunate part or the part is that these questions which I have done till now, these have been asked in civil services examination. Possibly you have never seen civil services previous year questions. Possibly you haven't gone that. Possibly you need to a little bit work harder for the civil services examination, and possibly you can do well in that case. Possibly you can then qualify. Right now, then you need, possibly you're not aware of the previous year questions also. So, okay. Anyhow. Okay, now let us see, because I'm doing this, so I'm going to Indian Standard Time. This is 82.5 degree. It passes through Mirzapur, right? It passes through. Indian Standard Time is a local time for us, bache. Indian Standard Time is our local time. Clear? Okay, chale. Spammers come, don't worry. See, we are very happy that spammers specially come for us to spam us. We are so happy that they take out time from their prestigious time of their studies. They specially come and they specially take out time and comment. I love it. Bache, please come and do this. There is no problem, right? Indian Standard Time is a local time for our country. Clear? Right? Okay. 82.5 degree is Mirzapur. It is close to Allahabad or Prayagraj, but it is not actually Prayagraj. So it exactly is Mirzapur. Right? Just a minute. Right? So Indian Standard Time, please, it crosses through UP, Chhattisgarh, Madhya Pradesh, Odisha and Andhra Pradesh. Right? What are the 5 states through which it passes? What are the 5 states in which it passes? Uttar Pradesh, Chhattisgarh, Madhya Pradesh, Odisha and Andhra Pradesh. One more thing, it does not pass through Telangana. It does not pass through Telangana. The reason behind it is many people think that this stat is old, it might be passing to Telangana. It does not pass through Telangana, only through Andhra Pradesh. Clear? Clear? Okay, chale. Okay. Can we do some previous year question, previous year plus certain MCQs? Chalo. I will remove certain answers. Wait a minute. Give me a minute. Give me 2 minutes. Okay. Can we start with the MCQ for this session? Clear? Clear? Can we start? Everybody? Chaliye. Can we start? First, you have to give me the answer. Clear? You have to give me the answer. Which of the following is correctly describing the Big Bang theory? Proposed by George Lemaitre, right? Universe originates from a singularity of infinite density and temperature. The expansion of the universe has stopped at present. This and this. What is the answer? Everybody. Now, let us please, rather more than the answer, you should understand which is not the correct answer so that you can eliminate. How does elimination techniques work? See here. See, if you read the statements, let us assume, please see here, assumingly you do not know whether it was proposed by George Lemaitre or not. It is quite possible that you do not know. The expansion of universe has stopped. Now, this stopped is a wrong statement. The moment I've eliminated 3, can I eliminate these 2 options? This is eliminated, this is eliminated. Now, even if I do not know George Lemaitre, I know one thing, that 1 is present in both of them. So it has to be correct. That is why I'm saying that it is not necessary that you need to know this. That means this is correct by default. I do not have to worry about it. Clear? It originated from a singularity of infinite density and temperature, which we have already taught you. So this is correct. So that means 1 is correct, 2 is correct. So that means A, 1 and 2. Can I see the answer? 1 and 2 only. Clear? Clear? So let us move to the next MCQ. Okay. Terrestrial and Jovian planets. Clear? Let us see. Statement with respect to terrestrial and Jovian planets. Terrestrial planets are smaller and denser. Let's see. Terrestrial planets are smaller and denser, they are saying. Okay. Jovian planets are mostly gaseous and have rings. Okay. Terrestrial planets formed farther from the sun than the Jovian planets. Okay. What is the answer for this? What is the answer for this? Quickly. Let us see how you get these answer correct or not. Okay. Okay. Let's see. Terrestrial planets are smaller and denser. You know that all the terrestrial planets were smaller in size and denser. So this statement is correct. Now let us see. Jovian planets are mostly gaseous and have rings. I have told you the 4 planets, most of them have rings. So that is correct. And they are mostly gaseous. That is also correct. Okay. Terrestrial planets are farther from the sun. No, terrestrial planets are closer. So this farther statement is wrong. I know wherever 3 is, it is wrong, and I already know 1 and 2 are correct. So A. Can I see the answer? A. 1 and 2 only. Clear? 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 Okay. Do the next question. Okay. Next question. Latitudes. Consider the following statement regarding latitudes. Clear? Clear? Okay. Latitudes are full circles parallel to each other. Okay. They are measured east and west of the prime meridian. Distance between 1 degree of the latitude is approximately 111 kilometer. What is the answer? See, latitudes are full circles. Yes, they are parallel to each other. That means correct. These are east or west of the prime meridian? No. North and south of the equator. This second point is for the longitude. So this statement is wrong. Distance between 1 degree is this much. Okay, it is fine. So 2 is wrong. So what we can do? Eliminate. Answer is A. 1 and 3 only. Clear? Okay. Consider the following about the Indian Standard Time. Indian Standard Time is based on 82.5 degree longitude. It passes near Mirzapur. It is 5 hours ahead of GMT, Greenwich Mean Time. What is the answer? Quickly write it down. What is the answer? Quickly, quickly, quickly. What is the answer? Most of you have written D. Okay. This is correct. Passes near Mirzapuram. Is this fine? Do you realize one thing? It is not 5 hours. It is 5 hours 5 hours and 30 minutes. This statement is wrong. See this. So this statement is wrong. These are correct. These two correct. This is wrong. So answer is B. This is what I have said. 2 correct. This wrong. Please remember, these are standard times. 5.5 hours I had calculated in front of you. Where is 5.5 hours? 5 hours 30 minutes. Clear? With respect to the evolution of the atmosphere, let us see this. The first stage of the atmosphere is mainly composed of hydrogen and helium. Primordial atmosphere was lost due to similar question has come I think 2 to 3 years back in the civil services examination also. So all those who think that these questions are not relevant, possibly civil services is not for you. So please focus, all those who are serious enough, solve these questions, right? Okay. The present atmosphere was basically formed due to degassing of the Earth's interior. What is the answer? Anybody? This statement is composed of hydrogen. Correct. Lost due to solar winds. Yes, we know it was lost due to solar winds. Second thing you need to understand is, yes, photosynthesis is contributed, but major contribution was done during the time of farting of the earth. That was degassing. So this statement is also correct. So the answer should be C. Clear? Okay. C is here. Degassing was a major contributor, further modified by photosynthesis. Clear? Okay, next. A place is located at 40-degree longitude. Clear? Sir, North Pole and South Pole latitude point are full. Beta, latitude is यूं. ये नॉर्थ और साउथ मूव करती हैं, बट नॉर्थ पोल से साउथ पोल इज लॉन्जिट्यूड. दैट इज वाई इट इज ईस्ट एंड वेस्ट. Understood? Okay. A place is located at 45 degree east longitude and place is 45 degree west. If the local time at A is 10 a.m., what is the time at B? Clear? What is the time at B? Calculate this quickly. So first, Lakshya has done. Good, Lakshya. You quickly attempted it. Okay. Quickly. Give the answer. A, B, C, D. What is the answer? Sama Singh 10 a.m. Sama Singh. Chalo, let's see. Whenever it is eastern west, you can draw like this. Let us say this is 0 degree prime meridian. Can I say this is 45 degree east? Can I say this is 45 degree west? Yes. Now, if you see the difference between both of them, what is the difference? From here till here, if you have to come, 45 plus 45, can I say 90 degree difference is there? Can I say 90 degree difference is there? One thing. A is located at A. So this is the place where A is here and A has 10 a.m. Clear? Now, I have to calculate what is the degree difference between both of them. So if you have, please understand, if you say we are in 2026 and if I say 100 BC, so you have to go from 2026 to 0 and then you have to go to 100 BC, na? Similarly, you have to calculate here also, right? So, degree difference in the degrees is 45 plus 45 is equal to 90 degrees. 90 degree is equal to 369. Time difference is 90 degree. 1 degree is 4 minutes. 360 minutes. 360 minutes can be in hours. How much? 6 hours. Can I say it is 6 hours difference? If this is on the east, this is on the west, can I say you have to subtract time if you go towards the west? So if this is 10 a.m., I will subtract 6 hours from it. If I subtract from 10, see here, watch is here. This is, if it is 10 here, I subtract 6 hours here, will it be what, 4 a.m.? So can I say the answer is 4 a.m. here? What is the answer A? Can I see the answer? 4 a.m. Did you get it how I have done? Understood everybody? This is how you do the calculations. You have to calculate the difference first. Similarly, I will be going towards the earth. Now I'm going towards interior of the earth in next part. Over there also we'll be doing all the P waves, S waves, earthquakes concept, all the dimensions of the earth, and then again I will be testing you on the questions. Hopefully you are enjoying how I'm putting the questions. This is a knowledge here that you need to have, right? And once you have this knowledge, I'm telling you, you will be able to qualify this civil services preliminary examination properly. Clear? Let me make it 20 minutes. Okay, 20 minutes. 20, see, because of the numericals we are doing, I'm putting degree over here also. Clear? So be with me. I will be there after 20 minutes and then we will be continuing with the chapter. We are here till night. Don't worry about that. With you to complete all these parts. Okay. Certain parts will take more time. When we go to the parts of oceanography, climatology, that will not take much time. Clear? So 20 minutes, after 20 minutes, we will be meeting here again. Okay. God bless you. Take care. We will be meeting. Hello, hello, hello. Hello, everybody. Am I visible again? Chaliye, let's begin. Continue with the session. Okay. See, in the previous lecture also, when we were doing right now, we just solved the question, right? Remember one thing, in preliminary examination, having the knowledge is again important. Along with it, it is also important that you are able to solve the questions. See, resources for every candidate is the same. The NCRTs, the standard books like the UDAAN magazines and all. The difference is how you use them. What I am trying to do right now is that I'm trying to tell you how you basically use that knowledge while implementing them, right? So my request would be that while you are doing this content, make sure that you solve the MCQs as I am doing with you. When you solve them, you get to know the art of solving the multiple choice questions. Clear, everybody? Clear? Okay. Okay. Let's begin. When I talk about the Earth's interior, please understand, again, the important dimension is when we talk about the Earth's interior, what is the Earth's interior? Now, the mystery of what lies inside the Earth's interior is something that has basically people have been very curious to know. Like, we cannot dig and go inside the Earth's interior manually. Like, if I keep on drilling, let us say some mine and all, you can go beyond to till certain kilometers because you know the temperature keeps on increasing. As the temperature keeps on increasing, then it becomes very difficult to further mine. Now, there are other ways, direct ways, indirect ways to know what could be the possible aspects through which what is present inside the Earth. So there are sources, direct and indirect sources. These have been asked in the examinations also and in the preliminary exam. So let us see this. Sources, direct sources and indirect sources. We will be doing one by one. Deep earth mining, drilling, surface rocks and volcanic eruptions. I'll be explaining it, don't worry. These are the direct sources. Indirect sources, if you realize, temperature, pressure variation, meteors, gravitational anomalies, magnetic field, and seismic activities. Now, these are direct and indirect sources which are present in your books, UDAAN magazine also, NCRTs also, and UPSC has repeatedly asked also. Let us study them one by one. Now, if I talk about the direct sources, see, deep earth mining and drilling. Now, you know that very well. If I am drilling and mining, the type of rocks that I study and get, I can understand what is basically present in the Earth's interior, right? So it reveals the nature of the rocks. What type of rocks are present? If you see, 12-kilometer deep hole is mined at Kola Peninsula. Now, this mine, though we have mined for 12 kilometers, going beyond that is again technically not possible also with the available technology. So till here what we know is that, okay, these types of rocks are present. So we get to know about brief idea about the types of rocks, right? Okay. Now see, surface rocks. When you go or visit any place, you see various types of surface rocks. So based on that also, you get to know, again, these types of rocks are present on the Earth. Possibly similar types of rocks can be present in other regions also. Volcanic eruptions. Now you realize that when due to the magmatic activities and the lava comes out, you even understand that, okay, these are the possible minerals that are present inside the Earth, right? Present inside the Earth. So based on these are direct sources because you can directly perceive them, understand them, see them. But these are not 100% correct because they give a limited amount of information, right? When I'm drilling, I'm only able to get to know about this constitution or composition within certain kilometers only. Surface rock which is present on the surface. What is inside, deep inside? Am I able to understand? No. No. So these are the three direct sources. Now let us see the indirect sources. Temperature and pressure variation. Now see, you know that temperature and pressure variation, every state of matter has a different ability to, let us say, be hot and cold based on the characteristics. So certain temperature and variations can also help us to understand what are the state of matter that is present inside the Earth, because we try to plot the charts and identify, we'll be understanding that also. Now, when I mentioned meteors, now you know that very well. What are again meteors, meteorites and meteorites? Tell me one more thing again. Meteors and Meteorites. Rights, do you remember why? Because you talk about right when you're on the surface of the earth. Certain meteoroid again hits the surface, and based on that you realize there are certain remains of that meteoroid that is present. Now, though it is not a part of the earth directly, indirectly possibly we imagine that okay, when the solar system and the universe was formed, we assume that it is formed from a singularity. So possibly these are the minerals that are present in the other parts of the universe. So possibly such minerals can be present in the earth also, right? Such minerals can be present in the earth also. So that is why it is an indirect source. Clear? It is an indirect source. Clear, everybody? Next thing comes gravitational anomalies. Variation in the gravity. So over here, please understand, gravity is stronger near the poles. It helps to understand the distribution of material in the Earth's crust. What type of material is present in the Earth's crust? So based on that, you realize that there are variations in the gravity also. So what possibly might be present in certain regions? Why the gravitational force is present stronger in some regions? So you get to know about a brief idea. Okay, certain type of minerals and metals might be present in some regions, right? So gravitational differences can also be indirectly helpful. Magnetic field. Now, magnetic surveys reveal the information about the magnetic materials present. Now, magnetic material depends. Now, please understand. When you see when we talk about the magnetic field, that means there are certain magnetic materials might also be present. So that means certain magnetic minerals might be present inside the interior of the earth. So that is also again useful for understanding. Next is seismic activities. Now this is the most important among all. Seismic waves are the crucial source of information for the earth's interior. Now please remember, among all the direct and indirect sources, seismic waves, this point is the most important. This is again those points which again give us a lot of evidence what type of composition or what type of minerals or what type of state of matter is present inside of the interior of the earth. And for this point, you need to go a little bit into more detail. Have you all understood a little bit about direct and indirect sources? Now, this is generally when you read about the UDAAN magazine or you read the NCERT or the standard books, they will be mentioning this in little bit, let us say brief only, that you do not have to go into more details also. But this point, seismic activity, right, has to be done, right, has to be done in a lot of detail, right? Clear, everybody? Can we move ahead till now? Have you understood? Let's see this. Let us study, now this topic again has come in the mains examination. They have asked how is the seismic waves help you to understand the interior of the earth in the mains examination. It has come. In the prelims examination, repeatedly the question on P waves and S waves have come. You know the concept of longitudinal waves and all related to this concept have come. They've also asked you about the body waves and surface waves concept. They have also come. So this question is a favorite of UPSC for the preliminary examination as well as the mains examination. So you should be very, very clear how these things basically work. Clear? Okay. Let us study. In order to explain the seismic wave, seismic activity, I have to go a little bit into detail and give a complete view. Once you have completed the seismic wave and seismology, then I will tell you how you use them to understand the interior of the earth. Clear, everybody? First, we will understand seismic activity and then how we use them to understand the interior of the earth. Let's begin. Let's begin. See, what is seismology? It is a branch of science which studies the various aspects of seismic waves and produced during the earthquakes. So what it means? This is a branch of science which studies the seismic waves. Now these seismic waves are what? These are produced when earthquakes happen. Clear? Now, what are seismic waves? Now seismic waves are mechanical energy that are caused during the earthquakes. We will be studying when we study the elastic rebound theory. Whenever earthquake happens, there is certain energy that is released. These energies are in the form of what? Seismic waves. Clear? Now these seismic waves are of various types. Seismic waves are of two major categories, body waves and surface waves. Body waves are of two types, primary P waves and secondary S waves. While the surface waves are of two categories, love waves and relic waves. Now we'll understand what are these one by one, right? We'll understand them one by one. Till here it is clear? Seismology basically is a branch of science which basically studies about the seismic waves which are produced during the earthquake. And seismic waves, what are they? These are the mechanical energy that are released. Okay? Mechanical energy that are released, right? Mechanical energy during the earthquake. Clear, everybody? Okay, let's begin. Let us first understand what are body waves, right? What are body waves? They travel within the body that is interior of the earth. Whenever I say body, please remember, body means body of the earth or interior of the earth. The waves which are traveling in the interior of the earth, those are known as body waves. Now, these body waves are of two types, primary P waves and secondary S waves. What are primary P waves? These P waves are the fastest of the waves. Now, please understand, whenever an earthquake happens, various types of waves are created. Now, these are primary and secondary. So, primary ones are the fastest, they travel the fastest. They can travel through solid also, liquid also, and gases also. They are longitudinal. They are longitudinal in a way like the sound waves travel through compression and rarefaction you would have studied. These travel in a similar manner. So, these are what? Longitudinal waves. They are longitudinal waves. That is why we say P waves vibrate parallel to the direction of propagation. So, they are propagating parallel to the direction of propagation. So, these are the characteristics of P waves. When we talk about the S waves, please understand, they travel only in solid. Now, based on these, we are able to analyze what type of state of matter is present inside the interior, in the interior of the earth. These are transverse in nature. Like you have the light waves traveling like this. So, these are transverse waves. Clear? Direction of vibration is perpendicular to the direction, as you can already see this. So, these P waves and S waves have certain characteristics. The most important being, they being longitudinal, they being transverse, they being the fastest. Third thing is, they can travel through solid, liquid and gases. They only travel through solid. Based on these, we know the nature, and based on them, we are able to identify what type of substance or matter is present in the interior. Clear? Clear? Okay. Now see, let us understand this very well. Everybody see here. Surface waves. When the body waves come and reach the surface of the earth, please remember, when the body waves reach the surface of the earth, then you will realize they generate a new set of waves which are known as surface waves. Because, please understand, they move along the surface. Now, please understand, body waves are generated in the interior. These body waves move and travel in all directions. When these, when the body waves move and reach the surface, they generate another set of waves which are known as surface waves. These surface waves are the most destructive type. Why are they most destructive? Because when they reach the surface, these waves generate these love waves and relic waves, which again hamper a lot of construction, infrastructure, life and all. And that is why you realize that these are the most destructive type of waves. Let's see them. Love waves. Let us see this. Supposingly, if you see a road from the top, let us say, please understand, you are seeing a road from, let us say, you are in a helicopter and you are seeing a road from, let us say, height of 100 feet or 200 feet. Initially, the road was like this, right? After some time, because of an earthquake, you realize the road has twisted in this way. Twisted in this way. That means there is only horizontal or sideways movement. It is because of love waves. So, involves horizontal side to side movement. Love is very closely related to snake, right? How will you remember? How will you remember? Love is very closely related to snake. You will remember this? Many would have just now on 14th of February would have realized that your partner is like a snake. So, what you realize? Love and snake will go parallelly, right? So, love and snake. So, there is snake-like movement. Snake-like movement, right? So, whenever a road is there, supposingly, these waves basically move horizontally. That is why they disturb the infrastructure. So road will basically be twisted and turned like this. Clear? So love waves are only horizontal waves. Only horizontal waves. Clear? On the other hand, when you come to relic waves, these waves are horizontal as well as vertical. They travel in rolling and elliptical motion, vertical and horizontal. Now, sometimes do you observe a road might be twisted and turned also, and certain regions it is uplifted and certain region it is moved down. That means those waves have led to the horizontal motion also and vertical motion also. Those are because of relic waves. Everybody, please remember, love waves only impact anything on the surface in a horizontal manner. Relic waves impacted in a horizontally as well as vertically. Right? As well as vertically. Is it clear to everybody? These surface waves are an outcome of the impact that the body waves have caused on the surface. Clear, everybody? Clear? Any problem here? Clear? Okay, let's move ahead. Okay, again, let's see. Supposingly, as I have told you, please see here, there is a road. When you are seeing the road from the, let us say, height of 100 feet to 200 feet, you realize that it is twisted and turned, right? There is no upward and downward movement, only the road is twisted and turned. When you see it from the up and even you go down, go at the where the road is situated. So you realize that only twisting and turning has been done. That means this is an outcome of love wave because it impacts any infrastructure, anything that is present on the surface in a horizontal manner. So snake-like motion will be visible. In the relic waves, what happens is anything that is present will not only be impacted in a horizontal manner, but also vertically. That means a road will be twisted and turned also, and up and down also in certain regions, right? Up and down also. So that means over here there is this horizontal motion also, and the road will be up and down also. There are certain regions it will be down, certain regions it will be up. So that means horizontal and vertical motion both are happening due to the relic waves. Clear, everybody? Clear? Okay. Let's move ahead. Now some basics of earthquake. Now this is again very, very important. Why? Everybody clear? Yes, exactly. Jet stream, like jet stream, absolutely. Clear? Love waves and relic waves done? Now see, let us understand a little bit about the earthquakes. We are not going to go into a lot of detail. What is required here, because you are already going to do this in the further chapters. So what are earthquakes? Earthquakes are basically vibrations in the Earth's surface caused by the sudden release of energy, right? Certain release of energy in the Earth's crust or the upper mantle. Now, though we haven't done plate tectonics right now, but little bit idea you already know because this is a marathon going on. So little bit idea you will be knowing. If you do not know, otherwise we will still be explaining plate tectonics when we do the chapter of plate tectonics. Right now, please understand. First cause, what is the reason? Earthquakes due to plate tectonics. You know this very well. Due to the sudden release of energy during the plate tectonic movement, the earthquakes can be caused. Now let us see this. Though you haven't done it, but again, little bit idea should be given. We will be doing plate tectonics after some time. Don't worry. Please remember, let's see this better diagram. You know that there are a lot of plates. Earlier continental drift you have studied where you used to say continents move, but we later on realized that these are not the continents, the plates move. Now, let me give you an example. Let's see this. I always explain my students in this manner. See here. क्या? काऊ के हॉर्न पर अर्थ इसलिए हिलता है, भूकंप आता है. Okay, let me be telling you very clear. This is got to do with philosophy. ये geography का relation नहीं है. इसका आंसर प्लीज अंडरस्टैंड, इसका आंसर साइकोलॉजिकल भी है. जो when this statement was written, somebody has written that it was in a cow's horn, that is why earth shake. People who mention this, they should understand what is the meaning of it. Even Lord Krishna, when mentioned it, the meaning means, even Guru Nanak mentioned dhol dharam dai ka poot. This means that it is like a idiomatic idiom. Idiom means they try to tell that when the bull is basis of dharma, when the dharma shakes, there will be, let us say, some upheaval in the earth from various manner. So it is not a statement from the perspective of you take it literally. It basically meant that bull over there signifies dharma. And dharma is what stabilizes the earth, because it is the dharma where earth is where dharma is practiced. Yeah, okay? So please remember one thing, that this is geography, yes I know, but that is psychology or philosophy what you are mentioning, and that is the correct meaning. If you want, I can explain you that also, but we are not here to explain those concepts right now. Okay, come here. Okay. Supposingly this is a plate and this is another plate. See here please very quickly. If two plates are coming close to each other, one plate will move below the other plate. One plate will move below the other plate. Right? Now the question will come, sir, see here, this plate is going below this another plate. Right? This will also lead to certain earthquakes. Yes, but the question will come, right? The question will come, sir, which plate will move down? The plate which is more dense, the denser plate will move down. When there is such movement, you realize that there are earthquakes. Clear? There can be earthquakes also when, let us say, two plates are moving apart. There is some movement. Then also there can be earthquakes. Over here, you realize the plates are moving apart. Sometimes what happens, conservative plane boundaries, where you realize that two plates are again moving side by side. Side by side. That can also cause earthquakes. Clear? So when we talk about these stuff, so please understand these plate boundaries, all of them can cause earthquakes based on the level of movement that is there. Please understand, this boundary is known as destructive plate boundary, right? Destructive plate boundary. Reason why? Over here, this part is going inside the mantle and it is being destroyed. That is why it is known as destructive plate boundary. Over here, when they're sliding, moving apart, new crust will be created. That is why it is known as a constructive plate boundary. Over here, they're sliding side by side, so there is no creation or destruction. That is why it is known as conservative plate boundary. Clear? In all these cases, you realize earthquakes can be there. Everybody clear to this? So when I mention over here, this is a similar thing. This is where you realize new constructive plate boundary. This is destructive plate boundary. Clear? Okay. So earthquakes can be because of the plate tectonics. Clear? Right now, we are not going to plate tectonics theory because we haven't studied it. We will be studying in the next chapter. Then it will be much more clearer to you. Okay. Let's move ahead. Earthquakes can also be caused due to what? Clear? Earthquakes can also be caused due to volcanic activities, rockfall, and mining areas. You would have realized this, that when I mentioned etc., etc. means many other causes. If you realize that when US-Afghanistan war was going on, you realize that US had bombed that region to a great extent, right? Huge bombs were dropped there, and later on you realize Afghanistan experienced large-scale earthquakes also during that time. Why? Because that is an outcome of the anthropogenic activities where you are dropping bombs in certain regions, which can ultimately disturb and cause earthquakes also, right? So multiple reasons can be there. Now another thing that you should know is Richter scale measures the magnitude, that is the amount of energy released. Please understand, whenever a earthquake happens, we measure the amount of energy that is released. That is known as the magnitude. That is measured by Richter scale. Then there is Mercalli scale, which measures the intensity. Intensity means the effect of the earthquake. The effect of the earth. How will you remember it? See here. Everybody, please see this. You have to remember this statement. You will remember because this question has been asked in UPSC repeatedly. See, all of you look at this statement. Intensity is measured by Mercalli scale. Magnitude is measured by Richter scale. Clear? Will you remember this? IMR. Intensity is measured by Mercalli scale. Magnitude is measured by Richter scale. So you will always remember this. Clear? Clear? Chale. Okay, let's begin. Mechanism of earthquake, right? Mechanism of earthquake. Elastic rebound theory. See, there are a lot of theories that have been given how earthquakes possibly would have taken place. One of them is the elastic rebound theory. Now, elastic rebound theory is one of those theories which is very often accepted by the people as a major cause for the earthquakes. Now, so what happens is, let us say this is a crust that is present. Now, in that crust, let us say there is some compressional forces that are acting. And let us assume that this is a line where, let us say, some break happens later on. Let us say this is a crust. Now, due to, let us say, stretching or let us say compression that has happened, it has twisted a little bit. Now, there is a limit to which this compression or let us say whatever movement of tectonic activity that are taken place can take place. After that, there will be certain release of energy that will happen. Now, you see, let us take like a elastic band. Now, elastic band is there. You can stretch it to a certain limit. After that, what will happen? It will break. It will break. Yes. Similarly, if you realize over here, some let us say compressional forces are acting, there will be certain degree to which you can compress it. After that, there will be a reaction. So let us say this region will break. The moment this region breaks, let us say there will be energy that will be released in the form of seismic waves. Seismic waves. Clear, everybody? Clear? So this is known as elastic rebound theory. When the elastic limit is extended beyond its level, you will realize that earthquakes happen. Clear? Clear? So the energy released is in the form of earthquakes, in the form of seismic waves. Clear? Okay. Now there are few concepts that you should know. See, earthquakes basically happen in the interior of the earth, right? Now let us assume this is a point where possibly this, let us say, fault or let us say breaking or whatever reason it might be would have happened. This is a point in the interior of the earth. This point is known as, where the earthquakes originate, is known as the focus. The alternative name for focus is hypocenter. Hypocenter. The point in the interior of the earth where the earthquake originates is known as the focus or hypocenter. The point within the earth where the earthquake originates. The important thing is earthquakes originate within the earth. Within the earth. Right? Please understand. One more thing is a line straight away drawn perpendicular to the surface. This point is known as epicenter. Epicenter. It is a point directly above the focus. Now, this is a region which experiences a maximum destruction. Maximum destruction. Why? See, this region is going to be the closest. If I take this point, do you realize the distance between this distance and this distance? Let this be A, this be B, this be C. If you see AB is less than AC, AB is less than AC. So epicenter in a way is a point that is closest to the focus. So the energy that is released will be reaching this point where least dissipation of energy would have happened or least loss of energy would have happened. So this region is going to experience maximum destruction also. Clear to everybody? So epicenter is a point directly above the focus or hypocenter, and this region will experience a maximum destruction also because it is closest to the point where the earthquakes originate. Clear? Okay. Now, types of earthquakes based on depth. Right now we have studied these dimensions. There are other categorization also. When you read the UDAAN magazine also and some standard books also, you realize there is categorization based on depth, how deep the earthquakes are. So this is again the differences I have put it over here. Clear? Clear? Now see. Somebody is asking, Prashant Pal, ये UPSC की class है? nahi bachche, this class is not of UPSC. This is for sector area 51 in United States. Na? Alien Protection Force examination has been launched by United States, where we have to take care of the aliens in area 51 in Nevada in United States. For that, we are studying the earthquakes. So when earthquakes comes, how we have to deal with the aliens, how will we study them, what are the aspects related to that. All those things are being studied over here with respect to that. So we are not studying for UPSC. We are studying for the alien forces, which will be recruited where? In United States. So if you are preparing for the alien forces examination, then you have to listen to this very carefully. If you are preparing for some other examination, then don't do, right? So this is very, very important. Area 51, task force. So you have to study for that. Okay, chaliye. So there are shallow focus earthquakes. That means shallow focus basically means that it is closer, the focus basically lies closer to the surface. Intermediate, matlab that means not very deep. When I talk about deep focus earthquakes, that means that the focus is situated very deep below the earth's surface, right? Below the earth's surface, right? Okay. Yes, it is also for the Indian cricket team, right? Please remember, yesterday you realize when the team was playing, they took this session, bache, marathon. Before that, then only they played cricket against Pakistan. That is why they won. Okay, Prashant? So today when you watch this marathon, next you can play cricket with other teams also, then you can win. So this is very, very important. Okay, chalo. Shallow focus, intermediate and deep basically are dependent on the fact that how deep the focus is situated. Now over here, see, the depth is 0 to 70 kilometers here, intermediate is 70 to 300 and deep focus is 300 to 700 kilometers. Frequency, shallow focus are the most common, less frequency 20 to 25% and least common are 5 to 10%, right? Magnitude, variable but occasionally include most powerful earthquakes, because what happens is when the focus is closer to the, right, when the focus is closer to the earth's surface, the amount of energy that reaches the epicenter is again more. When it is more, obviously the destruction is going to be more, right? Moderate to strong and moderate to strong again, but sometimes strong. Seismic waves produce high frequency waves that are more destructive, emit intermediate waves that can be destructive, and radiate low frequency waves which are less destructive. Plate boundaries, all plate boundaries, convergent and only convergent over here. So these are again various types. This is again less common differences that you do, but because we are doing this from our advanced level, so this is very, very useful. This can be asked in your examination. So this is one you should remember. Okay. Now this is a diagram which though I teach in Indian geography, but I have basically mentioned here. There is one more categorization which has come, basically that is zone 6 also, which we will be doing in the Indian geography part. But right now, see, distribution of the pattern of earthquakes. The one which are in red are the very high damage risk zone. Then you have 4 high damage risk zone, which is in this orangish color. Then you have the moderate damage risk zone, which is in white color, all these regions. Then you have the low damage risk, which is in pink color, and very low damage are the ones which are in yellow color. So this is again a distribution pattern of earthquake. Why it is important over here is because I will be doing this in detail when I will be doing, right? When I will be doing paper of Indian geography. Over there we'll be doing in detail because I'm teaching here, so I have just mentioned here. Clear? Okay. Consequences of earthquakes. Now, consequences of earthquakes, see, you know that it is going to destroy infrastructure, settlement, transport networks. Material and socio-cultural damages will take place, leads to fires, dam fires, landslides, death of the people, and economic losses. So this is something again general. We do not have to go into detail about that. Next is earthquake hazards mitigation. What do you need to do? Brief idea, because we are doing earthquakes, so I'm covering here also. Earthquakes, establishing earthquake monitoring centers, extensive use of geographical positioning system, preparing vulnerability map. Vulnerability map basically means that how to draw a map India. Beta, I will be drawing when I will be doing the Indian geography on 19. So I'll be teaching you all, don't worry. I'll be live doing in front of you, so you'll understand that. So please understand, preparing vulnerability map basically means which regions are more prone to destruction. Understanding those regions, hotspots is very, very important. Next comes educating the people. Educating the people, that means from the stage of preparation for the earthquake, any mishap happens, till the time of how to recover from any accident. So over here, educating the people becomes very important. Next thing is modifying the houses types. Do you realize one thing? When you go to Japan, you realize they are the regions which experience a lot of earthquakes. Still, they have one of the best skyscrapers that are present, one of the best infrastructure that is present. How? Because their architecture or the buildings and infrastructure are adapted or have been made according to the regions based on the earthquake, let us say, which might be one of the worst earthquakes. They're still able to tolerate that. Why? Because their architecture is in that way. Their construction designed in that way. Possibly we can learn from that. Those are the things we need to learn from them. That is what is missing in India also right now. We can work on that, right? Okay. Now, coming back to the point, till now you have studied a little bit about the earthquake, because we have to understand earthquake in order to understand the interior of the earth, right? Now, having understood or got the little bit details about the earthquake, now let us understand there's a concept of emergence of shadow zone. Just give me a minute. Emergence of shadow zone. Give me a minute, just a minute. Okay. Okay. Let us understand them. Shadow zone again is the most important dimension which you need to study in order to understand how we got to know about the interior of the earth. See here. Shadow zone is an area of the earth where seismographs cannot detect P waves or S waves from an earthquake. Let us understand this. Please see. Do you realize, if supposing that this is a point where the earthquake originated, you know seismographs are located on various parts of the surface of the earth. You know that? In various parts across the world, you will realize that the seismographs are going to be present, right? So whenever the earthquake happens in any part of the world, that seismic waves travel, and that seismic waves travel lead to basically the seismic waves being detected in various parts of the world. Agreed? But what happens is, there are certain regions, in spite of the earthquake happening, the seismograph is not able to detect the seismic waves. Now the question came, what is the reason behind it? It is basically first of all the nature of the P waves and the S waves, and secondly, possibly the interior of the earth is such that it is leading to shadow zone being created when we study the seismic waves. Now let's understand this. This is what seismographs are present on the surface of the earth, right? Now let us take the P waves and S waves shadow zone one by one. This is a region where the earthquake, let us say, originates. That is, let us take it as a focus. Now the waves will be traveling in all the direction. You know that very well. And you know, when the waves travel from one medium to another, again there will be certain refraction or refraction of the waves will happen. Now see, when the waves are moving, over here it will be detected, here it is going to be detected, here it is going to be detected. But when it comes, you realize that the outer core is in liquid state. So there will be certain refraction of the wave and it will come here, and this region will not be, let us say, observing any of the P waves. Similarly, it will be detected here, here, but because of the liquid nature of this is what? The outer core. Outer core. So there is refraction of light, a refraction of wave, and this is a region where you do not view or experience or note any of the P waves. Clear? Then this region is known as the shadow zone for P waves. This is known as the shadow zone for P waves. From 105 degree to 145 degree is the shadow zone. This observation was made. Please understand, this observation was made. People thought, okay, let's see the reason behind it. Later on, they analyzed basis because of the presence of certain type of state that is inside the earth that is leading to these causes. Earlier, it was just noted that this is the region where you're not able to identify the P waves. Now, let us see the S waves. You know very well that P wave is able to travel through all the states, right? All the states. Clear? Savinder Singh mentions, please Prashant, understand. Please understand. What NCRT says, that has to be given more priority than other things. I can value, if Savinder Singh mentions, the father of Savinder Singh is Staller and Staller. Staller and Staller also mention this. So what is being taught here? Listen to this if you want to qualify this examination. Otherwise, you mention what is mentioned by Savinder Singh's book, Allahabad Pustak Bhandar, 103 degree. Then you mention that, you will get it wrong, right? So please understand this very, very carefully. That I am telling you the publishing house also. Allahabad Pustak Bhandar from Allahabad. There are certain wrong things also mentioned there. You have to focus here. Okay. S waves, shadow waves, please understand. Again, you realize that energy is released from here. Energy being released, you will realize that in this region, S waves will be detected. S waves will be detected, but you know that very well, S waves cannot travel through the liquid state. You know that very well. So all the waves that enter this, they will be basically observed by the outer surface of the core. Outer core, it will observe all the S waves. So from this region till this region, that means beyond 105 degrees, you will not be able to identify the S waves. That means the shadow zone is beyond 105 degrees. Beyond 105 degrees. Clear? Now tell me one thing. After having identified that, okay, P waves we can see from 105 to 145, but in S waves we are not able to identify beyond 105 degree. So that means there is certain variation in the state that is present inside the earth. Yes or no? Yes or no? That means there is different state of matter that is present inside the earth. Through this we got to know that means there is certain thing inside the earth which is basically changing the, let us say waves are being observed and the refraction of the P wave is taking place. That means possibly liquid state of matter is present inside. That is how we got to know about the interior of the core. That the core is liquid in state. Later on we got to know, again further studies were made, then we got to know that the inner core is again solid about that because further studies are done with better seismographs. Clear? So what do we understand here? P waves can travel through solid, liquid and gases. They refract and the density due to the density differences, and the P waves undetected from 105 to 145 degree. This is known as the epicenter. This is basically known as the shadow zone. S waves can travel only through solid. So the moment any liquid or gaseous state comes, they cannot travel through that, right? So the assumption was obviously there is going to be liquid state that is going to be present inside the earth. So S waves cannot pass through the liquid outer core. So they are undetected beyond 105 degree. That is the shadow zone for the S waves. S waves. Clear? Yes. Remember, the inner core being solid was later on detected. When you realize that further study of the P waves were done, then later on it was detected, because through this study you are not able to identify the inner core. Later on it was identified. Okay. Now see here. Outcome. What is the outcome? Please see here. Please see here. Right? This helps to identify that there are different states of substances inside the earth. We've got to know about this. Further changes in the speed helps you to identify the nature of the substances. See, remember, when the waves are traveling, there will be different times when the wave are reaching the various parts of the surface of the earth. So that means there is going to be some speed variations also. When the speed variations are there, we know what is the speed of the wave in various mediums. So based on that, we are able to identify what type of materials that can be present inside the earth. Through that also we got to know, right? Clear? Now, Waves help to identify the discontinuities in the interior. Discontinuities means that whenever there is certain change in the state of matter, certain variations happen with respect to the speed, which we will be studying when I will be telling you the interior of the earth. So we identified certain differences in the states of the discontinuities that are present. And overall, it helped to understand the interior of the earth. So whatever I have written over here, this part and all, this came as a 15-marker question in your civil services examination also. Clear? Clear? Yes or no? Clear? Agreed? Yes, bache, whenever a earthquake happens, both S waves, P waves, see, there are other many waves, P dash waves, S dash waves, P slash waves, S slash waves. We do not have to go into all those details. There are multiple waves that are created. Broadly, we are studying P waves and S wave. Whenever earthquake happens, all these waves are released. Clear, everybody? Clear? Okay. Done? Now, bete, these are again handmade diagram. If you have studied about, let us say, a brief idea about what is in the interior, this diagram which I am making here is not something that was identified in one go. It took a lot of time earlier through let us say surface direct resources, then indirect means, then let us say seismic waves and all, and slowly you got to know about the various parts of the interior of the earth. Now let us take one by one and understand what is in the interior of the earth. This is like the continental crust. This is the oceanic crust. Let us go a little bit into detail. Okay. Just this is for your understanding so that you can understand how I made the diagram, right? See here, right? This is the continental crust. This is the oceanic crust, right? This yellow part. Clear? Next part, there are various divisions that I have made here. Various divisions I have made here. This is the crust. This part is the upper mantle. This part is a lower mantle. This part is a transitional zone of the mantle. Below that is the outer core and below that is the inner core. Clear? Clear? We'll be doing, please understand, lithosphere, ethnosphere, all those are different categorization we'll be doing after this, so focus here. So this is a diagram that I have made. Now let us understand it in more detail. When you study the crust is not uniform. There are two categorizations of the continental crust. One is the upper continental crust and the other lower continental crust. Between them is a continuity because of the difference in the densities and the nature, which is known as Conard discontinuity. Similarly, you have a discontinuity between the crust and the upper mantle, which is the Mohave discontinuity. Similarly, there is a discontinuity, there is a Repetit discontinuity, Gutenberg and Lehmann. So let us understand what they are. Conard discontinuity is between upper and the lower continental crust. Within the crust also you realize continental crust is very thick. The upper part and the lower part, there is certain variation in the densities also. So that can be very well observed. So that is why this region over here you realize there is density variation, that is Conard discontinuity. It is within the crust, that also continental crust. Mohave discontinuity is between the lower crust and the upper mantle. Lower crust and the upper mantle. Why? Because you realize over here there is variation in the density, there is variation in the nature of composition also of the substances that are there. So when the seismic waves travel, whenever they travel from one layer to another, there is certain change in the little bit speed, certain direction because of the density variations. Then is Mohave discontinuity, that is between lower crust and upper mantle. Then you have the Repetit discontinuity between the upper mantle and the lower mantle. Gutenberg discontinuity between the mantle and the core, and finally you have Lehmann discontinuity, that is between the inner and the outer core. Clear? Inner and the outer core. Clear, everybody? Clear? Okay. Clear? Conard discontinuity, Mohivic discontinuity, Repetit discontinuity, Gutenberg discontinuity, and Lehman discontinuity. These are the various discontinuities that you should be knowing. Repeatedly questions have been asked on them. They will ask you they are between both which of the following. Right? Clear? Okay. Let's begin. One by one, let us study crust. Let us begin crust. Now, you know that very well that crust is this part. Crust can be oceanic crust also and continental crust also. It depends upon the nature. Okay? Chaliye. Crust is the outermost layer of the earth. You very well know. These characteristics are important. So, please note questions can be formed from them also. It is about 1% by volume and less than 1% by mass of the earth. So, very important. If you see by volume, it is just 1% of the total volume of the earth. And by mass also, it is less than 1% of the total mass of the earth. It can be divided into two categories. First is continental crust and the other is oceanic crust. Clear? Clear? Conard discontinuity separates upper crust from the lower crust with respect to the continental crust. Because oceanic crust is very thin, you do not have two divisions as you have in the continental crust. So, whenever I talk about Conard discontinuity, we are majorly talking about what? The continental crust. Clear? Crust primarily comprises basalt rocks rich in silica and oxygen. Basalt rock rich in silica and oxygen. These are certain characteristics you should know. We can quickly move ahead. Now, you know that very well that I had discussed that crust can be of two categories, continental crust as well as oceanic crust. So, what is the difference between both of them? This can be asked in your paper. This have been asked in the preliminary examination also a few years ago. You know that very well. Continental crust is generally 35 to 45 kilometers, right? If you see the depth, thickness is 5 to 7 kilometers, and you know that it is repeatedly formed because of the sea floor spreading concept. We will be studying that also. It is about 3.8 billion years ago. This is about 200 million years ago because repeatedly the oceanic crust is repeatedly formed because wherever there is diverging plates due to and sea floor spreading, you know that new crust is added, and that is why the age of the oceanic crust is much more younger. They're much more younger. The continental crust are older. They are majorly granite. They are majorly basalt. They are less dense, about 2.7 grams per centimeter cube, whereas they are more dense, close to 3 grams per centimeter cube. So what do you get to know about them? Oceanic crust are denser than the continental crust. So whenever there is destructive plate boundary, which plate will go below the other plate? Tell me. Which plate will go below the other plate? The one which is more denser? The one which is more denser is what? The oceanic plate. Now the question comes, sir, if two oceanic plates are colliding against each other, then which will go down or beneath? The one which is again more denser. That is a major concept that you should be all aware of. Okay, let's move ahead. Stability. It is more stable. Continental continuously recycled at the subduction zone, subduction at the point where it is subducting, moving down. If you see the area, 40% area is the continental crust and 60% are the oceanic crust. Oh, clear everybody? Clear? Okay. Let's move to the second part, that is mantle. You know this whole mantle? Mantle stretches till a depth of, please understand, mantle stretches till a depth of 2900 kilometers. It forms 83% of the Earth's volume and 68% by depth, as you understand. It comprises of silicate rocks. Again, these are very important characteristics. These have been repeatedly asked again. Elements are 40% oxygen, 21% silica, and 23% magnesium. The way to remember it is OSM, OSM. Question has been asked on this also. Which are the major minerals that are present inside the mantle? How you remember OSM? O for oxygen, S for silica, M for magnesium, and they are in order. Oxygen 45, silica 21, magnesium 23. So they can ask you in order, arrange them in order, they are present in the mantle. So you should know that very well. Clear? Mohivic discontinuity. Mohivic discontinuity again basically separates a crust from the mantle, and it is of three types. First is the upper mantle, then the transitional zone, and then below them is the lower mantle. Let's see them. Upper mantle, see, upper mantle is till a depth of 700 and just a minute. This is, I think, 370 kilometers. Okay, it's fine. Okay, 370. It's here. From this point till this point, 370 kilometers. Till 370 kilometers is your upper mantle. Primary source of magma, it is plastic in nature. Plastic in nature, right? Second thing, some books write 400 kilometers. So you can put 400 kilometers, but more precisely, it is 370 kilometers. Below this is from 370 to 720 is basically the transitional zone. 370 to 720 kilometers. It is more dense. It is more dense. Then you have the lower mantle. It is basically from 720 till 2900 kilometers. 720 to 20, it is more dense. So as you move downward, the density is increasing. Clear? Yes, semi-molten state. Okay. Now, please remember, okay, the question comes. I told you one thing, that S waves are not able to travel through liquid. When the mantle is in a plastic state, how is the S wave able to travel through it? Anybody? Anybody? Can you really answer this? How the X is able to travel through it when it is in the plastic state? Because I said that S waves are not able to travel, right? Okay. Can anybody tell me? Right now I told you plastic state, right? I told you that S waves cannot travel through liquid. Anybody can answer this? When I talk about plastic state, it is not a liquid state. Let us take an example. Have you seen jelly? Now, when you see jelly, you cannot call it liquid, right? You can move the jelly like this, but you cannot call it liquid. Similarly, when you talk about this plastic state, it is not basically liquid. It is somewhat a semi-solid type of state. Semi-solid type of a state. It is not liquid. That is why you realize S waves are able to travel through it. Had it been liquid, it would have not been able to travel through it. These are the questions which can come in your exam also as one of the statements. So you should understand them well, right? Okay. Okay. Core. When you see the core, you realize core is also two parts. From 2900 kilometers to 6372 kilometers is the core. 2900 to 6372. Now you know that Witchart-Gutenberg discontinuity separates the mantle from the core. Density increases with depth and increase in the speed of the primary waves, because you will realize, please understand, inner core is solid. So definitely with the differences in the composition of the material, the speed will also vary. Clear? So it has two parts, outer core and inner core. Let us say outer core. Outer core extends from 2900 to 5100 meter. It basically comprises iron that is mixed with nickel and traces of lighter metals. It is liquid molten state. Liquid molten state. Okay. Answer this before I basically tell you. How is it possible that inside the inner core is solid, but the outer core is liquid? That means something solid ball is inside a liquid surroundings. How is it possible? Though you know that the temperature basically increases as you move inside. Yes, the temperature is increasing. Temperature is increasing. Even the temperature is in the core is much more. In the inner core it is much more. So how come the inner core is solid but the outer core is liquid? How is it possible? Think. Inner core extends from 51 to 63. It primarily is iron and nickel. It is in solid state. Now the question is, how is this possible? Okay, good answer everybody. Please remember, whenever you're talking about the state of matter with respect to the core, or for that matter any body, you will realize that there are two things that are going on. First is temperature, other is pressure. Both play a very important role with respect to the state. Whenever I'm talking about the outer core, Please see, as we move inside the earth, interior of the earth, the temperature and pressure both are increasing, right? But at the level of the outer core, the role of temperature is much more than that of the pressure. So that is why it is in a liquid state. But when you go further inside, that means close to 5,000 kilometers, you realize that temperature is rising, but the role of pressure has increased very much. That forces this part to be in the solid state. Remember this very clearly. There is a trade-off. What? Trade-off between pressure and temperature, which is playing more important role. So the role being played over here by pressure becomes more important, and that is why it is in solid state. So many of them gave a correct answer. Very good. Your preparation is going good if you are studying like this. Very nice. Okay. Some people ask, sir, tell us something about the lithosphere, asthenosphere and all. Please, bache, right now the things that you have observed, these have been identified through the direct and indirect sources. Clear? Now, this is more accurate also, but there are other divisions and categorizations also which we study. Let's see. This is a mechanical division of Earth's interior. Please remember, in the examination, they can ask you which among the following is a mechanical division. The crust, mantle, core is not a mechanical division, right? Mechanical division is lithosphere, asthenosphere, mesosphere, and barosphere. Remember this always, right? Let's understand this. Whenever we talk about lithosphere basically includes the crust and the certain part of the mantle, right? Crust and the upper mantle. So somewhat you can say that this part can be the lithosphere. Now the thickness varies from place to place. It can be 10 kilometers to as much as 200 kilometers also. Lithosphere is where tectonic plates are located. Clear? This is a little bit you should know about lithosphere. Then comes the asthenosphere. Now, it is the part of the mantle only below the lithosphere. So, uppermost part of the mantle below the lithosphere is called the asthenosphere. It lies below the lithosphere and a depth of 80 to 200 kilometers below the surface and may extend up to 400 kilometers also. This is again, as you know, we're talking about mantle, so it is going to be a plastic zone. It is capable of bending without weakening, capable of bending without breaking the convectional currents. So basically understand, over here this is plastic zone, so whenever a plate is going inside, you will realize it will keep on going down. It might not easily break inside. Later on it might break. Because it is plastic in nature, that is why you realize the plates are able to go down. This is the region where convectional currents are also working, which you will be studying later on in the convectional current theory by Arthur Holmes. What happened, audio? Mesosphere. Now please understand, the upper mantle part other than the lithospheric part is basically the asthenosphere. The remaining part of the mantle is known as the mesosphere. Extends to 2900 kilometers. Temperature is very high, 3800 degrees approximately. Barosphere. Barosphere is basically the core. Extends to 6372 kilometers. Very high temperature and pressure. Very high temperature and pressure. Clear? So understand this. I'm creating certain MCQs for you. I want you to answer it. Let's see. Give the answer to this. Which among the following are correct? Barosphere is roughly equivalent to the core. Density roughly increases as we move in the interior. Pressure plays a more important role than temperature as we move in the interior of the earth. You have three options, three statements, and A, B, C, D. Give the answer. Everybody. Quickly. Some are saying A, some are saying B. Quickly, let me see how many of you. This is a very important and a very analytical question. You need to use your brains. See, what I'm seeing over here is that most of you are marking A, right? Some are marking B, some are marking D. Quickly, write the answer. In 1 minute, I will discuss it. See, I have created this question based on your knowledge, what I have taught you. And this is how papers are created. Let's analyze. Want to know the answer? Okay, first of all, barosphere is roughly equivalent to the core. This statement is correct, which I've already told you, right? See here. Barosphere is the core. So it is clear. There is no problem in this. Okay. Now, the moment I mention 1 is correct, I can eliminate what option? C option. Density roughly increases as we move in the interior. That is correct. That is correct. Density is increasing as we move ahead. So this statement is correct. If 1 and 2 are correct, we know that these two options are eliminated. These two options are eliminated. One option is left, and where you all made a mistake. Do you know that? I have written here the role of pressure is more important as we move in the interior. I have not mentioned that the role of pressure is more in the inner core. I have mentioned the interior. Do you realize in the outer core the role of temperature is more than the pressure? Do you realize? I have confused you in a way. How I confused you? If I had written the role of pressure is more in the inner core, then the statement would have been correct. Or I would have written that temperature and pressure play a very important role as we move inside. These are the statements. In that particular case, this statement would have been right. But do you realize, merely mentioning that pressure plays a more important role in the interior, bhai, this is a very vague statement. This is not correct. So this statement will be wrong. So 3 is wrong. The answer is 1 and 2, that is B. 99% students over here mentioned A. 99% students mentioned A. Less than 1% student mentioned B. And these are the candidates who qualify this examination, and this is the success rate for civil services exam. But pressure has dominant role, beta. Pressure has dominant role in the inner core. Interior of the earth includes the outer core also, but in the outer core, temperature is more important than the pressure. I told you right now. Please remember, did I tell you that the outer core temperature is more important than the pressure? In the inner core, pressure is more important than temperature. That means this statement is not absolutely correct. Something that is not absolutely correct, you cannot mark it right. So, answer given by the student was less than 1%. That is why I'm telling you, just imagine, I'm just teaching you this and making the questions in front of you. This is how UPSC makes. So please understand this art. Clear? Okay. Now there is another division of the earth. It is known as the chemical composition of the earth's interior, that was given by Edward Suess. By whom? By Edward Suess. Edward Suess. Now this is one of the oldest classifications that you have. Though crust I have mentioned, but more importantly it is Sial, Sima and Knife. It is basically known as a chemical classification or composition. So please understand, right? Let's begin. Sial. See, it is located just beneath the outer sedimentary cover. The Sial layer comprises the granites. It is known as Sial because of the mineral composition that I have mentioned here. What happened? Can anybody suggest from where all content has been written? Just to know you, bache. This covers the UDAAN magazine. This covers the NCERT. This also covers the other standard books also. I have gone a little bit beyond the UDAAN magazine also for one reason, so that you can get a comprehensive coverage of all these things. Clear? Okay, let's begin. Sial is because of the two things that are present inside it. SiAl. Sial is because of silica and aluminium. Right? Silica and aluminium content. That is where the word Sial comes. Average density is 2.9 grams per centimeter cube. Thickness again varies from 50 to 300 kilometers. And it is acidic in nature. Now, if you realize, if you further go inside, this is what Sial, this is what Sima, this is what knife, right? So when you go inside, there is Sima, right? Sima. Now, beneath the Sial consists of the basalt layer, the source of magma and lava and the volcanic eruption. Two dominant constitution, silica and magnesium, that is where Sima. The average density over here, you will realize, is 2.9 to 4.7. That is why the density is increasing as you're moving inside. Thickness is from 1000 to 2000 kilometers. Clear? Inside is knife, NIFE. Why? This is basically like a core if you talk about. Nickel and iron, NIFE. It is still 6372 kilometers. That is the interior of the earth. Density is high, 13 grams per centimeter cube. So that means you are moving inside, the density is increasing. Clear, everybody? So the statement that I had mentioned in the beginning of the question, the density is roughly increasing as you move ahead, it is correct. Clear? Okay. Now, let us see this. Your NCERTs basically mention only this chart. They do not mention this chart. But this chart has also been asked in examinations like CAPF, in PCS exams also, in UPSC also, in one of the statements they had asked along with other statements. So you should be aware of these states. The composition of the Earth's crust and the composition of the minerals that are present in the entire Earth. Both of them are different concepts. The crust has a dominance of oxygen, 46.6%, silicon, 27.7%, then aluminium, iron, calcium, potassium, sodium, magnesium, and then others. If you see the overall Earth, you know that majority is iron. Iron is 32.1%, then oxygen. So you can be asked that the most dominant among the following elements in the entire Earth is oxygen. Then that statement is wrong, because when you're talking about the entire Earth, it is iron. When I talk about only the crust, it is then in that case oxygen. So these two charts should be very well understood, that there is a difference between both of them. And UPSC very often tends to confuse you based on oxygen and iron. Clear? So let's move ahead. Can we have certain questions here? Okay, just give me a minute. Okay. Let's have a few questions. Ready for the question? Ready for the questions? Chalo. With reference to the source of information about the Earth's interior, consider the following statements. Right? Clear? Do we need to learn? No. At least learn first 2-3 of both of them. That is it. Read the question. Again, this is very, very important. Let us see how you answer them. Deep earth mining and drilling are considered as the direct sources they have mentioned. Meteoroids, remember rights are means hitting something, right? Are considered as indirect sources. Magnetic survey help to understand the distribution of material inside the earth. What is the answer? Read it quickly and answer. What is the answer? It is a very easy question. I don't think you'll face any problem here. Okay, let's see. Deep sea mining and drilling are considered direct sources. Yes. Meteorites are considered indirect. Yes. Magnetic survey. Yes, they can be helpful in understanding the interior. So, answer should be C. Yes, answer is C. Clear? If you've got something else, that means some problem is there in understanding. Clear? Okay. Second question. Consider the following statements regarding seismic waves. P waves are the fastest and travel only through solids. S waves are transverse in nature. Surface waves are the most destructive. Quickly, quickly, quickly. Clear? Okay. Let's understand what you are trying to say. Okay. P waves are the fastest. Okay. Clear. They travel only through solid. Only is wrong. Please remember, any statement which is partially correct and partially wrong will be considered wrong. Even a single thing is wrong in a statement, it is wrong. The moment I mark this part as wrong, I know that it is wrong, this is wrong. 2 is present in both of them, so by default I know this statement is correct. S waves are surface waves are most destructive. I've already told you this. So I think this statement is also correct. So the answer is 2 and 3. 2 and 3. Clear? Next question. Following statements regarding the earthquake. Richter scale measures the intensity. Mercalli scale mentions the magnitude. Which among the following statements are correct? Quickly. Are correct. Tell me. Separate the playlist. We will do that. Don't worry. Right now, please study this. Some are mentioning C, some are mentioning D. IMR. Okay, let's see this. IMR. Even this is a question of UPSC, please. This is a question that has come in UPSC. So please understand. Intensity is measured by Mercalli scale and magnitude by Richter scale. Magnitude and Richter. Magnitude and magnitude Mercalli. That means the statement is wrong. This is also wrong. So that means both the statements are wrong. The answer should be D, because magnitude is measured by measures the Richter scale or the intensity by the Mercalli scale. So both the statements are correct. Wrong, sorry. So answer is D. Clear? So you remember how IMR over here is working. So this should be very clear to you. Okay. Next. Consider the following points about the Earth's focus and the epicenter. Focus is a point on the Earth's surface where the earthquakes originate. Epicenter lies directly above the focus. Let's see how many of you do this question. It is an easy question. Only thing is you have to be a little careful. Let's see how many of you do it. Clear? Quickly, what is the answer for this? But it is ABCD. Out of ABCD, what is the answer? Okay, some are saying B, some are saying C. Okay. The interesting thing is you need to remember a word. Focus is a point on this Earth's surface. I told you very well, Earth's in the interior of the Earth, not the surface. This point is wrong. Do you realize where it is wrong? This statement is right. Focus is where Earth, this originates. So most of you would have got it wrong because you saw the origination, not the surface part. So this statement is wrong. Moment this is wrong, okay, I know. This is gone. This is gone. Epicenter lies directly above the focus. Yes, that is right. B is the answer. Next. Mid-oceanic ridges are associated with rising, I think seafloor spreading, though we haven't studied, but little bit, let us test you if you know that. Though I had explained you a little bit, you know, basic studies you would have done. So let us analyze if you can do it. If not, doesn't matter. Let's see. Mid-oceanic ridges are associated with the rising convectional currents. Oceanic crust become older as they move away from the ridge. Seafloor spreading occurs at convergent boundaries. Let's see if you can do it. Let's analyze. Try this. Try this. Okay, let's see. Mid-oceanic ridges are associated with the rising convectional currents. See here. Rising convectional currents and mid-oceanic ridge. We will be doing all this. Yes, rising convectional current and the mid-oceanic ridge, and this is how seafloor spreading is taking place. So the statement that I mentioned here is correct. Mid-oceanic ridges are associated with the rising convectional currents. Correct. Nothing wrong here. Nothing is wrong here. Clear? Next. Oceanic crust becomes older as we move away from the ridge. Yes. The ones which are close to the ridge are the freshly formed crust. As you move apart, move away, it is the age increases or age has increased. So, 2 is also correct. Seafloor spreading occurs at convergent place boundaries. No, it is diverging. Diverging. Right? So, this is wrong. 1 and 2 are correct. Yes or no? Answer is A. Clear? Clear? Done? Okay. Everybody clear? Clear, everybody? Done? Can we move ahead? Ocean and continents. Now, this is a chapter, rather a part where we study basically about the various concept of sea floor spreading, continental drift theory. Okay, I'll give you 10 minutes break, don't worry. Continental drift theory, sea floor spreading, plate tectonics, and the various other theories that are present, right? So all these theories I will be covering in the ocean and the continents topic, and it is a request to you everybody that this topic is very important, not only from the prelims point of view, but from the mains point of view. After the end of this particular ocean and continent, I will be creating certain very interesting multiple choice question in front of you. And I want you to answer. Till now, if you would have seen that so many questions we have solved. The way you solve the question is very, very important because see, When you study these concepts and the content that I have provided, by default, your knowledge will increase. But there is something known as the art of solving MCQs. That art is being developed right now. Right? I'm giving you 10 minutes break, and this 10 minutes break, just rest for some time, eat something, and then we will begin the top. We'll again finish this ocean and continent in next about 45 minutes, and then we'll move on to the next chapter also. Clear? So I'm giving you 10 minutes break. Hello, hello, hello. Hello, am I audible? Hello, hello. Am I audible? Chalo. Good. Okay. Okay, students. Hi. Okay. Now see, I have come, let's say, before that only, ocean continents. Now see, this is very, very important here. Why? Because in the topic of ocean and continents, now, the theories which come here are very important for the conceptual understanding, and they have repeatedly come in the prelim examinations. Like they will ask you with respect to continental drift theory, they'll ask you with respect to plate tectonics, and they want to test your acumen whether you are able to solve and explain it or not. Please understand, earlier on what used to happen, people used to think if it is a preliminary examination or you're giving the prelims, they will not ask you conceptual questions. So people used to skip this topic of plate tectonics. Who will ask, doesn't matter. Continental, who will ask? They can ask simple questions. This was the perception. In today's time, when you're preparing, you realize this question can be asked in the mains examination also in detail and in the prelims examination. So if your conceptual clarity is there and you know the topic, whether it is prelims or mains, the only difference is that in the prelims you are filling those circles and in the mains you are writing the complete answer. So that is why we say prelims and mains is a very integrated preparation. Clear? So make sure that you understand every topic. If you have any problem, I'm always there to explain. I'm always there to repeat it. So don't need to worry about that. Clear your doubts. This video is going to be available till time immemorial, right? So I know many of them are having various classes, some tests and all. You can watch later on also. But if you are watching live, you can be solving MCQs with me. So that is an interesting task. Hopefully till now, when you were seeing that I'm putting on so many MCQs, creating on my own on random right now, and many MCQs I've displayed, hopefully you would have enjoyed that. See, MCQ solving is one of the most interesting things. If you start loving solving MCQs, I'm telling you that is the first symptom, or not symptom, first identification of a point that you might be getting through the prelims relatively easier, because in an easy way, because loving MCQs solving is also an art. I used to love solving MCQs, and that is why possibly it became relatively easy also to get through the prelim examinations also. So love to solve them and love to write answer. If you have two characteristics majorly, you will love to solve MCQs and you have a love to write also. So both the characteristics are fulfilled for the examination, because in the prelims they want to check you with the MCQs, and the mains answer writing. Whether it is prelims, whether it is general studies, whether it is optional, whether it is essay. Okay. अभी टेस्ट चल रहा है, कोई बात नहीं बेटे, just see here. Okay. This is again a handmade diagram, handmade map in front of you. The one in blue is basically the ocean, and the one which I have mentioned over here in the form of these green dots is a continental part, right? Now, if I want to study them, let us note down certain features and then we will go into the theories also. Certain observations, these statements which I have mentioned over here, UPSC has asked questions on them also, and we will study that also. See, water is 70.8% and land is 29.2%. Please remember, out of the total surface of the earth, if you see, water is close to 71% or 70.8%, and land is 29%. More than 75% of the land is in the northern hemisphere. Do you realize why? Now, I had given you the answer also why summer solstice and winter solstice are named on the basis of the convention that the people are more in the northern hemisphere. That is why you see land is also 75% in the northern hemisphere. The majority of the population is also in the northern hemisphere. So the convention of naming them summer solstice, though it is summer in northern hemisphere and winters in southern hemisphere, still it is called summer solstice because of the predominance of the people living in the northern hemisphere. Second, Pacific Ocean occupies 1/3 of the total surface area of the earth. Northern pole is surrounded by water while south pole is by land. You know that very well that South Pole is located in Antarctica, and Antarctica is a landmass. North Pole is in the Arctic Sea, which is again a sea. So that means North Pole is surrounded by water in a way and South Pole by land. Clear? Next. Yes, Deepak, absolutely. Continents are roughly triangular in shape except Antarctica and Australia. This is very interesting. This can be asked in your preliminary examination also. There was a boy Prashant who was mentioning Savinder Singh and all. Even Savinder Singh mentions this point, that continents roughly are triangular in shape. Right? Clear? Okay. Now see how. Do you realize it is somewhat triangular? It is somewhat triangular. It is somewhat triangular. Over here, triangular shape. You see, this is a statement mentioned somewhat triangular. Except Antarctica and Australia. Yes, Antarctica is not triangle. It is not roughly triangular. So, we can mention them, they're somewhat triangular. This is a statement again made in certain standard books also. So, we can accept this because we will be studying why it is mentioned. Okay. These are certain observations that are there. These are standard observations. Questions can be put on the basis of them. I'll be creating MCQs after this end of the chapter. So, be well aware of these points. Clear? Okay. Views and theories of the evolution of ocean and continents. Please remember, you all studied the concept of origination of the solar system, universe and all. Now the question comes, how did these evolution of ocean and continents took place? Now see, till now when you study the various theories, you might have studied continental drift theory by Alfred Wegener, but there is a continental drift theory also by Taylor. So I am covering all the theories. This is from the prelims as well as the mains perspective. So please listen to this very, very carefully. Once you are done with this, any question that comes from this topic, you will be able to solve it. Tetrahedral hypothesis by Lothian Green, continental drift theory by F.B. Taylor, continental drift theory by Alfred Wegener, convectional current theory by Arthur Holmes, concept of seafloor spreading by Harry Hess, and plate tectonics theory by Mackenzie and Parker. Clear? Yes, Pankaj, it will be sufficient, possibly only when if you studied properly. Remember, if you studied properly, yes, then it is sufficient. Clear? Are these 6 concepts visible to all of you? Based on these 6 concepts, I am going to base this chapter, and this is very, very important. Let's see one by one. Remember, when I'm doing these concepts, it does not mean that every theory is correct. There are going to be defects with every theory. We just have to understand what the theory is saying and then move ahead. Okay, let's see. Tetrahedral hypothesis by Lothian Green. What happens is, see, these are types of statements which are made when people have not basically seen Earth or observed Earth from various angles. They said that Earth is like a tetrahedron. Now, please understand, have you seen a triangle? Now, if you realize, if I create a 3D figure of this triangle, let us see. See here, if I fold, let us say, 4 equilateral triangles, one this side, one this side, one this side, and one below. Can a 3D figure be formed? A 3D triangle can be called a tetrahedron. Can you visualize that? Supposingly, I have 4 equilateral triangles, one equilateral triangle, another equilateral triangle, and another equilateral triangle, and one below them. So it will form a what? A tetrahedron. See, this is an equilateral triangle. This is one side of equilateral triangle, one side, and one behind that. So 4 equitriangles are merged like this. That is known as a tetrahedron. Clear? Clear? Exactly. Prism. Exactly. Now what Lothian Green says is that various continents and oceans are located on various parts of the tetrahedron. He said that all these edges or the pointed points are actually basically what? Are basically continents. Exactly as a pyramid. Absolutely correct. He said this point is North America and South America. This point is Asia and Africa. This point is Antarctica and this is Europe. And the planar surfaces are basically what? The oceans. This is Arctic Ocean and the back side is the Pacific Ocean. So as you see a pyramid now, similarly like this. Now the question arises is, this is considered like a stupid concept. Why? Because you know that Earth is not in a tetrahedral shape, right? But you know that when it was given, see, it was given in 1876 based on his thinking that yes, it is like a tetrahedral. So he has given this view. So he said Earth is in this particular shape. It is a combination of 4 equilateral triangles joined towards to form a tetrahedral. And at the edges of the pointed edges are the what? Continents. And the planar surfaces are what? The oceans. So this is what was the main idea of Lothian Green. And it is completely a crap concept, you know that. But still, let us understand what he's saying. He said Earth was earlier a sphere, later on turned to tetrahedron. He said Earth was earlier sphere, but due to cooling now it has turned into a tetrahedral. That is again, we have to study it because it is given, otherwise it is a wrong concept, you know that. Apex are continents and land. See here, apex, that means these pointed edges are the continents of the land and these flat parts are the oceans. The flats are the oceans and the back represents the Pacific Ocean. That means the back side represents the Pacific Ocean. Now see here, what is the criticism? We know that very well the balance of Earth cannot be maintained in a tetrahedron. It shows permanency of continents and ocean. This concept shows that the continents and oceans are permanent and you know that very well they are moving. And you know that very well the balance cannot be maintained by in a tetrahedral shape if it is rotating. So this statement or this theory was again considered a crap concept, but still we studied because it is a major perspective towards studying the future theories. Let's see. Continental drift theory by Taylor, sorry. First we'll do by Taylor, then by Wegener. See, when you are taught basically these theories, in the NCERT basically mentions about Wegener. It does mention about Taylor, but not in detail, just a statement is mentioned. So, but we are dealing with the theory of continental drift theory by Taylor also. Let us understand this. The main purpose, what was the main purpose that Taylor basically gave this theory? See, this hypothesis tries to explain the origin of the folded mountains in the tertiary period. You know that tertiary period are basically the young fold mountains that were formed like the Rockies, Andes, Himalayas and the Alps. And Taylor wanted to explain how these mountains would have originated. So he thought that I will give a theory. So he gave his continental drift theory. What he said is, please understand, his theory says that there were 2 land masses during the Cretaceous period. Please understand, he starts his theory from the Cretaceous period, which is 64 to 144 million years ago. He names that there were 2 land masses. See here, there were 2 land masses. Please don't get confused between Wegener and Taylor's theory. Both are different. I'll be explaining you the difference also. Let's see it first of all. See, Cretaceous period, one is Laurasia, another is Gondwana land. He said Laurasia was located near the North Pole and Gondwana land near the South Pole. So let's see the diagram. He said that it is located near the North Pole, it is located near the South Pole. According to Taylor, right? Very different from Wegener. The land masses started moving in 2 ways. He said these land masses started moving towards each other and also towards the western direction. See how it is moving, understand this. He says that there were 2 land masses. One was Laurasia and then close to the North Pole right now, and South Pole, the Gondwana land. These 2 were moving like this. That means they are moving towards each other also equatorwards and westwards also. So what happened? The driving forces responsible for both types of movement were the tidal forces of the moon. That means, he said, the moon's effect on the earth is a reason why this movement was taking place. Clear? Movement is taking place because of the gravitational force of the moon. Clear, everybody? Next, according to Tyler, during the equator movements, continents deformed and the edges mountains were formed. So he said while the continents were moving, their edges got distorted because of the movement and mountains were formed there. So he has basically, in order to explain the young-fold mountains, he has moved continents for that. Though which basically is like a very berserk concept, but still he has given this concept. See here. So he basically says that there are continents that are moving. Two land masses were there. Laurasia near the North Pole, Gondwana near the South Pole. Both of them were moving towards each other and westwards. While moving, the edges of them basically got distorted and mountains were formed there. And this movement is because of the tidal forces or the impact of the moon. This is the theory. Have you understood the core of the theory? Everybody, quickly tell me the answer so that I can move ahead. If you have any query, I can explain it again. Everybody, have you understood the continental drift theory, the concept by Taylor? Quickly. Again, let's repeat. First of all, the reason for this explanation was he wanted to explain the young-fold mountains first. Second, his theory basically says that he took the Cretaceous period. Cretaceous period is from 64 to 144 million years. That means this was the time this process happened. He gave two land masses. One landmass Laurasia and other Gondwana. He said both the land masses were moving towards each other and westwards. Both of them were moving. This landmass and this landmass is moving towards each other and this one, like this is the direction. See here. Like these two land masses are moving towards each other and westwards. So in this direction. He said while it is moving, the edges over here, the edges might develop, let us say, get distorted because of the movement and mountains might develop there. So just to prove that the mountain development activity, he has moved continents. Now, please understand this. All these movements are taking place because of the tidal forces of the moon. That means gravitational force of the moon. Clear? Yes, yes. He has only mentioned the gravitational force of the moon. This is the statement by Taylor, or Tyler you can say. Criticism, he made the continents move to great extent to explain the formation. Criticism is there. Second, tidal forces are not so strong. See, tidal waves can cause, these gravitational force can cause tides. Tidal forces here refer to the gravitational force of the moon. Now, gravitational force of the moon can cause tides, but they are not strong enough to move the continents completely. Forces within the earth have not been considered. So that means endogenetic forces or what are the movements inside the earth have not been considered here. So that is an incomplete theory. Clear? It is incomplete. Clear? Yes, it is like to kill the ant, a cannon is used completely. Yes, absolutely right. Next comes the continental drift theory by Alfred Wegener. Now this is where most of the books basically emphasize on. NCERT also mentioned them in detail. Most of the books also mention it in detail because this concept is again a better concept, more latest one, and even little bit better accepted than the concept that is given by Taylor. Let's see. Main purpose is he grew out of the need to explain the variations in the climate in the past. He wanted to explain how the climate was different in various parts of the world, and keeping that in mind, he created this theory. So you need to understand what is the intent and reason for creating a theory. Assumption. Wegener assumed that continents were moving while the climate belts were stationary. He said the climatic belts are stationary. It is the continents which are moving. And when the continents come under the influence of various belts or regions, automatically they will be experiencing different climates. Agreed? Supposingly, a continent is here. If it is moving, obviously when it is here, it will experience different type of climate. When it is here, it is experiencing different type of climate. When it is moving here, it is going to experience different type of climate. Just to understand it. So what does it mean? He said the climatic belts are same or constant, but the continents are moving. Clear? This is his major thing, right? Climatic belts, bache, means in the equatorial region, this is equatorial belt, you realize, you will study in the climate chapter, in this region you realize you will have rainfall, you will have high humidity. If you see this region, you will have cold climate, because again you will have a vegetation of a different kind than that of the equatorial region. So we are talking about what type of climate is being experienced in a region. Clear? Okay. Let's move ahead. First theory statement. Alfred Wegener agreed with the view of Edward Suez. What did he do? Alfred Wegener agreed with the view of Edward Suez. He said, I agree with his chemical three-layer system that is given by Edward Suez, or Sial, Sima and Knife. So this categorization which is being given by Edward Suez, that is a chemical classification of the interior of the earth, was agreed by what? Continental drift theory by Alfred Wegener. So this is the first statement that he agrees to it. Next comes, Wegener considered that Sial to be limited to the continental crust, whereas oceanic crust is represented by Sima. He said that Sial is not present in the oceanic crust, only Sima is present. Continental crust is majorly comprises the Sial. All land masses were united to form one Pangea. Now understand, what does he say? He said that there was one landmass. That landmass was known as Pangea, and there was one uniform body, one water body, Panthalassa. So this is one body, that is Pangea, and this whole water body, other parts are known as Panthalassa. You know that very well that Taylor had used Cretaceous period to explain his theory, whereas Wegener is using Carboniferous period 286 to 360 million years ago as a basis of his theory. These are the differences also. Taylor used Cretaceous theory, Cretaceous period, whereas he used Carboniferous period to explain his concept that from here these changes started taking place. This is again a very, very important difference. So Carboniferous period, you very well asked us sometimes, sir, why in the mains examination marks have not been provided to us? Why in prelims we were not able to attempt it? Because we tend to miss out these minute details which are very important. Taylor represents, I will make a chart if you want also. Cretaceous period Taylor, Carboniferous period, what? By Wegener. Over there, Taylor mentioned that there were two bodies, Laurasia and Gondwana land in the northern and the southern part. Here he mentioned there is one body, that is Pangea, and one water body, that is Panthalassa. Clear everybody? Understood? Now see. This is again a handmade diagram that I have made for you. 225 million years ago, he said again, this initially it was one body, slowly, right? Slowly you will realize a movement started taking place. This is 225 million years ago. MYA means million years ago. After 150 million years ago, you realize that further movement takes place. Then you realize first, second, third. You realize further. See, this is the peninsular part of India. You see this? You see this? It was again slowly it is moving, and finally Earth today is what it is now here. Clear? Clear? So this is how the movement has taken place. Now see here. Laurasia consisting of present day North America, Europe, Asia formed the northern part of Pangea. He said Pangea can, over here also please understand, he divided the Pangea also into two parts. Pangea into Laurasia and Gondwana land. Laurasia, the upper part, formed the North America, Europe and Asia, and the Gondwana land formed the South America, Madagascar, Peninsular India, Australia and Antarctica. This question has been asked, right? This question has been asked in the preliminary examination. Which of the following basically formed the Gondwana land or Laurasia? So you should be aware of this part very, very well. Very well. I will create an MCQ also on this. Let us understand this first. He said Pangea was disrupted during a subsequent period and land masses drifted apart. Now the thing is that he said that there is a landmass, one Pangea. One Pangea over here, you realize, now is breaking and moving apart. Moving apart. See here. He first mentioned equatorwards and westwards due to the gravitational differences and the tidal force due to the moon. Again, please understand over here also, the major dimension which Wegener has focused on is those polar fleeing forces absolutely and the tidal forces. Here also, if you realize, the major emphasis is on the gravitational force of the moon. Because of that force, you realize that this movement is taking place. Certain dimension you will realize in equatorwards also, but moreover westwards movement is taking place. That movement overall you will realize is an outcome of the gravitational force of the moon. So over here again the same thing is here, that they have emphasized on the gravitational force of the moon, which is basically the cause for the movement. Let's see here. He has given certain evidences now. Let's see the evidences. Just a fixation of the continent. This was asked in the paper this very year, right? This year, the last year, right? Yes. Polar fleeing forces and tidal forces. Yes, again, it is an outcome of the gravitational forces of the moon. South America and Africa, if you basically come together, they will basically just a fix, like a puzzle, like they were part of each other. So shorelines of Africa and South America facing each other have remarkable and unmistakable match. Assumably that they were in the past together, that is why they can fix in this manner. Next is rocks of the same age across oceans. If you realize, radiometric dating have been done, and based on the radiometric dating you realize that if you see the rocks on Greenland region, this is the eastern part of United States, this is the Iceland and UK wala region, Scandinavian countries and Africa. These rocks have a similar age. These rocks have a similar age, and people realize that this is how is it possible when there is an Atlantic Ocean between them? How can they have similar age? They said possibly they were together in this manner. That is the reason possibly they have the similar age. So rocks have similar age. This diagram is again important here, right? Next, the age was found to be 2000 million years ago, right? Next is tillit. Now tillit are again deposits that were present. These are glacial deposits. If I bring all these continents like this, there are deposits that have been found. Deposits, oh, just a minute. Deposits over here, 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 here. It is like they were together possibly, and similar type of deposits have been found here. These are deposits of the glacier, like glacier deposits. So sedimentary rocks are formed by the deposits of the glacier. These are tillit deposits, glacial deposits. So possibly they were together. This is the evidence. Next are the placer deposits. Now please understand, these are deposits of sand and gravel in the bed of the river or lake containing particles of valuable minerals like the gold. These are known as placer deposits. And you will realize very similar type of placer deposits are found here, 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 and even here also. So possibly it is assumed they were together. That is why such deposits are here, right? Then distribution of fossil. Now, if you study the distribution of the fossil remains that have been found, you will realize that if I bring the continents together, over here fossils have been found. Cyanogathus, over here Glossopteris has been found. Lassosaurus has been found. Mesosaurus has been found here. So if I bring them together and the fossils which I study, there is a very specific resemblance. That means possibly they were together. That is why the fossil arrangement is in this manner. Clear? So fossils of flora and fauna found in the various continents in a specific arrangement has been found over here. So we realize that means possibly they were together, right? So these are the evidences that we basically found. Now comes the criticism. Remember, this is a 15-marker question that has come in your exam in the prelims as well as the mains. Mains, it has come 15 marks, right? 15 marks. Prelims, so it is after every time it is repeated after few years. Lack of mechanism. Wegener could not explain a satisfactory mechanism to explain how continents moved. He was not able to explain. He has given his stories. He was not able to explain how it is actually moving, right? He ignored the oceanic currents. Wegener's theory mainly focused on the movement of the continents and did not adequately account for the behavior of the oceanic crust. He did not basically explain about the oceanic crust, what are the changes taking place. One more thing, South America and Africa, the juxtaposition that has been present, it is not a complete juxtaposition. Now, if I tell you, see here, if I invert this particular this cup and put it on the top of this, sorry, does it mean if that juxtaposition is happening, that means this was a part of this? No, no. There can be by mistake also, it can be an outcome of certain coincidence also. It does not mean that two things which are juxtaposition does not mean that they were initially parts of each other. Yes or no? So many scientists have said that that is a very wrong interpretation. Complete juxtaposition is not there. Wegener did not elaborate on the direction and sequence in a proper manner. He just mentioned about the pole fleeing forces and tidal forces. He does not explain it properly. That is one of the reasons. So this was what? The continental drift theory. Clear to everybody? Done? Is the concept clear? Now let us come to the next part, which is the convectional current theory by Arthur Holmes. This is one concept, though you have studied this, we will basically briefly study it, what it basically means. Now see, if you see, this is a mantle, right? Study of the convectional currents become important, right? Clear? The study of the convectional currents become important because they form the basis of your understanding of the plate tectonics theory also. Now please understand, he says that there are convectional currents in the mantle that move in a cyclic manner, in a very cyclic manner. The region where the currents basically rise, it is known as upwelling of the current. The region where it sinks is known as downwelling of this convectional current. Clear? This is happening in what? The mantle. Now let us understand what he says. Convectional currents, the person is Arthur Holmes, very, very important. To explain the Earth's lithospheric plate and dynamic processes that shape the Earth's surface. Now he wanted to understand how basically the plate movement would have taken place. And there was a lot of views, but he wanted to explain. So he came up with the concept of convectional currents. He says that Earth's mantle is a layer of semi-solid rock beneath the Earth's crust. Now he says there's a layer that is semi-solid, plastic in nature, that lies beneath the Earth's crust. Now within the mantle, heat is generated by the radioactive decay of elements. Now please understand, there are radioactive elements that are present and that are basically providing a continuous amount of heat that is basically being generated, right? Now with the heat being generated, you realize that the heat generated in the mantle creates the process of convection. Hot and less dense material rises upwards, that is upwelling, and the cooler and the denser one basically sink, that is downwelling. The convectional current is responsible for tectonic plates because understand, if there is a plate here, let us say this is a plate, convectional current is rising, it will pull this movement. Let us say this is a plate, convection current rise, they move, so it will apply a force on the plate also and force it to move forward. So convectional currents are forcing the plates to move forward. That is what is the basis of convectional currents over here. Let's move ahead. Is this concept clear? See here, when this convectional current is moving, it is basically known as slab pull. That means it is forcing this plate to move ahead. That is why how it is moving downwards inside, subducting, because of the pressure that is being exerted by this convectional current. How is this moving this-ward? Because of the pressure that is exerted by the convectional current. Clear? Okay. Now comes the concept of seafloor spreading. Again, seafloor spreading, very important to understand the plate tectonics also, as well as how it is related to convectional current. We'll understand that also. See, in 1960, Harry Hess gave a unique concept to explain the mid-oceanic ridges. You know mid-oceanic ridges? At the diverging plate boundaries, you know, again the magma comes out, and then over here all the lava, and there is deposition over here, which leads to a creation of ridge-like structure here. Mid-oceanic ridges, that is why are found in the diverging plate boundaries. Clear? So he wanted to understand the reasons why, how these mid-oceanic ridges are formed and the dimensions associated with them. So what he did is, he wanted to find the origin of mid-oceanic ridges. So he gave certain views. Let us understand them. He postulated that mid-oceanic ridges were located on the rising limb of the convectional current in the mantle. See here. This is the rising limb. Both these are rising limb. That means upwelling. That means rising limb, they are located at the rising limb. That means here, beta, please remember, mid-oceanic ridges are not only present in the Atlantic Ocean, they are present in the Indian Ocean also, they are present in the Pacific Ocean also, everywhere. It is not limited. Yes, the Atlantic Ocean ridge, the mid-oceanic ridge is very dominant, a very important one. That is why we study it very often. But it is present everywhere. So can I say this is again at the rising limb? So let's move ahead. He postulated that the mid-oceanic ridges are present at the rising limb of the convectional current. That was one thing. Now let us see this. Rise of the convectional currents creates tensional forces on the surface. Spread in the opposite direction, it is known as a spreading point. Let's understand this. Supposingly these are two plates, right? This is the distance, the gap between them is representing the region of the mid-oceanic ridge. This is, you will realize, let us assume over here the convectional current is rising. Now when it rises, it will create force on that. This force will help lead to these moving apart, whereas fresh deposition is taking place. Fresh magma is being deposited in the form of, right? Tension, that means tensional forces, a force being exerted by the tensional forces over here. Over here means that the forces of the convectional currents are exerted on the crust, on these lithospheric plates, which are basically forcing them to move apart. Clear? The region where it is moving apart is known as a spreading point.
I've added that to the list.
Oh, sorry. Siri started speaking. So this is known as the spreading point. Let's see this on the diagram. This rising limb, it is moving apart. So this is what the spreading point. Clear? Spreading point. Yes. Now please understand this. The place of descending convectional current, compressional forces. Opposite of compressional forces are the tensional forces, right? Compressional forces, descent of crustal current, subduction zone. Now see here again, let's see. This was again the tension, that means they are moving apart. Over here the descending means there are both this plate is going to subduct under another plate. So this part is known as the subduction zone. Why subduction zone? Because this plate is subducting or moving beneath this particular plate. Clear? Clear? So this is moving beneath this particular plate. So this point is known as subduction zone. Clear, everybody? And you will realize this is the downwelling of the convectional current. So this is what? Where is it? Descending crustal material, subduction zone. Clear till here? Now let us understand. The crustal material are spreading from the mid-oceanic ridges, and the sea floor is moving on either side is known as sea floor spreading. Now realize this, that do you realize as this will move this side, new crust will be formed here, new oceanic crust will be formed, while this will go inside and again melt or become a part of it. So fresh crust will be formed, that means new oceanic crust are continuously being formed. On the other hand, you know that this is spreading on either side. This movement of spreading is known as sea floor spreading. sea floor spreading. Is it clear? This is known as sea floor spreading. Everybody clear? Or any issue? Clear? Again, spreading point, where it is spreading, subducting point, where the plate is subducting. Spreading point is always related to the, let us say, upwelling of the convectional currents, and subducting zone is associated with the downwelling of the convectional currents. This movement of the convectional currents force the plate to subduct. This region is a subduction zone. Over here, as this plate moves this side, fresh lava is deposited and this new crust will be created, which will further keep on moving. That is why you realize that oceanic crust are younger than the continental crust. Now understand, let us take 2 points here. See here, point A and point B. Point A and point B. Yes, exactly. Compressing forces on zone on, yes. The region, what does subduction mean? Ujjwal, understand, supposingly someone sits on you, presses you down, it's subducting you. That means there is some compression. The reason where the point where a plate is moving below another plate, that region is known as subduction zone. And it is because of the compressional forces. Yes, because over here, this convectional current is forcing to come here. Over here, this convectional current is forcing. That is why the one which is denser is moving down. Clear? Answer this question. Based on the diagram that is present here, answer this MCQ. Which among the following are correct? Point A, rocks are older than point B, rocks, let us assume. Point A rocks are older than point B rocks. Subduction is related to compressional forces. Upwelling of upleveling of convectional currents is related directly to the mid-oceanic ridge, right? Options: 1, 2, 3, B, 2, 3, C, 1, 2, D, 1 and 3. What is the answer? What is the answer? Give the answer quickly. What is the answer? Point A rocks. This is point A, this is point B. Point A rocks are older than point B. Subduction is related to compressional forces. Upwelling is related to convectional currents are related to directly to the mid-oceanic ridges. Now understand. Subduction is related to compression. Correct. Correct. Upwelling of the convectional current is related directly to mid-oceanic ridges. Correct. Just tell me one thing. This seafloor spreading, that means this is going to move this side. Do you realize few thousands of years ago, like a few hundreds of years ago, this point would have been here? Yes. So that means this is younger because it is closer to mid-oceanic ridges. Let us assume, assumably, this is 1000 years old. This possibly might be 2000 years old. That means A is younger than B. But I have written point A rocks are older than B. So this statement is wrong. So one statement wherever it is present is wrong. 2 and 3 is the answer. Right? Doesn't matter. Those who have enrolled, you can enroll now. Those who will be enrolling after the class, make sure that you enroll after the class. Otherwise, you will be missing on the test and all. Those who can enroll now when I give the break, then, or after the class when it gets over, immediately then enroll. Okay, doesn't matter. Is the answer correct now? The answer is 2 and 3 only. That is the concept of seafloor spreading, na? The one which is closer to the mid-oceanic ridge is younger. The one which is far off it is older. The one over here C is the oldest, even older. That is a major concept, right? Clear? Exactly. This statement, what has been mentioned by Scroll with Vivek, age increases as we move away from the mid-oceanic ridges. This has been asked in the prelims. The statement this gentle boy has mentioned has been asked in the prelims. That is why this is the concept which I wanted you to understand. As you are moving far away from the mid-oceanic ridge, that particular point, the age is more. The closer you are to the mid-oceanic ridge, the age is younger. Clear, everybody? Okay, next. Evidences. Now, please understand, you should understand something with respect to polarity. Very often you realize that Earth behaves like a magnet, right? That is why the compass are able to work. Now, whenever you use a compass, you know, okay, the North Pole, South Pole and all, it is an outcome of the polarity because Earth itself is a magnet. The Earth behaving as a magnet is because of the convectional currents which are moving, right? There have been instances where the direction of the convectional current changes. That means supposing it is moving like this, starts moving in the opposite direction. And that is why you realize there has been reversal in the polarity. That means North Pole becomes South Pole becomes North Pole. That is magnetic North Pole and South Pole change. Now, there have been a lot of instances. Now, please understand why that concept is relevant over here. Please understand. When the magnetic material comes from the inside of the Earth, whatever is the polarity of the Earth, the magnetic material align themselves according to the polarity of the Earth. Please understand it again. Earth behaves as a magnet, right? Earth behaves as a magnet. The magnetic nature of the Earth has closely got to do with the convectional currents that are going on. Now, the convectional currents that are going on, there have been reversal in the convectional currents over the history. Over a long period of time, this process has taken place. So what happens is, when the magnetic substances in the form of iron, nickel and all are coming out, whatever is the polarity of the Earth, these elements basically align themselves according to the polarity. So what we have seen is, supposingly, this is the fresh magnetic material. So freshly, let us say metals have come out. Let us say iron and nickel, and this is a polarity, and they have arranged themselves in this order, like South Pole upwards, North Pole downwards. And you realize before that North-South was reversed, so they have aligned themselves in this direction because this will further move apart. At equal distances, you will see similar set of polarity. This is the same polarity because it has freshly come out. If you move further apart, you will see both have North Pole in the northern part, South Pole southern part. That is magnetic north and south. If you move further towards the east and west, you will realize similar polarity. If you move further apart, similar polarity. That means, right, that how is it possible that similar type of polarity is present at equal distances when we study the floor of the oceans, right? And then it was basically studied. It is because fresh sea floor, let us say, deposition of the magnetic material takes place, and there is arrangement of the let us say iron and nickel based on the polarity, and that keeps on continuing because this is further moving apart. So this polarity basically helps or gives us evidence that sea floor spreading is taking place. And that is why this is a very, very important evidence. That means alternative bands are present over here. Clear? Okay, let's move ahead. Earthquakes and volcanic activities. Distribution of earthquakes and volcanic activities are concentrated in the mid-oceanic ridges and plate tectonic movements. You know that mid-oceanic ridges are also centers of the volcanic activities, so that also provides some evidences. You realize mid-oceanic ridges, the presence of mid-oceanic ridges itself points out how they are created. Possibly magmatic materials coming out, that is why those ridges are created. So that is also an evidence. Age of the oceanic crust. Oceanic crust in the mid-oceanic ridges are younger than the ones which are far away. That is far away. So you realize this, that means the ones which are younger, that is close to the mid-oceanic ridge, that means freshly created oceanic crust is there. That means possibly that fresh crust is being created. The ones which are older is older in nature. That means possibly there is movement also taking place. So this is also an evidence. Clear? Okay. Finally, we come to the last and the major theory over here. That is plate tectonics theory by Mackenzie and Parker. This theory, if you have studied all the concepts which I have explained you, continental drift theory, sea floor spreading, and the convectional current theory by Arthur Holmes, these three form the basis for the plate tectonics theory. How? Please understand. Convectional current theory basically says only the continents are moving. That is wrong. You know that very well, because what he saw is, right, what he saw is, yes, please see, he saw that the continents are moving, but reality is the plate is not confined to the continent. It is extending even beyond that. So the concept of plate tectonics came here, and these three theories which I mentioned right now form the basis for the plate tectonics theory. Let's understand. The theory tries to explain the dynamic movement and interaction of the Earth's lithospheric plates, which make up the outermost shell of the planet. Now, he is trying to explain how these plates are basically moving. Let us understand. What is a plate, first of all? The rigid lithospheric slab or rigid solid crustal layer technically is called a plate. What is a plate? The rigid lithospheric plate or the solid crustal layer, which is the outermost part, is known as what? A plate. The whole mechanism of evolution, nature and motion of the plates is known as plate tectonics. What is plate tectonics? How these evolved, what is the nature of the plate, how they are moving. All these concepts combined are known as plate tectonics. Clear, everybody? Let's move ahead. What is the basis of the theory? Continental drift theory and seafloor spreading. If you want to add one more thing, it can be convectional current theory. Obviously, you know that for seafloor spreading, you need to have convectional current theory also. So those three theories form the basis of the theory. Now let's understand driving force and the mechanism, how it is working. Plates are in constant motion, driven by internal heat generated by radioactive decay in the Earth's mantle. That means the mechanism behind it is convectional currents. Convectional currents. So what is the driving force of mechanism? It is a mantle convectional currents. So you have already studied in the seafloor spreading. The driving force of the mechanism behind the plate tectonics are the convectional currents. Clear? Okay. Now let us understand the plate tectonics classification. Let's see. If you see the classification, there are two types of classification. One is geometric and other is kinematic. You can be asked in the examination also, right? Geometric means there are 7 major plates and 22 minor plates. Major means larger size, minor means smaller size. Major are North America, South America, African, Eurasian, Antarctican, Pacific and Indo-Australian. You can be asked in the examination which among the following are the major plates, which among the minor plates. This has been asked in multiple preliminary examination at the PCS level also, and once or twice has been asked in the UPSC also. So we can ask it again. Minor, these are few important ones, but they are 22 in overall. Arabian plate, Nazca plate, Philippines plate, Scottish plate, Cocos plate, and similar other plates. These are what? The major and the minor plates. If you want to see the diagram, see here. See here. Everybody see here. this is the North American plate. This is the South American plate. This is the African plate. This is the Eurasian plate. This is Indian Indo-Australian plate. And other part is the Pacific plate, right? And over here is the Antarctic plate, the major plates. Now let us see the minor ones. For example, Caribbean plate is here. It is basically between the North American plate and the South American plate. Then you have the Joie de Foco plate. It is between the Pacific plate and the North American plate, this part, again a minor plate. If you see over here, this plate is the Cocos plate, this plate. See here. This is the Cocos plate. Now understand, it can be asked also where these plates are located. It is located at the intersection of the Pacific plate, North American plate, Caribbean plate and the Nazca plate. Now please understand, this is a Nazca plate. It is also a minor plate, but an important plate. Why you should know these location is because you can be asked, right? You can be asked. This is what? This is a Cocos plate. This is a Nazca plate. If you see over here is a Scotia plate. This is minor plate. It is located surrounded by one Antarctic plate and the South American plate. Clear? Now comes the Arabian plate. This is the Arabian plate. Now, if you realize, they can ask you the Arabian plate is surrounded by which all plates. They will mention certain plates and you need to know. You know that UPSC can very well ask you. So, can you see the Arabian plate is surrounded by what? First, the African plate, the Eurasian plate and the Indo-Australian plate. This is why I have made the diagram over in front of you, because if you rote learn this, you will never be able to remember it. I'm guaranteeing you. But if you see through map, because you can download it later on, provided you enroll it, you will be able to understand it. So if you see here, Arabian plate is surrounded by this region, see? This boundary is of what? The African plate. This part is of the Eurasian plate. This part is of the Indian-Australian plate. Even Indo-Australian plate also is divided into two parts. This is the Indian plate and this is Australian plate, but you can take it as one. Clear? Clear, everybody? This map is a Brahmastra for the plate tectonics. Everything over here is mentioned. If you do this map, any question on minor, major plate, whether it is surrounded by this, that, whatever, you can do all the questions. Just have a look at the map. See it for yourself. Let us see another. Philippines plate. Again, very often asked. See the Philippines plate also. See here, this part over here, the Eurasian plate, over here surrounded by the Pacific plate. Right? Clear, everybody? Clear? This is again very, very important. Please practice this when you download the notes, because this will help you in a long way, because questions are repeatedly asked, which among the following is major or minor. Let us do one MCQ. Let us do one MCQ on this. Which among the following are correct? Solve it. Solve it. Yes, Kailash, it is. You can very well see this. Use your common sense and memory a little bit, and let's see. If you can solve it now after revision, see, imagine you can do it, so you can do so well, right? Okay, people are saying, some are saying B, okay? Right? Okay. Arabian plate is a major plate. We know that very well, that this is not true. It is a minor plate. So, the moment I say one is wrong, this goes, this goes, this goes. Automatically the answer comes. It was a very easy question. Why? Because the moment you say one is wrong, other options are eliminated. Right? Clear? Done? Okay. Let's study this now. Okay, bache. We have studied from plate tectonics from first the geometric perspective. Done? Now let me teach you from the perspective of kinematics. Kinematics is convergent, divergent and transverse boundary. We'll understand this one by one now. Please understand, these are three diagrams. This is kinematic, right? Kinematic. Okay. This is geometric. Will you understand both of them? In the examination, they can ask you, what is the geometric classification? What is the kinematic classification? So you should know both of them. Clear? Let us see the kinematic part now. First, divergent boundaries. Please understand, when I say diverging, they are diverging. Can I say diverging is also related to constructive plate boundary? Quickly tell me. If two plates are moving apart, that means they are diverging. But do you realize when they are diverging, then the fresh magmatic material will come out in the form of lava and new crust will be created. So can I say divergence leads to creation of new material or new crust? And can I say diverging is related to constructive plate boundary? See here, divergent boundary, that means these boundaries are moving apart. When they are diverging, there is construction taking place. There is construction taking place. Clear? So, diverging plate boundary means constructive plate boundary. Clear? So, see here. Can I say these regions are spreading sites, regions where spreading of the plates is taking place? And I know very well here the mid-oceanic ridge is located. It will be moving apart. So, when new crust is generated, the plate pulls away from each other and the site where the plates move away are known as the spreading sites. Again, the same diagram, spreading sites. This is the spreading site. They're moving apart. So clear till here? So what can happen? First is example is oceanic divergence. If two plates are oceanic plates, example is mid-Atlantic ridge. Mid-Atlantic ridge is an example of what? The oceanic divergence. Clear? Clear everybody till here? Next, continent divergence. Tell me one thing. I'm giving you example from a very wide perspective. I'm not limiting yourself to continent. Do you realize over here this plate is moving apart? You know that very well. After some time, this is going to come and hit the Western Ghats. Till the time you would have died, don't need to worry. Till that time you would have all died. You will not be alive. You know that this is moving apart. That means there is divergence of the continent taking place. And this part will later on, after a few million of years, go and hit the Western Ghats. Yes? So, tall mountains as huge as Himalayas would be formed here. That is a different case. So, this is the East African Rift Valley. So, there is a Rift Valley being created over here. This line which I have created is a Rift Valley being created here. Clear? Clear everybody? So this is continent divergence. What is the oceanic divergence example? Mid-oceanic ridge. Mid-oceanic ridge. What is continent divergence example? East African Rift Valley, which is here. Now see, now let's understand the convergent boundary, right? Let's understand the convergent boundary. Tell me one thing, whenever two plates are converging, can I say it leads to destruction? Why? Do you realize this particular part has gone inside the mantle? It is destroyed. Do you realize this? Can you see my hand which is below this hand? Whenever there is convergence, some part will be moving, one plate will be moving below the other plate. The plate that is moving below the other plate is again what? This part is getting destroyed. So that means convergence basically is a destructive plate boundary. It leads to destruction. Clear? Leads to destruction. So convergent boundaries can also be known as destructive plate boundaries. There is destruction happening. When two plates move downwards towards each other, where one plate overrides the other plate and other is overridden. That means one is moving towards the other, or let us say it can happen one place is stagnant, other is moving, or both are moving towards each other. Both the cases can happen. In that particular case, one is subducted under the other. The one which is subducted under the other is the one which is of a higher density. Because it is of a higher density, it is going to subduct under the one which is lighter. Yes, it is going to subduct under the lighter. So this is destructive. Now please understand. Let us understand ocean-continent convergence. If a plate, oceanic plate is converging with a continental convergence. Let us see the example. It occurs between an oceanic and continental plate. It leads to the formation of volcanic arcs. Volcanic arcs are long chain of volcanoes that are formed on the continental plate above the subduction of the ocean plate. Right? A set of volcanic arcs are formed. Clear? Next, folded mountains. Rocky Mountains in the North American plate is an outcome of the Juan de Fuca plate along with the Pacific plate. So again, fold mountains will be formed. You know that very well. So that can also happen. Let's move ahead. Foreland basin and backland basin. If you realize, please understand this. Let me explain you with a diagram now. When this plate is subducting below, you will realize after some time, this extra material that has entered the mantle, in order to compensate that, you will realize some type of volcanic activity to a certain extent will be there. This can lead to these volcanic arcs being created over here. Clear? Now, the region over here is this part is known as a back arc basin and this is known as a foreland basin. Clear? Okay. Ocean convergence. Ocean convergence. The convergence of two oceanic plates, it can lead to the formation of trenches. Now, trenches are what? One of the deepest portions of the oceans. If you see here, let me show you the diagram. This part is subducting under this. So you realize this part is little deeper. This is known as a trench. This is known as a trench. See here. This is if you realize this is subducting under this. So this is a deeper part. This is known as a trench. Okay, let's see. Example, the Marina Trench. Volcanic island arcs are formed again. Continent convergence. Example is Himalayas. If you realize, it is a example of again continent convergence. If you realize, folded mountains, Himalayas, Indian plate and Eurasian plate are colliding. Uplifted plateaus, Colorado plateau can be formed. Again, transforms boundary. Transforms boundary can be conservative boundary. Why? Because again, there is no creation and destruction per se. There is no creation or destruction per se. So what do we see? That is known as a transform boundary or the conservative boundary. Now, landforms associated with conservative boundary. First, transform faults. When two tectonic plates slide past one another, transform faults can be formed. We will be studying these in the next chapter, what are faults and all. San Andreas fault in California. You would have heard GTA San Andreas, yes? So there's a fault that is associated. We'll be studying them in the next chapter. Offset drainage. Offsets the river in California, let us say a river is basically flowing, a part is moved. Let us assume it was together over here. A river was flowing like this earlier on. Now this part has moved further. So what will happen? It is changing the pattern through or direction through which it was flowing. So it is offsetting the flow of the river. Next comes mantle plume. Mantle plume, again very important. A narrow vertical column of hot buoyant rocks that rise from the mantle to the crust. It is known as mantle plume. They are thought to originate deep within the Earth's mantle, specifically at the mantle or core boundary. If you see here, let us say this is a plate here, right? This is a plate here. Over here, if you realize, this is, let us say, the mantle core boundary. This like a tail is formed and this is a head. This is a plume that has risen. This is known as a mantle plume. What is this? A mantle plume, like a mushroom-like structure that you can see. This is a mantle plume. Now what happens sometime is, it reaches what? The crustal part, right? It reaches the crustal part. Now this crustal part will lead to what? This is now known as a hotspot, where again the magmatic material will be released on the part which is above it. Let's understand this for a minute. Let's understand what for a minute. Have you ever understood how come the Deccan Plateau is formed or was formed? Everybody understand? While the Deccan, you know that plate tectonics movement, the peninsular part was earlier the part of Africa and started moving towards what? The Eurasian plate. While it was moving towards the Eurasian plate, there was something known as a reunion hotspot. Assume it in this way that when the plate was moving, supposingly this is what the Deccan Plateau was there. While it was moving over a reunion hotspot, there was lot of what? Basalt came out and it basically spread over the part of the peninsular region, which is a Deccan Plateau to be more precise, right? And then what happened? The peninsular plateau moved forward. Later on, you realize, that is why you realize now how come this volcanic eruption has taken place. So there are no volcanoes in that part. There is no volcano in that part, but how come do we have basalt there? It is because, please understand, this can be asked. When the peninsular plateau region or the plate was moving towards the Eurasian plate, for some time when it crossed the reunion hotspot, there was a lot of basalt that came out from here, and that is what Deccan Plateau was formed. And later on, this plate moved forward, and we right now do not have any evidences because there is no lava below that, right? Because there was no volcanic eruption right now where we are. But from where we were traveling over there, the reunion hotspot was there. Now you realize, see, our plate has further moved forward. So that is why, please see, hotspots are again one of the very important principles to study. Deccan Plateau, right? Deccan Plateau. So this is the reason. If Deccan Plateau phenomena, how it is formed basically comes, you can use this diagram also to explain it. Let's see here. See, it consists of hot molten rock magma and rocks that are partially melted. The radioactive elements like uranium, thorium contributing to the high temperature. These plumes lead to volcanic hotspots, such as the responsible for Hawaiian Islands and the Reunion Islands. So later on, what happened when you saw that the Deccan Plateau has already moved, let's say the Peninsular Plateau had already moved ahead. So now what remains are the Reunion Islands. Reunion Islands. See here, the Reunion Islands were formed here. That is a remnant of what used to be the source of the volcanic eruption that took place and covered the Deccan Plateau. I'll be covering this when I will be covering the Indian geography part on 19th, right? Please understand there's a difference between Peninsular Plateau and Deccan Plateau. Deccan Plateau is a step-like structure which is formed because of the hotspot at the Reunion region, Reunion hotspot. Deccan Plateau is a complete peninsular region. So, the Peninsular Plateau is a complete peninsular region. Deccan Plateau is only a part of it, which basically primarily covers the region of Maharashtra, southern parts, some parts of Madhya Pradesh, certain parts of, some parts of, let us say, Karnataka also. So these regions are covered there. So you should be very well aware. I will be explaining you when I will do Deccan Plateau there. Clear? Okay. Done? Okay. Pacific Ring of Fire. Now you know that very well. See, you know that very well that Pacific Ring of Fire is a region which is a tectonic belt of volcanoes and earthquakes are located. It is about 4,000 kilometers long, up to 500 kilometers in wide, and surrounds the Pacific Ocean. If you want to see it, see here. This region is the Pacific Ring of Fire. Now, because this is a tectonically very active region, you will realize this, that large number of volcanoes, large number of earthquakes happen in this region. But because continuous movement is there. So please remember, this is known as a Pacific Ring of Fire. This region has more than 450 volcanoes, constituting 75% of the Earth's total and 90% of the world's earthquakes. This statement can be asked in your papers also. Clear? Okay. Convergent plate boundaries. See here. Volcanic arcs of the Andes is an example of it. Hotspot Hawaiian example, and transform boundaries San Andreas Fault. So these are certain examples that you should just to add on to it. Clear? Okay. So I am giving you right now few. Let us study some MCQs. Can we do some MCQs in front of you? Let's see. Let me write some questions. Which among the following are correct? Which are correct, right? Which are correct? You have to tell me that, right? Answer. Quickly. Please mention ABCD because it becomes easier for me, right? It becomes easier for me rather than writing it. Please mention ABCD, all of you, because it will be easier for me to interpret also and easier for me to understand also. I would request you to do that. ABCD. one more option I'm adding. Now answer. Now answer. Just to add on to test you. Please now answer. Okay, quickly, once more, quickly read the question and answer. I'm giving you 1 minute. Let us see how many of you are able to answer it. 1 minute, answer this question. I've given you 5 options. You can answer out of 5. Okay. What I've seen is majorly the people have answered C, right? Some have answered D. Okay, let's answer. Let's answer. The reunion hotspot is the causative factor for the formation of the peninsular plateau, right? The answer here is wrong. It is a causative factor for the formation of the Deccan Plateau, not the peninsular plateau as a whole. Right? Please understand, we are talking about the Deccan Plateau. Peninsular Plateau, I told you right now, is a whole body. So, it will not be a right statement. Beta, this is a Deccan Plateau. ठीक है? Please understand. अभी बोला था Deccan Plateau and Peninsular Plateau are not the one and the same thing. Divergent. So, the moment I eliminate one, you can eliminate these 3. Divergent plate boundaries are the reasons for mid-oceanic ridge. Absolutely correct. But due to their destructive nature, those are constructive nature. So, 2 is also wrong. Answer is E, only 3. Clear? Clear? Everybody? Just please note these things. They are small things that you should understand, because if you are making mistakes there, right? Exactly. But I will tell you the difference when we will be doing Indian geography also. Please understand that. Cheating. I added one more option. See, I think in Bihar PCS you have 5 options, na, if I'm not wrong. In Bihar PCS you have 5 options. I don't know. Long ago I was seeing Bihar paper. What they do is they mention 4 points, and E they mention none of the above. None of the above. So now the person starts saying, what is the reason? Yeah, none of the above. Can it be there? Can it not be there? So it is very irritating. Bihar PCS options are even worse than the UPSC. Anyhow, okay. $10 break, and then we will be beginning with another chapter. So hopefully till now, please stay with me. We are going to do a lot of MCQs. We are going to do a lot of all the content that we are here. So we'll be helping you out from every dimension. Please, if you are with me, please make sure, right? Please make sure that you stay. Please enroll, all of you, in within this 10 minutes. Enroll yourself in the link in the description link that is given. Right? If you realize just below the video where PW only is English is written, you realize to download the PDF, join the free batch, there's a link given. physicswala.onelink.me, right? I will cover everything, don't worry. If certain things are left, I will be covering the next marathon along with it. Don't worry, I will cover everything. Clear? Everything will be covered. This today and 19th, world and Indian geography in totality will be completed. Don't worry. Chalo, 15 minutes, okay. Not 20, 15 minutes. 15 minutes break, and after that I will be meeting you. So meanwhile, please click on the link, and after that, once the lecture is complete, tomorrow you can attempt a test also. Clear? Okay. I will meet you. Hello. Okay. Hello everybody, I guess you're all doing well. All of you good? Okay, so I have returned. Hopefully you are also doing well. Okay, now let us move to the, let us move forward to the next part, Let's move to the next part. Are you all understanding what we're doing? Hopefully it is clear. Now please remember one thing very clearly. We are covering the complete part. If some part, let us say, remains today, I will be covering it with this next marathon also. So don't need to worry. By the time these two marathons get over, your Indian geography and world geography will be completely done along with all the these questions that are there. Clear? Along with all the questions. So the very important part that has to be known to you is that the questions which we are doing here are those which will form the basis of your way of attempting the questions. Please remember, as I've already told you, clear? Everything is going to be there. See, let us say this part covers geomorphology, climatology, oceanography, and biogeography. Everything is there. We will be completing. Don't need to worry. Don't need to worry about that. We will be completing. We have 2 marathons, 1 places in news and 2 marathons of maps also. So everything will be done. It is my promise to you. You don't need to worry about this. You just have to study and revise, study and revise, study and revise. My promise I have to keep. You have to keep your promise of reading it exhaustively, repeatedly, properly, and with it solve the questions. Solve the questions. Possibly I'll talk to the team also if it is possible in the future when, let us say, the prelim examinations are 1 month away. We can have possibly, let us say, 2,000, 3,000 questions practice. Do you want that also future? I'll talk to the team if it is possible. Like, let us say geography, I can have, let us say, 1,000 or 2,000 questions geography discussion from the complete geography of India and the world. See, I would love, because the way we are solving the questions right now, by that time I assume that you would have covered the geography, right? Based on the marathons, based on the book and content, whatever you are reading. So then possibly 1,000, 2,000 questions from geography if you do, you will reach a stage where you will not get your questions wrong. See, when I used to appear for the preliminary examination, I used to solve close to, again, 120 mocks full length, right? So those used to be 12,000 questions, close to 12,000, 13,000 questions. And then what will happen is, please understand, if you do it for all the questions, then everything can be done properly. So what I will do, when I will be doing, possibly if it is possible, see, right now I don't know, let us see if it is possible in the future, before the prelims, we can have like the discussions. I will be giving you time. We have a polling also, then we can discuss the answers also, if that is possible. But we need your support, only then that is possible. You should be very well be supportive. Sir, we need to do it. Sir, we need to do it. We need to practice. Because see, at last, when you see the question, I'll give you, let us say, half a minute to solve. You solve it, put the answer, and we can have the result over here with your names also, right? With your names also. So we can do that. But we need you to be with us. Okay, let's continue. So, clear? Yeah. First, but before that, again, you need to complete all these marathons also properly and revise them repeatedly. And then only it will be possible for us to be at a level where you can solve those questions. Every single point, every single point from NCERT, every single point from the standard book and all. So if they want to create a question from, where will UPSC create? out of these one are directly, indirectly. That is what, see, UPSC also has a scope. The examiners who are creating the questions also have a scope. They cannot get questions from alien nations, right? Okay, come on. So this is again the Telegram account where you can, I will be posting the link also, but please remember before that you have to enroll. And this is my Instagram account. If you want to connect, you can connect to this also. Now the chapter that comes is rocks, right? Very interesting topic, very brief topic also. I will be asking you questions in them. Let's see what is a rock. See, rock is a naturally occurring. Please understand, we are not talking about artificial rocks. We are talking about naturally existing rocks. So these are naturally occurring solid aggregate. What do you mean by aggregate? Something that is together. Because any rock, if you realize, it is made up of multiple minerals that are associated with it. So aggregation, collection, togetherness of minerals or mineral-like matter that form the Earth's crust. Clear? Simple definition of a rock. We do not have to go into R&D. Now, whenever I want to study the rocks, the major thing that comes is what are the types of rocks, characteristics of each rock, and that is what is repeatedly asked in the civil services paper also and along with other examinations. So if I want to study the rocks and the types, we should know what are the types. If you want to see, there are broadly three categorizations through which we study them. First is the igneous rocks. Second, you have the sedimentary rocks. Third, you have the metamorphic rocks. Now, these are the broad categorizations which we study. Clear? Now, see, I will be going here into a lot of details with this. I'm not restricting myself to NCERT, please remember. NCERT, everything will be covered. UDAAN, everything will be covered. But certain other things also I am adding here because so that you have a comprehensive knowledge of these things. Clear? Shall we begin one by one? What is igneous? What is sedimentary? What is metamorphic? And there are very characteristic features that are there. Remember, when I will be explaining you these, you will understand what the examiners are exactly looking at. Please remember, whenever the examiners are checking, they look at the keywords which are present in the answer. If those are present, you will get the marks. If they are not present, in spite of you writing all the stories, you will not get the marks. Let's see. Okay. Igneous rocks. When I mention the word igneous, it is derived from a Latin word, ignis. Now, do you realize when you buy Maruti Suzuki Ignis, that small car, that word is ignis? The car name is ignis. So, what does it mean? Fire. Yes. So, ignis means fire. Now, you understand the car with the name ignis is fire. So, igneous is derived from the word ignis, which means fire. Now, you know that well. Please remember, igneous rocks are formed due to the, now please understand, they are formed due to all the processes that happen because of the cooling of the magma and lava. Depends upon whether it is cooling on the surface of this earth or below the surface. There are three processes which are involved. These are the keywords that you should remember. What are the keywords? Igneous rocks are formed due to cooling, solidification, and crystal formation, that is crystallization of the hot and molten material known as magma and lava. Clear? Lava is what comes out. Magma is what is inside the surface of the earth. So their deposition can take place inside the earth also. Those are known as intrusive rocks. Yes. So igneous rocks can be formed on the surface also and below the surface also. So that is why these three keywords. Remember, bache, if you do not write the three words, examiner will assume that you are a class 10th candidate and possibly you do not know the intricacies. So the keyword cooling, solidification, and crystallization are the keywords. Whenever igneous rock comes, you need to know this. I will be testing you on the multiple choice question, so you should be very well aware of these points. Cooling, solidification, and crystallization of the hot and molten material as because of that means of the magma and the lava. Clear? Now see, all rocks are formed directly or indirectly from the igneous rocks, thus are called parent rocks. Now please see, whether we read the sedimentary rocks or metamorphic rocks, you will realize that all those rocks directly or indirectly, again, the materials have come from the magmatic sources only. So later they undergo erosion and all those processes, and later on other rocks are formed. So these are the parent rock out of which other rocks are formed. That is why igneous rocks are known as a parent rock, because they are a parent of the other rocks also. Clear? So parent rock. Now, having studied this, it is important to study the characteristics. Now see, these characteristics are not mentioned in your NCERTs, right? Now these are from the standard books, UDAAN magazines also, UDAAN book also. So I have compiled it here so that you, at one point source, you have all these things here. They are roughly hard rocks. Absolutely. They have solidified, they are crystal in nature, so they are hard rocks. They are granular or crystalline in nature. They do not have strata. What do you mean by strata? Layers. Like in the sedimentary rocks, what do you see? There is deposition of one layer, then another layer, then compression, and further layer. But you do not have such strata. Strata mean layer. You do not have such layers in igneous rocks. There are no stratas like the sedimentary rocks. Water is not able to easily percolate, less affected by chemical erosion. So let me ask you a question. Recently you saw there was Pran Pratishtha of Ram Mandir that happened, Ram Mandir ji in the Lord Ram's temple. Did you realize the statue of Lord Ram was made of black igneous rock? It could have been made because of sedimentary rock also, metamorphic rock also. So why is it made up of, why it is made up of igneous rock? Do you know the answer why? It is less affected by the chemical erosion. Because you know very well, when after post the Pran Pratishtha, you realize there will be application of ghee, there will be application of curd, there will be application of kumkum, there will be application of kesar, there will be application of water, there will be application of oil. If these things happen with, if these reactions happen with a sedimentary rock or a metamorphic rock, there will be possibility that it might get eroded easily. Yes? Yes? That is why igneous rocks are used, so that their subjection to the chemical erosion is minimal. Do you understand the logic behind it? Right? Less impacted by the chemical erosional activities. So this is a reason behind choosing, not only now, even previously also, historically also these things have happened. Clear? Where igneous rocks are less impacted. Now, igneous rocks do not contain fossil. Now, for you yourself know that these are formed because of the magmatic activities, right? Magma comes out. Obviously, if any animal is present there also, or fossil remain was present there also, it is going to be destroyed because of the high temperature that is there. So you cannot have any fossils in the igneous rocks. Clear? They are mostly associated with volcanic activities and thus are called volcanic rocks. Clear? Everybody clear? Right? Okay. So these are the important characteristics of the igneous rocks. Everybody clear? Now, once you have done the igneous rocks, quickly, we'll move on to the aspect of classification of igneous rocks. Now, SiO2, that is silica, right? Now, let us see silica over here. The greater the silica content that is present, more acidic the igneous rock is. So that means greater SiO2 is present, more acidic the igneous rock is going to be. Okay? Now see, type based on silica content, acidic. That means where this question has been asked, let me be very clear, CAPF examination that is also conducted by UPSC, this question has been asked directly, that acidic, intermediate, basic and maleic, and this percentage was also given. So please remember that if you think that, array leave it, why sir is given the percentage, leave it, there is no need of doing it, please better do not get into those things of avoiding stuff as shortcuts in order to be a civil servant, because you cannot see, there's a difference between smart work and shortcut. Smart work is fine, shortcut will not work here. So you need to read it properly. Now see, acidic greater than 66% silica. Example, granite and pegmatite. Intermediate, 52 to 66% silica, diorite and andesite. Basic or mafic, 44 to 52% silica, basalt and gabbro. Ultra mafic, less than 44%, peridot and dunite. So these are examples. If you do not have to go beyond these examples also, more than sufficient, but you should know this chart. This chart is important. And you should revise it and read it also repeatedly. You will remember it. Clear, everybody? So acidic, intermediate, basic or mafic. Basic and mafic is same thing, ultra mafic. That means the acidic content is less. Clear? Okay, let's move ahead. Based on the texture. Now, texture means whether it is coarse grained or fine grained. Based on that also, we can divide. Texture, see, pegmatitic, this is a type of texture. This is a characteristic and this is the example. Pegmatitic, it is extremely coarse grained. Example, pegmatite. Pheneritic, coarse grained, granite and gabbro. Porphyrite, if you see, you can avoid this also, but again, questions can be asked. So you should have an idea of it, right? Porphyritic, it is mixed. Example, porphyritic basalt and porphyritic granite. Granular, it is medium grained. Cinerite and granulite. Aphanitic, fine grained, basalt and andesite. Felsitic, very fine, felsite. Glassy, finest, obsidian. Obsidian is a very shiny, again, if you cut that igneous rock, you will see that finey content or that shine whenever you study obsidian as an igneous rock, right? Okay, just a brief idea you should have of this. At least this is but more important. This is something that questions are repeatedly asked. This is again, I've added, though not required, but still you should have a little idea. Okay, next is mode of origin. Intrusive rock and extrusive rocks. Now, how igneous rocks are originated, there can be two broad categories. We'll be doing this in later also, but let us understand intrusive rocks and extrusive rocks. Now, let us see the intrusive rocks first of all. Intrusive igneous rocks or landforms also we can say. When the rising magma during the volcanic activity do not reach the Earth's surface, rather they are cooled and solidified below the surface, the resultant igneous rocks are called intrusive igneous rock. Intrusive means inside, extrusive means outside. If supposingly, while the magma is rising, right, and it cools down below the surface of the Earth, so there will be rocks and bodies, let us say igneous bodies formed below the surface of the Earth. Those are known as intrusive igneous rocks or bodies. Now, those are of two kinds. First, plutonic and second, hyperbasal. Plutonic, formed due to cooling of magma very deep inside the Earth. When the rock formation takes place or bodies are formed very deep, both of them are below the surface of the Earth. Please remember, both are below the surface of the Earth, but one is very deep. Then it is known as plutonic. Hyperbasal, again it is below the surface, but not so deep. It is generally closer to the surface. Formed due to cooling and solidification just beneath the Earth's surface. Let us take an example. If this is supposingly the surface of the Earth, right? If supposingly certain bodies are formed here, let us assume, just a representation. These can be known as, let us say, hyperbasal. But let us say very deep inside over here, you realize some igneous bodies are there. Then it will be plutonic. Clear? Let us see this. Okay. I have made a diagram. This is again a handmade diagram for you. I have drawn all these things which again are repeatedly asked in civil services with respect to the intrusive igneous rocks or intrusive bodies. Now let us see what are they, because if you realize these are various characteristics that are present here and UPSC repeatedly asks, right? Okay. Let's see. Can you see the diagram? There are a lot of labelings that I have done here. See here. Okay, there's a volcano here, lava plateau here, dike here. But more importantly, these are the surface level. Let us talk about all these things which are below the surface. Now, this is the surface, below the surface. Do you realize this body? See here? See here? This. Do you see this? This particular part? Can you see this, everybody? This is very deep below the surface of the earth. This is the surface below the surface of the earth. Very deep. If the deposition, very large bodies are formed, that is deep inside, deep below the surface of the earth, then it is known as batholith. 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 Let us see one thing. Now, sometimes what happens, do you realize these white lines that I have drawn? Possibly these are sedimentary rocks, various layers are here. Sometimes what happens, magmatic material might rise and it might form this type of a shape, right? This shape might be formed. This is known as laccolith. I'll be explaining you, don't worry. On the other hand, there's a possibility a saucer might be formed like this. It is known as lopolith. Lopolith, and over here, laccolith. A pipe that is connecting the source to this, let us say, locolith or lapolith is known as a pipe. And a vertical igneous body that is created is known as a dike. On the other hand, horizontal horizontal body that is formed, which is again is known as a sill. Now let us see one by one. Let's see. Batholith. A large body of magmatic material that cools in the deeper depth these are granitic bodies. So that means what are batholiths? Batholiths are the bodies that are formed deep within the surface, deep below the surface, which are of very large scale, right? Clear? You can also mention this, okay? What happened? So among the igneous bodies, these are the largest bodies. These are the largest bodies. So you can see these are massive bodies, deep within the deeper below the surface. Laccolith. Do you see? These are laccolith. These are large dome-shaped intrusive rocks. So please understand dome. So this is a characteristic feature. So this is a dome is formed here, right? Between the sedimentary layer rocks over here, right? These are what? Sedimentary layers. There is intrusion of what? Igneous, intrusion of magma, and it has entered this, and you realize this is what? This is a dome-shaped structure has been formed. So within a level, base level, connected below with a pipe through which the material has come up, magmatic material has come up. So the characteristic feature is a dome-shaped igneous rock has been formed here. Clear? Next is sill or sheet. You would have seen this. This is sill, right? Sill and sheet, both are very interesting. These are both horizontal bodies, horizontal igneous bodies. See here, see here. Oh, again, I forgot lopolith, right? Lopolith is saucer-shaped concave igneous body. Now, please remember, do you realize this is a saucer-shaped body? Saucer-shaped body. Now, the problem that arises is every time whenever you study these igneous bodies, you get confused between lopolith and laccolith. Do you know how? Do you want the way how to remember it? See here. P for plate. Plate is this shaped. Normally, plate is this shaped. You put some things. Rather than writing saucer, it can be a plate also. P for lapolith, P for plate. So now you can understand it is a saucer shaped. The other one, laccolith, will be obviously the dome shaped. So P for plate. Clear? Remember through a plate. Plate is saucer again. So that way you will not forget it. That way you will not forget. Clear? Now sill and sheet. Sill or sheet are both the one and the same thing, just thickness is varied. These are both horizontal bodies. If you see, these are horizontal bodies. See here. Now, what is the difference between them? Let's see. There are near horizontal bodies of intrusive igneous rocks. Thinner ones are called sheets. Thicker ones are called sills. So, both of them are one and the same. The only difference is thickness. If they are very thin, then it is sheet. If it is relatively thicker, then it is known as sill. So it is just the difference with respect to the thickness. This can be asked and has been asked in the examination. Sill and sheet. That they will ask you that, for example, a statement can come that sills are thicker than sheets. So you should be knowing it. Clear? Okay. Next, dikes. Now please understand, dikes are what? These are almost vertical bodies, right? See here. Lava makes its way through the cracks and wall-like formation. Wall-like formation, again vertical. That is why these are known as dikes. They are mostly perpendicular to the beds. That means the base level, they're perpendicular. That means there are vertical bodies. One more thing, again, are facholiths. Now, these facholiths are very important. When we will be studying now the fold mountains. Now, see here, everybody. Supposingly, everybody see here. This is a tissue paper. Can I take it as a lithospheric plate? Everybody, so let's put it like this. Can I take this as a lithospheric plate? Now, if I exert force from both sides, right? Can I say it is a compressional force that is acting? If I exert a compressional force, it is possible that it will fold like this. This is what happens with the fold mountains. When the Indian plate collided with the Eurasian plate, you would have realized this, that the folds that are formed, that is Himalayas, are young fold mountains formed in the Tertiary period, right? Now, these fold mountains that have created are an outcome of the compressional forces that was acting. Now, similarly, that was a very large scale event that happened. Similarly, these happen at a very small level also, that is folded structures that are formed. When these folds are formed, the top part, and this is the lower part which is bent down. The one which is the above this part, the one which has upfolded, the upper part, is known as anticline. This part is known as anticline. The one which has folded down is known as syncline. See here. The one which has folded up, this part is known as anticline. This part which has folded down is known as syncline. Clear? Anticline and syncline. Now what can happen is, sometimes igneous depositions happen at the syncline and anticline. Then it is known as facholiths. Then it is known as facholiths. See here. They are formed due to the injection of magma along the anticlines and synclines. It is known as facholith. Clear, everybody? So what we have done is, we have done all the intrusive landforms. Is it clear to everybody till here? Clear to everybody? What are the various igneous bodies, intrusive igneous bodies? Clear? Quickly tell me. Clear? Done? See here now. Now comes the extrusive igneous landforms. What do you mean by extrusive? These rocks are formed due to cooling and solidification of hot and magma at the surface of the earth. Now these can be of two types: explosive type and quiet type. So we will be studying volcanism and volcanic activities afterwards, not right now. So we will be covering over there these part, right? But just to have a brief idea, explosive types can be bombs. These are big fragments of rocks. It can be lapilli, pea-sized fragments, or breccia, that is mixture of large and small particles. Otherwise, quiet type, like the lava plateaus, that come. So these are basically what? The extrusive landforms. Again, the volcanoes and will also come here. We will be covering that part later on, not right now. Okay. Igneous rocks done. Clear? So we have covered igneous rocks in lot of detail. See, that is the maximum that you can come across igneous rocks. Covered every dimension of igneous rock. I'll be testing you on the questions also once I've completed with the rocks. Clear? Any query? Hopefully it is clear, right? So what we have done in igneous rock, let's see. Igneous rocks, the etiological meaning we have done with a little bit of what are the keywords. We have done cooling, solidification, crystallization and all. Then characteristics of igneous rocks, then classification based on silica, based on texture, based on mode of origin, intrusive igneous rocks, all the bodies, igneous rock bodies, extrusive igneous rocks and landforms. Clear? Now comes the sedimentary rocks. Sediment by default means sedimentary rocks are formed because of sediments. Sedimentary rocks are formed because of the sediments. Now, the moment you realize it is derived from the word, Latin word sedimentum. Sedimentum means settling down. See, now these sediments are basically possibly coming from different part. Let us say some erosion is taking place along the mountain range. From there the sediments are coming down to some other region and later on deposited. Later on other layers are deposited. So these what happen is layers of these material sediments are deposited and they get compressed also. Because of those compression and all, you realize sedimentary rocks are formed. Clear? Over here, please remember, whenever we talk about sedimentary rocks, the sediments can be of various types, various categories, whatever, because it is at last it is the deposition taking place and the erosion might be taking place in whichever region we do not know. Right? See here, sedimentary rocks are those where rocks are an outcome of the deposition of different layers of strata by the different types of sediments. Why am I saying different types of sediments? See, like igneous was, you know that very well that okay, the volcanic eruption is taking place and cooling, solidification, crystallization is taking place. So we know that is very simple process. But over here, when the deposition is taking place of the sediments, they can be brought by the rivers from various rocks, depending upon what type of rock that is. Even the sediments of the sedimentary rock can come. Even those erosion of the igneous rock can happen. Even those of the metamorphic rocks can happen, and their deposits are taken down and they might settle down in the later phases. So this is basically settling down. Clear? Let's understand the characteristics. Sedimentary rocks are formed of the sediments derived from other rocks, plants and even animal remains also. They have fossils. How come do they have fossils? Please remember, supposing there is a layer here. An animal died, the plant or some plant died and just it's lying down on the floor, lying down on the ground. Then you realize certain sediments are deposited. Then other layers are deposited. Then other civilization comes. Those people live and die. Then other layers are deposited. So you realize there is layers that are present here. And in every layer you realize various types of sediments when we present. That is what you realize when you study about the regions where petroleum is found or natural gases are found. Those are because of those petroleum remains and all those are formed in the sedimentary basins. You would have heard that very often. Why? Because possibly thousands and thousands of years ago, certain creatures, plants, animals would have lived there, which have basically resulted in them being converted into those resources. Yes or no? One or the other, we can say that. That is why, please remember, that is why you hear the word sedimentary basins, whenever you talk about natural gases and oil and all, right? That is why they have fossils. Sedimentary rocks they cover the largest area of the globe, that is 75%. If you see all the rocks, 75% area is covered by the sedimentary rocks. Layers of sedimentary rocks are seldom found in the origin and in the horizontal manner. Please understand. Please see, when I say sediment, the layer of sediments are very rarely found in the origin site. What does it mean? What do you mean by origin site? Please see. This is a mountainous region where erosion is taking place. Those sediments will be brought down and deposited hundreds of kilometers far away. That is why it says that the sediments which are found are not at the original location from where they were found. That is why the erosion happens. The sediments are carried to long distances and then they are deposited in some other place. That is why they are not found in the original location, right? most of the sedimentary rocks are permeable and porous. Permeable and porous, that means water can seep through that, right? Okay. The connecting plane between two beds is known as the bedding plane, and uniformity between two beds is known as conformity. Lack is known as unconformity. I will explain you that. See here. Understand this very well. Supposing this is a layer of sedimentary deposits that was deposited. On top of it is another layer of sediments that is deposited. On top of it, another layer of sediments is deposited. Clear? On top of it, another layer of sediment is deposited. Obviously, now you will realize pressure will be exerted from the top layer. Again, compression will be happening. That is a different scenario. We'll study that. But do you realize, can I say this plane, if I see this, let's draw a line here, this line. The connecting plane between two consecutive layers of sedimentary rocks is known as a bedding plane. Can I call this as a bedding plane? Between two consecutive sedimentary rocks. Can I call this as a bedding plane between these two? Can I call this as a bedding plane between these two layers? Can I call them as bedding plane? Bedding plane basically means that connecting plane between two consecutive layers. So that means between two layers, this plane can be considered as the one which is differentiating between the two layers of sediments. Clear? Clear? This is known as a bedding plane, which we talk or use with respect to the sedimentary rocks. Clear? Now understand one more thing. When we see, yes, clear everybody? Clear everybody? Bedding plane. When there are two layers that are present, these two layers, if you see, are present here, they might be very different from each other. Supposingly, this sedimentary deposit, this deposition of the sediments that have happened, they're an outcome of the erosion of, let us say, igneous rocks. Let us say, whatever erosion was happening due to river, wind, whatever. These erosion has basically comprised of, let us say, igneous rocks, and they were deposited because sediments, let us say, igneous rocks were eroded, and the material over here came and they got deposited. Supposingly this layer has sediments which are more to do with the previous sediment rocks, right? This has got to do with another type of igneous rock. Do you realize there is difference in the two types of the layers that are present here? That means if there is uniformity in the two beds along the bedding plane, there is conformity. But if there is no, if there is, let us say, no uniformity, it is known as unconformity. So if you realize these two layers over here, they are different in nature, possibly the texture, possibly the composition, possibly the nature. So can I say there is unconformity or unconformity between them? On the other hand, let us assume that when this layer was deposited, after that there is another layer of a similar material or nature deposited here. Now, I cannot say these are absolutely different. So I would say that there is conformity between both of them, because there is uniformity or similar to each other. When there is similarity between the bedding planes, we can call it conformity. When there is differences, then it is known as unconformity. Please understand, over here, this topic is very wide in itself. If you study geography optional, you can go into a lot of details with respect to conformity and unconformity. We do not have to go for general studies. So we limit ourselves to this point only. Okay. Now see the classification of sedimentary rocks. Please see here. Classification of sedimentary rocks. Classification of sedimentary rocks on the basis of the nature of sediments. Now we do not have to go into R&D on these topics. Brief idea should be known to us. See here. Clear till here, everybody? Everybody clear? Okay, let's begin. Till now, we have done with respect to sedimentary rocks, the origination of the word, the characteristic of sedimentary rocks, the concept of conformity and unconformity. Now comes a classification. Now, classification can be done through various parameters and various types on the basis of the nature of the sediments. On the basis of the nature, I can say mechanically formed or clastic form. That means some form of mechanical forces are acting. That are sandstones, conglomerates, clay rock, shale and loess. Mechanically formed, that means due to the disintegration of the pre-existing rock. If there is a rock already existing, disintegration of that rocks take place due to various erosional forces and all, then these types can be formed, right? Chemically formed, now these are formed due to the precipitation of minerals from a solution, gypsum or salt rock. Organically formed like limestone, dolomite, coal and peat. These are formed due to the remains of the plants and animals. So these are again three categories which can be studied under this. Clear? Okay. Next are on the basis of transporting agent. Now what are the transporting agent? Let us see. One can be argillaceous or aqueous, one and the same thing. This can be first marine rocks, that means formed closer to the regions of oceans and seas. Lacustrine rocks which are formed close to the lakes. Riverine rocks which are formed close to the again what? Rivers. Aeolian sedimentary rocks. Aeolian sedimentary rocks again associated with Lewis. Glacial sedimentary rock, work of wind is here important. Glacial sedimentary rocks, tills and moraines, which we'll be seeing when we'll study the glacier topic right now after some time. So these are based on the transporting agent. What is transporting a particular sediment? Based on that we are classifying here. Clear? Okay. Let's study here. Next is the formation of sedimentary rocks. Please remember, everybody tell me, what were the three keywords when you wanted to study igneous rock formation? What are the three keywords? Quickly tell me. Three keywords which should be mentioned when you are studying the igneous rock formation. What are the three keywords I had mentioned? Quickly, everybody write in the comment section, because you should have the knowledge, only then I will tell you this. What are the three keywords if you want to study igneous rocks? Those three keywords formation with respect to its formation need to be mentioned very categorically. What are those keywords? First, cooling, right? Solidification. Third, crystallization. These three keywords are very important, very important. Similarly, if you want to study sedimentary rocks, there are four keywords that you should be remembering. What are those keywords? Weathering, sedimentation, diagenesis and lithification. What are these four keywords? What are these four keywords? Everybody. What are these four keywords? Tell me. First, weathering. Second, sedimentation. Third, diagenesis. And fourth, lithification. These are the four words that need to be mentioned or are associated with the formation of the sedimentary rocks. Let us study one by one. We'll be doing the topic of weathering in detail, obviously in the following chapter, but you should have a brief idea. Weathering basically refers to the breakdown of rocks or near the Earth's surface into smaller particles. Now, this breakdown can happen due to physical forces, chemical forces or biological forces. For example, if water, let us say, gets into the cracks, and during the night time if you realize there is fallen temperature, it will convert into ice and it will exert pressure on the rock and possibly break the rock. Those are physical. Chemical, let us say some chemical reaction is taking place, solution, hydrolysis and all, that can lead to again chemical erosion. Biological, let us say some burrowing animal is basically resulting in, let us say, because of the burrowing activities or animals, it is leading to, let us say, breakdown happening of the rocks. So that is again a part of the biological activity processes. So it can be physical, chemical and biological. I will cover this in detail when I will be covering weathering. It produces sediments. So overall what happens? Weathering is the breakdown of the rocks through physical, chemical and biological processes. This produces sediments. Clear everybody? Weathering, everybody clear? Once you have studied weathering briefly, we will be doing this topic in detail, don't worry. Right now we are studying sedimentary rock, so we will not go into detail. This stage creates sediments or produces sediments. Next is sedimentation, the process where weathered material are transported by the agents and deposited. This, please see, this involves transportation and deposition of the sediments. What will this lead to? This will lead to the formation of layers. How? See here. Supposingly this layer is deposited. Because supposingly the sediments are coming from some other region by, let us say, wind, glacier, whatever be the case. These are deposited here. Then you realize there is another layer that will be deposited. Then you realize that another layer might be deposited, whatever be the case. So there are three things in this sedimentation process. First, transportation, from whichever reason the sediments are coming. Deposition, and because of them, one layer after layer will be deposited. That means layers will form. That means strata. Strata mean layer. Various layer existing is known as stratification. So transportation, deposition, and formation of layers, which we can call as strata. These three things are happening in the sedimentation phase. Clear to everybody? Clear to everybody? What is it? Transportation, sediment formation took place in the weathering. Then you have transportation and deposition taking place in the sedimentation. And then those layer formation, third thing. Clear? Stratas are layer. So, clear everybody? Now let's move to diagenesis. Okay. See here. Till the previous stage, you have understood that transported, deposition and layer formation has taken place. Now there will be certain other processes that will be acting on them, those layers that have formed. In this stage, sediments undergo physical and chemical changes. The sediments that were formed, they are going to undergo various changes. Once they are deposited, there are a lot of forces going to act on them also, right? Yes, exactly. Strata means layers. The whole process of formation is known as stratification, where every layer is formed. So I'll be telling you that also, don't worry right now. Sediments undergo physical and chemical processes. What are those processes? Understand. First, compaction. What is compaction? Weight of the overlying layers squeeze the sediments. Now please understand. Let's see here. If this layer is present, other layers are deposited on top of it. Will those layers exert pressure on them? See, let us assume this. It was like this. Other sediments are being deposited over here. So those layers will exert a pressure on them and it will squeeze. So this is known as compaction because of the weight of the layers which have been deposited on top of it. So that is known as, that is makhana layer. Yes. Now see here. Because this layer is here, there will be layers on top of it. These layers will be exerting a lot of weight on this layer. So there will be squeezing of this layer or compacting. So this is compaction. Clear? Next is, second thing that happens in this is cementation begins. Please listen to this. Begins, does not end. Cementation begins. See here. Cementation begins. What is cementation? See here. Minerals like calcite, silica, iron oxide precipitate and bind the grains. Now these types of minerals basically are binding, right? Binding all the minerals that are present there, right? Bhook lagne lagi. Koi baat nahi, doesn't matter. Minerals like calcite, silica, iron oxide precipitate and bind the grains. Various grains that are present, these minerals act as binding agents, right? These act as binding agents. That is known as cementation. The role what cement does now, similarly these minerals do within those layers. They basically bind them. Clear? Okay, I'll give you an answer. Like just an analogy. Have you seen Taj Mahal? Na? In Taj Mahal, you realize there is cement used? No. Instead of cement, you realize the marbles which were stuck on the surface of that structure that was formed, it had gud, it had dal, it had certain herbs. A mixture of that was created, and those were like cementing agents for the marble, right? Similarly, these calcite, silica and iron oxide are like the cementing agents for the structure as a whole. Clear? Next are recrystallization. Recrystallization. Minerals reorganize into stable forms. This is known as recrystallization. Clear? They basically reorganize themselves into stabler forms. Yes, lime is also used. Diagenesis occurs at shallow depth and relatively low temperature, less than 200 degrees Celsius. Clear? Clear? Everybody clear? So what are the processes involved in diagenesis? Compaction, cementation begins, recrystallization. And these are the three processes which are associated with diagenesis. Clear, everybody? What is associated with lithification now? See here. Lithification is the final stage where the loose sediments finally become sedimentary rocks. With the lithification stage, you say it has now become sedimentary rock. What is that? Lithification is compaction, further compaction that is taking place, plus complete sedimentation. In the previous stage, sedimentation had begun. In the previous state, cementation had begun. Over here, cementation is complete, and further whatever layers were deposited on top of it, those have further compacted it. So lithification in simple words is final compaction plus cementation being complete. Once the lithification process is done, you have the sedimentary rock done, available now, available for display. Clear? See, I have this part I have done in a lot of detail. Why? Because once you have done this, you are very well prepared for any type of question that comes from your rocks chapter. Clear? So it is lithification is compaction plus cementation. Clear? Yes or no? So is the sedimentary rocks part clear to everybody? Sedimentary rock parts clear to everybody? Now, next type of rocks are metamorphic rocks. Metamorphic rocks. Clear? Metamorphic rocks. Now you can label them, rename them, whatever. This is how it happens. So see, I told you, see, whatever is mentioned in the NCERT is here. But whatever is not mentioned in the NCERT which are important is also here. What is mentioned in UDAAN is also here. What is present in the standard book is also here on the board. So what you are being covering over here is all these things. So you have all the material which is like a weapon for you to appear for the civil services examination. Clear? So do it very properly, right? Watching the lecture is important because you will be understanding and correlating with me what I'm teaching you. But after that, the task will not end. The task again then the major part is again revising this. Clear? Without revision, nothing happens. The more you revise, greater are the chances for you to qualify this examination. Lesser you revise, you are far away from the goal. Clear? Okay. Metamorphic is derived from the word metamorphism. Metamorphism means change in form. What do you mean by metamorphism? Metamorphism means change in the form, right? Change in the form. Clear? Now, what do you mean by change in the form, right? Now see, let us understand what metamorphic rocks are. Again, over here also, I will be giving you certain very important concept that you might not find other places. NCERT basically mentions certain words related to metamorphic rocks, but it does not explain it in detail, right? It is quite sufficient of mains to obviously it is, right? It is obviously it is. Please remember this. That is why if you're doing this, you are prepared for both the things, prelims and mains, plus yes, you need to add certain current affairs which come in geography. Those are again added through your current affair magazines and all. Clear? So this is again very, very important from every aspect. See, in mains also what they do, they will ask these questions only, explain the process through which sedimentary rocks are formed. Please understand, everybody, Listen to me for 2 minutes. In the examination, let us assume a 10 marker question comes. Explain how sedimentary rocks are formed. Till now also you would be reading NCERT sedimentary rocks. You will say, okay, there is some erosion, deposition, sedimentary rocks formed. Yes. But do you realize this? The examiner expected you to write these processes also. That is why, because 10 markers are very to the point answers. You write these processes, example, that is done. That is what is expected from you in the answers also. But if you write just 2 processes, okay, there is some erosion and then deposition then happens, then you will not be getting the marks from Ache. Over here, you prepared for the prelims also and prepared for the mains also. Both of things. And that is why you cannot segregate prelims and mains preparation. It is integrated because it is the conceptual understanding that is important. Clear? You would have realized this by now. That is why when you are doing this, your content is solidified and prepared for your mains. Yes, Bachche Ujjwal, yes. You will see for yourself. Once you have revised all this, you attempt questions, you will realize, you will understand what is the importance of the content. Clear? Okay. Metamorphic rocks are rocks which are formed under the action of or due to pressure, volume, or let us say that temperature changes that take place. More precisely, temperature and pressure changes, due to which consolidated rocks undergo recrystallization and reorganization of material within the original rock. So what happens, please understand. Let us see, let us take in this way. Okay. Okay. This is supposingly igneous rock. This is supposingly metamorphic rock. And this is sedimentary rock. All the 3 types of rocks are in front of me. Clear? What is going to happen is, if these 3 rocks, even I am talking about the metamorphic rock also, if I apply pressure, depending upon the rock nature also, pressure, or let us say temperature changes, all these 3 rocks will transform themselves in some or the other form. Igneous rock under certain temperature or pressure conditions can transform itself. Sedimentary rocks can also transform itself, and even the metamorphic rocks that are present can also transform themselves into some other rocks. That is why, please remember, whenever I mention change in form, by change in form we want to point out that there will be changes happening from one form to another form. That initial form can be sedimentary, can be metamorphic, can be igneous. From that it changes to some other form. What is the linking line? See here. See here. What I am trying to say is, let us say this is the initial form. Initial form, that means of rock. That means any rock here. Any rock means it can be igneous also, it can be sedimentary also, it can be metamorphic also. If you are applying, let us say, vast temperature changes, or let us say pressure changes, you will realize that they will form into some other metamorphic rock. This sedimentary rock will also transform into some metamorphic rock. This metamorphic rock will also might change into some other metamorphic rock. Do you understand this? That is why I said change in form. Change in form is taking place. Clear? Now let's move ahead. Characteristics. Now see, metamorphic rocks start from the other rocks, which can be igneous, sedimentary, or even metamorphic rock. This is what I've explained in the previous slide, that metamorphic is going to change the form of any rock that is existing, whether it is igneous, sedimentary, metamorphic, whatever be the case. Minerals inside the metamorphic rock change during the metamorphic processes. Yes, minerals change inside. Again, there will be recrystallization also. Metamorphic rocks are generally more resistant to weathering than the parent rock. These are even more resistant. Now see, in the process of metamorphism, grains and minerals are in some rocks get arranged in layers or lines, such an arrangement is known as foliation or lineation. Again, understand this. Very important here. See this last point very clearly again. This is very important here. Why this is important is because a question can be asked on this also in your prelims. In the process of metamorphism, that means metamorphic processes are taking place through temperature, pressure, whatever be the case. Grains of the grains, that means sediments or minerals, whatever we are looking at. So grains and minerals in some rocks are arranged in layers. Let us assume there are certain previously existing rock that is present. Due to some pressure, temperature changes, there can be arrangement of the minerals in layers. That arrangement is known as foliation or lineation. That arrangement is known as foliation lineation. It is not known as stratification. Stratification is a term which is used for sedimentary rocks, where layers are deposited in the form of sediments. Over here, the changes are taking place because of temperature or pressure, or both for that matter. And that is why the rearrangement is taking place. Over here, it will be known as foliation or lineation. So if I use the word foliation and lineation is associated with which among the following rocks? That is metamorphic rocks. Whenever I say sedimentation or stratification is associated with which rocks? It is sedimentary rocks. That is why these keywords, why I am picking up these keywords, please remember, you can be asked these words. Foliation, lineation is associated with which rock? Is associated with sedimentary rocks. Now you will say, array, lineation, foliation is like layer, sedimentary rock, mark it. That is why UPSC is testing you on such concepts. Foliation and lineation you are going to use with metamorphic rock. Clear, everybody? Sedimentation, sedimentary processes, and stratification you will use with sedimentary rocks. Clear in your mind? Okay. What happens sometimes, another thing, along with the foliation and lineation, one more point should be kept in mind. That is banding. Banding. Again, a very unique feature, a very important feature of metamorphic rock. Minerals or materials or different groups are arranged in alternative thick or thin layers. Let us say, when this foliation and lineation process is happening, it is possible that the layers can be, some can be, let us say, this thick, others can be thicker, other can be supposedly very thin. This arrangement of thick and thin layer, because of the metamorphic processes, are known as banding. Clear to everybody? That means foliation, lineation, banding are words which you will always associate with metamorphic rocks, not with sedimentary rocks. Please keep it in your mind. Clear? Banding. Done? Okay. Now comes, what are the factors of metamorphism? Factors means, what are the reasons because of which metamorphism is going to happen? The reasons because of which metamorphism is going to happen. First is heat. Heat, or let us say, obviously the temperature, in a way you can call it a temperature only. Increased heat or increase in temperature causes the minerals in the rock to recrystallize and rearrange because of, see, when you talk about crystallization, because there is certain arrangement through which a mineral is formed, if the recrystallization takes place, some other structure arrangement changes can take place, and that will lead to, again, what happened? What is the difference between banding and metamorphic rock and layers and see? Understand. If a, please bache, visibly, again, when a geologist is studying, they are very easily able to identify them through their nature and all. A person who has not basically studied rocks and all, it might be difficult for them to identify. But for the person who has, let us say, undergone through geological studies or geologists, they can very easily identify this is a metamorphic rock or this is a sedimentary rock, right? There are similarities, yes, but that again requires experience and study, on the basis of which you can identify. Clear? That is the important thing. Okay. Now over here, remember, increased heat causes the minerals to rearrange and recrystallize and reorganize. That can also transform a rock into a metamorphic rock. Pressure, it causes mineral to compact and align in specific orientation. A lot of pressure is being exerted. So that can cause the minerals to realign themselves and then again transform into sedimentary rocks, transform into metamorphic rocks. I'll show you the processes also. Don't worry. Chemical actively fluid. Now see, this is again important. Its presence can facilitate the exchange of elements between minerals and the rock. It can lead to growth of new minerals. Now let us assume it is not directly responsible, it is indirectly responsible. Let us say there is certain chemically active fluid present. Let us say certain elements dissolve in water and they just seep down, and previously let us say a region where temperature was high or pressure was being exerted and that minerals basically enter there. So new let us say new addition to a new addition of that particular mineral can happen. So chemically active fluid can basically create new possibilities of new metamorphic rocks being formed. Clear? Time, greater the time, greater is the possibility of metamorphic rocks being formed, provided there is temperature or pressure forces are being exerted. So metamorphism is a gradual process. It takes time over millions of years. So more is the time, greater is the possibility of metamorphic rocks being formed. Clear? Okay. Next comes type of metamorphism. You have seen the factors. Now let us see how this is basically happening. See here. Types of metamorphism include contact metamorphism and regional metamorphism. Now see, in the NCERT, these 2 points are mentioned. Regional and contact. These 2 points are mentioned. Now they are done in very brief, so you're not able to understand what it basically means. So that is why in the UDAAN magazine also it is mentioned. Now I'm expanding it even further to explain you the concept. Contact metamorphism is localized. That means limited to a certain region, very small region. Regional metamorphism is one which happens in a very large area. Very large area. Regional metamorphism has 2 parts. I'll be making you understand each and every point. Don't worry. Just this is a flow chart. Then we'll go into detail. Regional metamorphism can be dynamic regional metamorphism and static regional metamorphism. Clear? What are the processes? See, what are the types of metamorphism? Contact metamorphism, regional. Regional has dynamic regional metamorphism and static regional metamorphism. Clear to everybody? Clear? Shall we study each one of them? Okay, let's begin. Let's see here. Contact metamorphism. Please remember, contact metamorphism is also known as thermal metamorphism. What do you mean by thermal metamorphism? That means the role of temperature is very, very important here. What? Temperature, heat. Always remember, when I'm talking about contact metamorphism, the alternative name is also known as thermal metamorphism. That means the temperature or the heat is the one which is playing a role in converting any form of rock into metamorphic rock. Let us take an example. Supposingly earlier, let us take this. Supposingly, see this. Supposingly before this thing happened, this was a structure. Let us assume this. Next is this red color. Okay. Then is a green color. Okay. Then was this pink color. Okay. Okay. Supposingly, see this here, everybody. Everybody see here. Supposingly, this was a sedimentary rock or layer some present in some region, right? Now what happens is that some volcanic activities, or let us say magmatic flow, happens in this region. What happens? Magma basically rises from here. Magma basically rises in this region. Now when magma is rising here, you will realize it is very high in temperature. This part which is close to the magma, see here, is very close to the magma, will transform itself into some other form. Like limestone is converted into marble because of this. So these was, let us say, limestone. This part has converted to marble. So limestone to marble conversion is an example of thermal metamorphism or contact metamorphism. So wherever you find marble, one of the major reasons is that it has undergone transformation from limestone to marble because of the high temperature or heat that was provided to it. Everybody clear? Quickly tell me. Quickly tell me, is it clear? Clear? Quickly, quickly, quickly. Clear? So contact metamorphism basically means that it is an outcome of the thermal metamorphism or provision of heat, very high amount of heat, which transforms one form into another. Now let us see this. This is actually a diagram also. Please, this question can be very well asked. Remember in your GS paper 1, even when you are writing your mains examination, prelims, so it is important, very important. There is no doubt about it. Even in your mains examination, every time in the geography part, they will ask you, because see, in the paper 1, 250 marks, you will realize every year it changes. Sometimes they can ask you geography questions about of 100 marks. They can ask you 70 marks also. Out of that, remember, 2-3 questions are very direct and very easy. Easy from the perspective that these are directly book oriented. And these are the questions which are asked. Mention the various types of metamorphic processes are taking place. What are the characteristics of metamorphic rocks? And over there, if you get that wrong, if you're not able to write, then there are chances of you qualifying the examination diminishes. Why? See, those are full tosses. Either you hit it for a 6 or you better get bold then. It is better you hit for a 6 when you have done this. So that is whatever we are doing here, we'll make sure that you hit every ball for a 6. Rather than getting bold, it is a worst feeling when you get bold on a full toss. I hope you don't want to do that. So better hit for a 6. Be a Hardik Pandya. Clear? Okay. Regional metamorphism. Regional metamorphism. Again, you know there are two types. First, let us understand what is regional metamorphism. Whenever we talk about regional metamorphism, you should understand that the role of pressure is most important in regional metamorphism because area is relatively larger. Now see here, when the rocks are altered in their form in an extensive means a huge area, the process is called regional metamorphism. That means, see, over here, the amount of pressure that is exerted, right? Right? Clear? क्या हो गया? Okay. So, in regional metamorphism, the pressure is playing a important role. Let us understand. Let's see this. Just imagine the Indian plate colliding with the Eurasian plate. Can you imagine the amount of pressure that is exerted? This plate is moving further, and you know that the height of Mount Everest is still rising. You know that? Why is it rising? Okay, let's take an example. If I tell you, okay, there's a car outside your house and I tell you to push the car so that it can move. Tell you leave the car. Let's take a truck. I tell you to push the truck so that it move. You will say, sir, what are you saying? I cannot even pick up the tire of the truck. How can I move the truck? The question will come. Now imagine the amount of force that will be required to make the Mount Everest rise. Can you even imagine? So do you realize when I talk about regional metamorphism, that is the role of pressure. And pressure in a large area, not one part. When Mount Everest is rising, it is not only Mount Everest, it is the large part of the Himalayan belt that is moving. Because the Indian plate is further moving towards the Eurasian plate. That is why when I talk about regional metamorphism is a characteristic feature of the mountainous areas. What? Mountainous areas. Why mountainous areas? Because over there the plates are moving towards each other in those regions, tremendous amount of pressure is exerted. And that is why large area is there. Clear everybody? Let's take an example also. Let's see. Now it can be of various types also, various forms. Let us see how. First thing about regional metamorphism is that it is the role of pressure is most important, right? First. Now let us see the two types. Dynamic regional metamorphism Now see here. See here. Supposingly, sedimentary rocks were present and very massive pressure is exerted. There can be some synclines and anti-synclines. See here. This rock, this sedimentary rock was in this form. Massive pressure is exerted and it has bended because of that pressure. There is bending taking place because of the massive pressure. It can be upward and downward both ways. You can create a syncline also, anti-syncline, no problem. But what is being shown here, that massive pressure is exerted. Clear? See, just imagine if I try to crush it, lot of pressure will be exerted. Yes. Similarly, what I'm trying to tell you is, over here, massive pressure is exerted and this pressure over here can transform this rock into some other form. Transform into some other form. And this is again metamorphism because of the pressure that is exerted. Clear? Let's see here. When the rocks are metamorphized due to the compressional forces, compression taking place, the resultant high pressure caused the convergent horizontal movements and that results in the metamorphic rocks being formed. Clear to everybody? Yes or no? Is it clear? Quickly tell me. Clear? What is dynamic regional metamorphism done? Now let us understand the examples here. Please understand, various rocks are formed because of dynamic regional metamorphism. Let's see the example. Granite might be metamorphized because of dynamic regional metamorphism into myelogenite. Myelogenite is created or formed from granite because of dynamic regional metamorphism. Shale, due to the dynamic regional metamorphism, can be converted into pylonite. Basalt, due to dynamic regional metamorphism, can be converted into malonite basalt, malonitic basalt. So these are three examples for what? Dynamic regional metamorphism. Dynamic regional metamorphism. Clear? Everybody understood before I move to static regional metamorphism? Is the dynamic regional metamorphism clear? Can I move to static regional metamorphism? Clear? This is again a very important example that you should be aware of and very clearly, quickly, because I'll be doing MCQs after this on this topic. Clear? How many MCQs are there? Multiple MCQs. Okay. So we have done with what? Dynamic regional metamorphism. Now comes static regional metamorphism. What is static regional metamorphism? Let's see. See over here, let us assume initially this layer was not there. Let me just color it. Just give me a minute. Supposingly, this is again what? The various layers are here. See here. And let's understand this. Over here, please understand. Quickly see here. One layer is deposited, over there another layer is deposited, over there another layer is deposited, other layer. Do you realize this is something very important? I told you that because of the compression, sedimentary rocks can be formed. That is clear. We have studied this in the sedimentation part. But when the pressure exerted by the overlying rocks are so high that the lowermost layer might transform its nature and change into metamorphic rock. That can also happen. Please understand, this is very similar to the process of sedimentation which I had explained you, but this is different from the extent that the pressure exerted over here by the overlying rock is very high. So what happens here is, if multiple layers are added and pressure exerted by them is very high, what can happen? the one which is at the lowermost layer, it can transform itself and change this part into metamorphic rock. This lowest layer or lowest part of that layer can change into metamorphic rock because the pressure which was exerted from the top was very high. This is known as static regional metamorphism, where the rocks are metamorphized at greater depth. That means which are at greater depth because of the intense pressure and weight of the overlying rocks. Because of the overlying rocks. Clear? This is known as static regional metamorphism. Clear? Clear, everybody? Yes, heat can have a role, but more importantly, it is pressure. Please remember, more important role is pressure. Clear? So we have done with what? Contact metamorphism. We have done with regional metamorphism concept. Within the regional metamorphism, we have done dynamic regional metamorphism, and along with it, we have done with static regional. Let us take the examples of static. Again, over here also, if you realize, one of the examples is very similar to shale converting into palonite can also happen because of static regional metamorphism also. So you can mention that as an example also. Okay. Let's begin rock cycle. This is the easiest topic, right? Okay. Please see here. When we talk about rock cycle, you've already seen water cycle, hydrogen cycle, all these, water cycle, phosphorus cycle, all these things. Certain things we'll be doing also in the environment topic also. See, rock cycle means that one form of rock is converting into another form. Clear? This is rock cycle. That means igneous rock converting into metamorphic, metamorphic converting into sedimentary, sedimentary converting into igneous, igneous. How it is converting, let's understand. See here. Supposingly, the first thing is magma, right? Magma. Now, magma, let's say, come out on the surface in the form of lava. It's cooled down. I'm not writing here. Obviously, we know cooling, solidification, and crystallization. Cooling plus solidification. Just a minute. Cooling plus solidification plus crystallization, we know that. That process happening, it will form igneous rock. But do you realize, supposingly there is igneous rock already present, and then let us say lava comes out, that can possibly melt the igneous rock also. Yes. So melting can again form it or make it a part of magma. Okay. Now igneous rocks and can undergo weathering, lithification, and all those processes, you know. They can form. They will lead to formation of what? Sediments. Sediments formed from the igneous rock. That can happen. Now, please understand, we know this something very clearly, that these sediments can later undergo compaction, sedimentation, and all those processes and can form sedimentary rocks. These sedimentary rocks can undergo heat and pressure and form metamorphic rock. Yes. These metamorphic rocks itself can undergo weathering and lithification, later on form sediments and then form sedimentary rocks. Clearly, magma can further melt these sediments or sedimentary rocks and metamorphic rocks and again becoming a part of what? Igneous rock. So all these cycle is one or the way other way related to each other. Yes, this is known as rock cycle. Clear? Okay. Are you ready for the questions? Let us see the MCQs. Just give me a minute. Okay. Can we begin with the questions? So let's start. Question 1. Tell me the answer. Have a look at the question. What is the question here? With reference to the igneous rocks, consider the following statements. Igneous rocks are usually called parent rocks. They usually contain fossils. They generally crystalline and hard. They have well-defined strata like the sedimentary rocks. What is the answer here? Quickly, 1 minute. 1 minute. Quickly tell me. What is the answer? A. Let's see. Igneous rocks are called parent rock. Yes, this is correct. They usually contain fossil. This is wrong. They do not contain fossil. So this statement is wrong. The moment, let us say, where is 2? 2 is here, cut this. 2 is here, cut this. Now just remember, I do not even have to read third point. Why? Because in the 2 remaining points, 1 and 3 are present. That means 3 is by default correct. See, this is the way how you save your time. In the remaining 2 points, point number 3 is present. So I know by default it is going to be correct. So I don't need to read it. I have to read point number 4. They have well-defined strata like sedimentary rocks. They do not have strata. That means 4th is also wrong. So the answer is A. Correct? Yes or no? Somebody is saying D. Bhai, strata are present is associated with sedimentary rocks. It is not saying. They are saying they have well-defined strata like sedimentary rock. We are talking about igneous rocks, not sedimentary rocks. Clear? Yes or no? Answer is A, 1 and 3 only. Somebody I think did not write like. They thought we are talking about strata and sedimentary rock. Please be very clear when you are answering these questions. And please focus properly. Clear? Please focus properly. This is very, very important. Next question, ready? All of you ready? Let's see who gives the answer first and a correct answer, right? Let's begin. Question 2. It's on intrusive igneous bodies or forms which are correctly described. So you have to tell the correct. Batholith, laccolith, sill and dike. Quickly read it and tell me the answer. Tell me the answer quickly. Please mention A, B, C, D rather than mentioning 1, 2, 3. Please, it's a request to you. I'd already mentioned you are preparing for civil services examination. I want answer in A, B, C, D, not 1, 2, 3, 4 and all. Please. This is A, B, C, D written. Mention in A, B, C, D. Okay, somebody is mentioning C, somebody is mentioning B. Okay. I said not 1, 2, 3, 4. I just please mention A, B, C, D in that terms. Please. It becomes easier to understand what you are answering. Right? Okay, let's see. Batholith are large granitic bodies formed at greater depth. Correct. Laccolith are dome shaped. Yes, because P word was plate saucer shaped and the other word was again dome shaped. Okay, correct. Sills are vertical intrusive bodies. No, sill and sheets are horizontal. Horizontal. So this point is wrong. The moment 3 is wrong, cut 3. 3 gone, 3 gone. That means, okay, 1 and 2 are correct. Now I can confirm that yes, 1, 2 are correct. What is there? So now dike are vertical, wall-like intrusive. Yes. Dike were vertical. Sills were horizontal. So this is also correct. Answer should be A. No, sorry. If this is correct, so B. Right. Sorry. It should be B. Because I marked it correct. Sorry. Don't commit this error which I have committed. I marked it here right, but marked it wrong here. So yes, this is right, and this is right. B. B. B is the answer. Not A, B. Oh. This mistake is very bad. This is one of the worst mistakes that you can commit. See, I have experienced this. I would request you also to be very careful. Sometimes what happens is you over here mark it correct. Like you know that this is correct, this is correct, and this is correct, this is wrong. But over here marking it wrong, that is the worst form of mistake because you know the answer and still we commit a mistake. So just be careful about that. Clear? Okay. Let's move to the next question. Ready? Question 3. Question 3. With reference to the sedimentary rocks, consider the following statements. Tell me. Yes, in the exam it happens. Clear? Okay, Akshay is saying happens because you're continuously teaching since morning. Yes, it happens. I can understand. I think this time, if I say I've not taken even 1 hour break, if I am not wrong, from the past, what is the time right now? Okay, from past, I think, plus 9.5 hours plus, I haven't taken 1 hour break in totality. Less than 1 hour break I've taken, right? If I'm not wrong, right? Okay. Okay. They are formed. What is the answer you are giving? People are mentioning B. Okay. Let's see what is the answer. Any other answer that you're mentioning? No? Okay, let's see. They are formed by the deposition of sediments in layers. Okay, clear. Sediments in layers. Please see very, very careful. Deposition. Okay. Sediments in layers. Okay. Correct. They commonly contain fossil. Okay. Now, because 1 and 2 are correct, so I can tell you that these 2 are not correct. Now, do you realize, do I even need to read statement number 4? Everybody see this. Everybody see this. Do I even need to read statement number 4? No, because the ones I have eliminated, because I know 1 and 2 are correct. So 2 is not mentioned here, 1 is not mentioned here, I have eliminated both of them, right? Over here, 4 is not present in both of them, so I do not even need to read 4. They occupy about 3/4 of the Earth's surface approximately. Yes. B. Understand, this is how you save your time. Many of the candidates, though they would have eliminated this, they would still be reading 4th point. Arey, 4th point kya hai? Arey, this is not required. These are the certain skills you need to learn. That comes with practice. Right? That comes with practice. You need to do thousands of questions, only then you will reach the level where you know how to eliminate very smartly. Please remember, out of the 100 questions that come in the prelims, I'm talking about general studies, you will be confidently able to do 35 to 40 questions only. 35 to 40, confidently, 100%. Sometimes even less. What about the other 60 questions? Now you cannot just go and just do 40 questions and leave your paper. No, you will have to do other because you never know what the cutoff might be. So in the remaining questions which you are doing, let us say you're adapting 85 questions. Let us assume 85, 90 questions, whatever. In those questions, you have to be very careful in what you are attempting. Then please remember, once a candidate who has solved thousands of questions, see, many will say, many toppers, many people will be saying, I respect everybody's opinion, right? Many will be saying, Arey, there is no need to solve. Okay, it is good. But tell me one thing, if 2 people have equally prepared or prepared well, right? Prepared well, the one who has solved thousands of questions more than the other person will definitely be at a better position. Right? Okay. See over here, it is saying non-porous, right? Non-porous, just to test, just to confirm to you, it is not non-porous, it is porous. That is why the statement is wrong. That is why I was not even interested in reading this, because I knew the statement is wrong, because in this 4 is not present. but it is porous in nature. Clear? Okay. Same goes for the mains examination. In the mains examination, when you're continuously reading the content, okay, you can have knowledge about the content, but what about writing? That is why, please remember, in mains is very easy in comparison to prelims. Why? But there is a condition here. If you know the skill of answer writing means that if you have a limited content also, you know how to interlink the topics, you know how to write the way, how you can add diagrams, flowcharts. If you know that thing now, even with lesser knowledge, you can qualify this exam. Unfortunate thing is that many people just are in the process of revising, and they do not write. And that is why, in spite of the fact that they could have qualified this examination, they do not qualify. That is why for prelims, read, revise, equally important. Revise multiple times, but practice. For mains, again revise, but practice. More you practice, okay? More you practice, greater is the possibility of you qualifying this examination. Remember that. Okay, let's begin. Answer this. What is the answer? Bedding plane in geology. Now see, bedding plane in geology, or let us take geomorphology, is associated with which among the following? Do you realize just now you've studied, so it becomes easy. Otherwise, if you read the statements, it is very close. Do you see that? How they have linked it? They have linked it to the metamorphic rock, they have linked it to the sedimentary rock, they have linked it to the fracture, they have linked it to the surface of the lava flow. Had you not studied this when I had taught you, do you realize, just imagine, you would have got confused whether it is metamorphic rock, whether it is two consecutive sedimentary rocks, or fracture. It becomes easy because you have studied these concepts which I explained to you. Otherwise, many of them would have marked this or this. Who knows? Very easy. You know that it is B. Clear? I think I don't have to explain this. It is very clear. Okay. Consider the following processes with the formation of the sedimentary rocks. What is the order? Give me the answer. What is the answer? Anybody? Somebody is mentioning C. Somebody is mentioning A. Do you all remember what is the first step? There was, I told you, weathering. Where weathering, you will realize that physical, chemical, and biological processes lead to formation of the sediments. That is the process of weathering. After weathering, you realize there is transportation, deposition, and strata formation in the phase of sedimentation. So that means first is weathering, second is sedimentation. Then you realize in diagenesis, there is compaction and cementation begins. Yes, and recrystallization also possibly can take place. So that means diagenesis. Last is lithification, is compaction plus cementation completion. So that is fourth. So the answer is A. Answer is A. भाई इसमें गलत कैसे कर सकते हो यार? भाई, you need to be very artistic in nature. You need to be a super cool Michael Jackson to commit error in this question. Right? I am teaching here for past 10 hours and I am telling you, you are getting this question wrong. Tell me. Just tell me, how can you get this question wrong? Yeah? Okay. Clear? Okay. I am giving you 10 minutes, 10-15 minutes break, and I'm going to begin with the geomorphic processes. This is one topic which people find it very difficult. And over here, I'm going to explain you geomorphic processes, weathering, erosion, all the processes with diagrams and all. See here quickly. Over here, I'm going to explain you all the processes. All this is not present in your NCRTs also. Type of folds that are present, what are the classification, what are the type of fractures that are present, faults, all the phenomena here, what are the forces that are acting, weathering, how it takes place through various mechanical processes and all, granular, I have made all the diagrams also here for you, exfoliation, chemical processes, biotic weathering, mass movement. This is one concept that people find it difficult. I am giving you a break of 10-15 minutes, and after that I will again begin. Please remember, this is the critical chapter which you should know, right? This is a critical chapter. So let us stop here for 15 minutes and then I will begin it again. Please stay together. We'll be there. I'll be again resuming after 15 minutes. We'll be solving a lot of MCQs also and continuing. So please, I'll be coming after 15 minutes. Meanwhile, whatever you want to have, whatever you want to eat, you can have and eat, and then we'll be here again. Hello everybody, I guess you are all doing well. I am back. Okay, let's continue. Geomorphic processes. Now please understand this. This is very important. This chapter over here, geomorphic processes, is something that people or students basically find it very difficult to understand. And they feel here, how should we do this chapter? There are a lot of things that are associated with this. There are a lot of dimensions, a lot of processes. But again, this chapter itself is one of those critical topics of physical geography. If you haven't done this, that means your geomorphological part of geography as a unit is incomplete. If you remove this chapter, you haven't studied geography properly, or rather you haven't studied geography only. So if you want to study geomorphological part of geography and you haven't studied this, then you haven't done anything. So importantly, you should study this topic very carefully. And if you have done this, you will be in a state where you will feel confident, because questions that are asked very often, did you realize they sometimes ask you, which is a depositional feature of glacier? Is this an erosional feature of glacier? Everybody over here, tell me honestly. Sometimes when the thing comes that this is a depositional feature of glacier, is this a erosional feature of glacier? This is depositional feature of let us say karst topography. It is a erosional or depositional feature of karst topography. These things come. I will be giving you questions on these things. And you will realize for yourself that, acha, now I have a good idea what these questions are, what the topic are, how to differentiate and how to solve them. Just to show you, see, neither NCERT or things, see, wherever, even I have added to what we say as a UDAAN magazine, I have added to that topic also, right? See here, just a minute. Like over here, I've made all the diagrams and all also, plus just give me a minute. So, where is it here? Geomorphic process itself, I have divided into two parts. This part, and then I'll give, after completing this part, then we will go on to the landforms topic, where we will cover this, because that is an extension of this topic only. So please, let's start with this. This will form the basics for the second part of geomorphy, geomorphic processes, because that is very clear, right? Okay. Now see here. What do you understand by geomorphic processes, right? Geomorphic processes. Geomorphic processes are natural physical processes. What? Natural physical processes that create, modify or destroy landforms. Any landform that is present, right? Any landform that is present, let us say mountain, let us say some plain, let us say some plateau. All those things are present. Now there will be a lot of processes that will be acting. Lot of processes will be acting. Those processes can be surface processes also. There can be from inside the earth also. Let us take an example. Everybody see here. Let us go to all of you. Like I am from Dehradun, right? It is a dune valley. Beautiful place to stay. Nowadays, a lot of traffic is there. But still, I take you all to the Himalayan region. Now, when you go to the Himalayan regions and I'm showing you the mountain ranges and all those things, do you realize, you will observe that, sir, are these mountain ranges rising? I'll say yes. Why? Because again, because of the tectonic activities that are taking place. Now you will say, sir, what are tectonic activities? I said the movement of the plates and all. I said, okay. So then how is it taking place? Because I've taught you the convectional currents that are moving, that is forcing the plates to move, and that is why collision of the plates is happening. And again, yes, Indian plate is moving towards the Eurasian plate, and these mountains are rising, these ranges are rising. Okay, sir, can I say, sir, that these are processes which are operating within the earth or inside the earth? I'll say yes. So what is the meaning of the processes which are involved or operating inside the earth? I'll say those are endogenic or endogenetic processes, because what are they? They are operating within the earth. Okay, sir, this is fine. Second thing, you will say, sir, are these mountain peaks getting eroded? I will say yes. How are they getting eroded? Sir, I will say the rivers are moving. Yes, they are flowing at a very fast pace. Are they eroding the various paths of the mountains and let us say creating certain gorges, valleys and all? You say yes, sir, they are. So, do you realize those are basically operating what? On the surface of the earth. So, can I call them exogenetic or exogenic processes? Do you agree to this? There are certain processes which are acting inside, below the surface of the earth, and there are others which are acting on the surface of the earth. There are some endogenic or endogenetic process also, and there are other which are exogenic or exogenetic processes also. So, can I say one more thing? Just understand, any landform that is present in any part of the world, it is an outcome of the endogenetic and exogenetic processes that are acting on it. Yes or no? Because endogenic processes might be creating certain things also. Exogenic processes might be destroying also. They can do the vice versa also. In many cases, it is there. So, that means it is basically an outcome of the balance between the endogenic and exogenic processes. That is why you have a landform. So, can I say these processes are modifying a landform? They might be creating a landform. They might be destroying a landform. So, this is what geomorphic processes are. Geomorphic processes are natural physical processes which are modifying, destroying, or even creating what? The landforms. Please understand, this is done through the action of weathering, erosion, transportation, and deposition. Now, right now, because when we will do these topics, you will be better able to understand what is weathering, what is erosion, what is mass wasting. Then all these things will be clear to you. Right now, we are just beginning it. So, in a way, geomorphic processes encompasses both endogenic processes, endogenic that is, operate inside the earth. Exogenic are one which are operating on the surface of the earth. Is it clear? Is it clear? Now, let us begin with this particular flow chart. See here, factors affecting Earth's crust. Clear? Clear? Bete, watch this UDAAN series. This is equally important. Everything is being covered here, right? Watch this. This is equally good, even better. Over here, I am solving multiple choice questions and all. So, if you are watching this series, follow this also. UDAAN is equally good, even better. Clear? Follow this, right? Right. Okay, let's see here. Please remember, forces affecting the Earth's crust are broadly two categories. Please remember, endogenetic can also be known as endogenic. Endogenic can also be known as hypogenic. These are three words for one and the same thing. UPSC can change the words and they can ask you. You should be well aware of these things. Clear, everybody? Clear? Endogenic, endogenetic, hypogenic. These are one and the same thing. Exogenic, and epigenic are one and the same thing. Many people, I still remember in various examinations also, sometimes people get confused when a question was asked, what do you mean by epigenic processes? People say, epigenic? Epigenic is what? It is basically an alternative name for exogenetic and exogenic processes. So, they can, instead of using these, they can use the word epigenic and hypogenic, and you will get confused. So, please keep this in mind. You should not make a mistake. Right now, please remember, I am doing this. Later on, I will make you understand this also. I'll show you here. Just a minute. Okay, let's see here. See, endogenetic or endogenic or hypogenic, just see the diagram, then we'll do an explanation also. These are divided into two broad categories, diastrophic and sudden. Diastrophic can be volcanic eruptions and earthquakes, right? because volcanic eruption, sudden activities, earthquake are sudden. Next is diastrophic. Now these diastrophic can be divided into further two categories. Epirogenetic and other is orogenetic. Epirogenetic can be divided into two categories, emergence and submergence, and orogenetic into tensional forces and compressional forces. Now let us understand, you've seen the chart. Please understand this is related to endogenetic processes. I will be covering exogenetic afterwards. First, let us see this. Now let's see what are these. Diastrophic. Diastrophic basically involve both vertical and horizontal movement caused due to forces deep within the earth. Sudden, again, volcanic eruption, which are sudden activities. Now let us see what are epirogenetic. Let us understand this. Epirogenetic means, epiro means continent, genetic means origin. Epirogenetic means continental origin, that is something of a very large mass which is either emerging or submerging. So that means epirogenetic movements of forces are emergence of large continental masses because of the upward movement. Something forces that are exerted from within, which leads to emergence of certain continental landmass or large landmass. On the other hand, submergence means submergence of large continental landmass, that means downward movement. Understood what is epirogenetic? Again come back. Endogenetic or endogenic forces include diastrophic and sudden. Sudden includes earthquakes and volcanic eruptions. Diastrophic includes epirogenetic and orogenetic. Let us see epirogenetic first. Epirogenetic means, epiro means continent, genetic means origination. So continental origin, that means large mass might either emerge or submerge. So emergence of large continental masses is basically known as emergence, which is upward movement, and submergence is submergence of land mass. Now, this is orogenetic. What do you mean by orogenetic? Orogenetic, orogen means mountain, genetic means origin. Now again, please understand, horizontal place, these are horizontal forces having diverse effect over here. That means origination of the mountains take place. How it is happening? Let's see. Tensional forces and compressional forces. See, tensional forces are divergent. Divergence forcing that is acting is tensional forces. Compressional forces are convergence that is taking place. Both of them, through both of these cases, you can realize there can be mountain building that can happen. We'll study when we'll be studying the chapters further. These things will be clear. Okay. Tensional forces can create cracks, fractures, and faults. Compressional forces creates folds. You remember? Folds? Compression creates fold. Tensional forces can lead to creation of fractures, faults, or even cracks. So this is again tensional forces, cracks, fractures, faults example. And in compressional forces are convergent. I've given the example of folds, right? Folds. Okay. Now the question comes, this NCERT does not mention. NCERT stops here. But we need to study what are folds and faults. That is very, very important. Let us study folds and faults. That will enhance your understanding of this topic, which is very, very important here. Let's begin. Let us study folds first. See over here. Wave-like bend formed in the crustal rock. What is wave-like bend? This is a, let us say any, let's say sedimentary rocks or all. Compressional forces is formed, exerted. So do you realize this is a wave that is formed? A wave is formed because of the compression happening. Let us say compression is happening from both sides. It can also happen where compression is acting just from one side and other is static. Then also it can happen, right? So this will lead to such structures. So they are bends that are in the crustal rocks due to the compressional forces, resulting in horizontal movement caused by the endogenetic forces originating from deep within the earth, such are known as folds. Okay, just tell me one thing. I have marked a point over here. This is A, this is B, right? Just tell me, syncline is A or B? Syncline is A or B? I had talked about syncline and anticline, remember? While I was talking about faccolith, in the intrusive igneous landforms, I had mentioned faccoliths, and where I had mentioned syncline and anticline. And I had mentioned there, come on, quickly tell me, how many of you know this? Come on. I had told you this downward bending is syncline, upward bending is anticline. Okay, now, do you want to know how to remember this? Everybody, do you want to know a trick how to remember it? Quickly, do you want to know the trick? Tell me. This is one thing that most of the people get it wrong. In most of the times whenever I ask the candidates, they always get it wrong. Do you want to know the trick? You will laugh when you listen to this, right? Just tell me one thing. Beta, A is this shape. So upfold, this can be seen as A. This is A, so it is anticline. A for anticline. Will you remember this? Simple. Use your logic, bache. This is A. Can you remember this? Upward is A. It is anticline. It is more easy. Will you remember this? How I've done? This is A. Anticline. You will never in your life forget this. You will never in your life forget this. That is why, forget this. S for sync, S for syncline, that is fine. But this is even easier. A anticline, which is again it is in this way, right? Clear? Never forget this. These are small tips. Please remember when you are actually appearing for an examination, right? Many times or very often I would say that people tend to forget these small things because there is a lot of pressure. But once you know the trick, never in your life will you forget this concept again. Clear? Okay. So, when I see this structure, somebody asks me this, oh, this is A. This is anticline. This is syncline, obviously, which is remaining. Okay. Now, please understand, anticline over here, the upfolded rock structure, syncline, the downfold. You already know this, so I don't have to worry about this. Now comes the topic of type of folds. When I talk about folds, please remember when the compressional forces are acting, the way the fold is formed works on various parameters. First of all, whether the compressional forces are acting from both sides, whether it is acting from only one side, what are the type of rocks, elements that are present in the rock, what is the bedding or how the layers are present, what is the degree of the force that is acting. So multiple dimensions are there, and that is why you realize folds of various shapes and sizes and types are formed. So based on that, I am basically listing over here all the types of folds that can be present in the market in the sense in the world. Okay. Symmetrical folds. Please remember one thing that should be very clear. Whenever we are studying a fold, before we go ahead, this is known as a limb. This is a limb. This is another limb. Right? These are limbs. Just remember this, right? Okay. Come here. When both the limbs bend at equal and dip at the same angle, then it is known as a symmetrical fold. See here. The angle between these, or let us say the angle between these or the angle between these angles are equal. Do you agree to this? This angle is equal to this angle. This angle is equal to this angle. This angle is equal to this angle. So do you realize the limbs bend at equal angle. So that is why it is known as a symmetrical fold. When this does not happen, then the angle is not symmetrical. Let us say this angle might be different from the other angle. So that means there is, over here, the both limbs do not bend equally. Then it is known as asymmetrical fold. Clear? Next comes, done, symmetrical, asymmetrical. Symmetrical, asymmetrical, done. Next comes monoclinal fold. What do you understand by monoclinal fold? Please remember, it is a bend in the otherwise horizontal rock layer where the layers tilt in one direction like a step. Now see here, sometimes what it happens is, how it is formed, please see. Supposingly this is what? A sedimentary rock. Sometimes the force is exerted in such a manner that this part remains almost stagnant, but this is bent like this. You will see a step-like structure that is formed. Step-like structure that is formed. Now, this is known as a monoclinal fold. Monoclinal fold. Or you can say a 90-degree. Yes, but again, 90-degree can also be mentioned, but this is a step-like structure. So, this is known as a monoclinal fold. Clear? Yes, 90 degrees there, but monoclinal fold is basically associated with a step-like structure. Now, see here. So you realize this is a step-like structure, almost 90 degrees here, right? And the tilt is in one direction, which is like a step. This is known as a monoclinal fold. Please remember, you will not find such detailed diagrams anywhere. So please focus here and just keep it in your mind. You will always remember it. Symmetrical, asymmetrical, monoclinal fold. Done? Done? Any query out of these three? I guess no. Clear? Next, isoclinal fold. See here. Here the limbs of the fold become parallel but are not horizontal. See here. These are almost parallel to each other. This is almost parallel to each other. This is almost parallel to each other, but it is not horizontal. It can be of any, in any direction. This twisted, but it is not horizontal. It should not be horizontal, and the limbs should be vertical. The limbs should be parallel to each other. That is known as an isoclinal fold. What are the two conditions for isoclinal fold? What are the two conditions for isoclinal fold? First is, it should not be in a horizontal direction. Not horizontal. Second is, the limbs should be parallel. Limbs should be parallel. These are the two conditions. This can be asked even in your MCQ. With respect to the isoclinal fold, explain the following. First, the limbs should be parallel. Yes. Second, they should not be horizontal. Good. What now comes the recumbent fold? Recumbent fold is one where the limbs are parallel and it is in horizontal shape. Then it is known as a recumbent fold. That means if I remove the condition over here, not horizontal, and put it that it is horizontal and it is parallel, then it is recumbent. Limbs of the fold become parallel, yes, as well as horizontal. So see here, over here it is in horizontal shape, and what is this? This is parallel to this, this is parallel to this, this is parallel to this. Then it is known as a recumbent fold. Clear? Clear? Yes or no? Clear? Identify the keywords here, because very often, see, the various books and all sometimes tend to confuse you, and sometimes it becomes difficult to understand also. So it is very, very important that you have these things clear in your mind. Clear? Okay. Now, sometimes what happened, the next step sometimes is overturned fold. Overturned fold. Now what happens? If one limb, this is a plane, this limb is moved forward due to the compression, due to the forces that are exerted. When one limb is thrust upon another fold due to intense compressional forces, then it is known as a overturned fold. See here, this was over here like this only, but it has moved forward a little bit. Then it is known as overturned fold. It is thrust force to move ahead. This is known as overturned fold. Clear? Overturned fold. Clear? Now next, till here it is clear. Yes, isoclinal exhibit vertical. No. Isoclinal, remember this. Very important. Isoclinal can be vertical. Isoclinal can be like this also. Isoclinal can be like this also. Isoclinal can be like this also. But it should not be like this. Do you understand this? Good question. Good question. Other than horizontal, anything is valid. Isoclinal definition will be valid for that. The moment it becomes horizontal and it is parallel, obviously, then it is recumbent fold. Clear to everybody? That is why I have not written vertical here. Vertical, yes, it is a isoclinal, but it can also be isoclinal if it is in this direction. Only in the horizontal way, then it is recumbent fold. Clear, everybody? It was a good question. That is why I answered that. Good question. Okay. Let's move ahead. Next. Open fold and close fold. If, please understand, the angle between these two limbs is more than, let us say, more than 90 degree and less than 180 degree, it is known as an open fold. And if between the two set of limbs over here, if it is less than 90 degree, it is known as acute, less than, that is acute angle is there, then it is known as a closed fold. See again, if the angle is less than 90 degree, that is acute angle, it is closed fold. If it is more than 90, less than 180, then it is what? An open fold. Clear? Now comes the most important topic in this fold, which is nappy, right? Nappy. Please remember one thing, I will be giving you a question to understand. It is quite possible in the mains examination also. Prelims, so they can ask you, nappy is associated with what? Many will be writing diaper. Yes, now this is what, if the examination in paper 1, it comes, describe or write a note on the nappy. Many will be writing, it is very critical for the hygiene of a child. Nappy stops the urine flow that is taking place in the babies. It also stops the stool also. Though it has bad smell, but it is good for the baby. This is what you will do. I know many will do this because they are rocket scientists. Nappy is not that, because many will say, sir, paper 1 has society, and when society, children are also there, and children's health is also important. If children's health is important, nappy also becomes important. No, right? So what is important here? Nappy. See here, you have already studied the overturned fold, right? You have already studied the overturned fold. Now this is an extreme aspect of the overturned fold. See here, due to the continued horizontal and compressional forces, the broken limb of the fold, please remember, in the overturned fold, this was thrust on this lower limb. It was moved a little forward. Sometimes this upper part is moved multiple kilometers or many kilometers away from the original position. Then this upper part is known as a nappy. It is thrown several kilometers away, then it is known as a nappy. Understood? In the examination, a question can come. Let's see this. If it in the mains examination, right? you need to understand one thing very clearly. When you're talking about NAPI, you should first of all know we are talking about geomorphic processes which are endogenetic in nature. Endogenetic in nature. Within the endogenetic nature, you have the compressional forces, you have the tensional forces also. In the compressional forces, you know the folds are very important. Clear? Within that, you have the concept, within the fold, right? Just give me a minute. Within the compressional forces, you have basically studied folds. Now folds, you know that if you want to explain the formation of NAPI, you will not simply give this diagram. You will first of all, what will explain, how will you explain? See here, that you can write a little bit of fold and about compressional forces and all, and compressional forces, then you will define what NAPI is, definition, and after that possibly a diagram to represent it also. How the diagram will be there, you know that very well. Right? Now you know that what is this fold? Let's take it horizontally only in a way. Stage 1, let us say. You realize that after that it is possible what is this fold? What is this stage 2? Stage 2. We have studied this in the overturned fold. Stage 3 NAPI formation, where we realize this, that this has gone multiple kilometers away. So this upper part, this part is known as NAPI. Clear? Clear? This is how you link and write even if you have less content. Examiner, the moment they see the diagram, they said this child has a proper knowledge. Diagram and explanation, and possibly write the significance on, and you are done. 10 marker, that is what is required. Clear? Okay. See here. Done? Clear? Okay. Now, next part is crustal fracture, right? Right? Crustal fracture. Crustal fracture, if you realize, what happened? Beta, recumbent fold, the stage 1 can be recumbent, and stage 1 also can be in isoclinal in a way. If it is not completely horizontal, but to a certain extent the inclination is there, that also can be stage 1. Stage 1 can be recumbent. It can also be isoclinal if case it is not completely horizontal, but some angle might be there. So that means stage 1 can be isoclinal also and recumbent also, in depending upon the scenario. Is it possible? Over there you can mention it can be recumbent or isoclinal, where there is no complete horizontality, but certain angle is there. So that means stage 1 can be either of them. Clear? Okay. Crustal fracture. Crustal fracture. Now you know that very well what fracture is, or joint or crack develops. It refers to the displacement of rocks along the plane due to tensional and compressional forces, either horizontally or vertically. Majorly, yes, tensional forces are there. Some form of compressional forces can also act. It is divided into two categories. First, joint. Joints are basically fractures in the crustal rocks, wherein there is no appreciable movement of the rocks. while faults are ones where there is appreciable movement of the rocks take place, right? Clear? Sir, ये why name learn नहीं होते हैं? Just remember one thing. When you enter a new classroom, I've told you earlier also, everybody, whenever you enter a new classroom or you go to a new school, there are 60 people in the classroom, right? There are 60 people in the classroom, and you are not, if you do not know the name of any person, but within 1 month, when the teacher is taking the attendance, when you're talking to them, within 1 month, you will be knowing the names of all the classmates. And after some time, all the people in the other sections also. Why? There are 60 people in your classroom and you know the name of each person. There are supposedly 5 sections and 60 people in every class, 300 people, and supposedly you know the names of, let us say, 250 of them. How are you able to remember the name of 250 of the people in 2-3 months? Why? Because you hear their name. Yes, you hear their name repeatedly. You talk to them. Okay, this is your name. That is how you tend to remember them. Similarly, why do you not treat your subjects in a similar manner? That means you need to revise them again. You need to take them as your friends. When you revise them again, by default, you will remember them. Every day, do you realize one of the major reasons how you remember the name is when the teacher says, okay, Siddharth, present ma'am, Sana, present ma'am, Samarth, present ma'am, Riya, present ma'am. So you realize you hear the name and you see this is a person, right? Because you're hearing, that is why when you want to revise it loudly, let your ears hear them. Revise it and repeatedly revise it. The next time you realize, yes, you remember it. Again, that plus the conditions apply when you're revising, your focus should be there, right? Focus should be there and concentration should also be there, right? Okay, clear. Old days, if you remember, people used to say whenever you revise it a little loudly so that your ears hear it. You know why? You know why? Because when you are speaking, your ears are listening to them, your brain becomes more active, right? Clear? Clear? Your brain becomes more active. Okay, chalo. Fractures mean that if there is, let us say, a crustal rock, there is some fracture there, but there is no movement of a rock. But in a fault, this rock supposedly might get displaced downward also. So there is displacement or movement of rock that is present. That is the difference between a fault and a joint. Now, let me show you a fault and a diagram of it. See here. This is again very important. Few basics of fault before we move ahead. After this, I will be telling you the various types of fault. Please remember, this was earlier a block like this. See here. This was earlier like this only, right? Now, if I tell you that there was certain fracture that happened here, and this part basically moved down. Can you imagine this? Everybody's listen to this and see this very carefully. Supposingly there was a fracture or a joint and this particular block moved a little down. Can I say it will be in this manner? Are you able to visualize this? This is what I'm saying joint, because over here there is no appreciable movement of a block or a part of the rock. But the moment this part moves down, I can call it a fault because there is appreciable movement of a part of the rock or a part of it. Clear? Part of it. Can you visualize this? I hope you are able to visualize it. Why have I called a joint? Because the definition over here says it very clearly that there is fracture, but there is no appreciable movement. So that is why I have called this a joint. I can also call it as a fracture. Right? Now, because of this part moves down. Now, this is an example of a fault in front of you, and there are certain parts of a fault. And fault has certain parts. Now, let us understand this. Okay, once more. Okay. Okay, let's see this. See here. Due to the various forces that are being exerted, supposedly a crack develops, not a crack, let us say to be more precise, a joint and fracture happen here, right? This part, a fracture is here or a joint. Because now, why I'm mentioning the joint? Because though a fracture has happened, this hasn't displaced or moved anywhere else. Clear? Nappy is a word that is associated with, remember, nappy is a word that is associated with folds. We are doing faults now. There's a difference between both of them. This is a joint. Why? Because right now the crack is developed, but no rock part has moved up or down. No movement has taken place. But let us assume that this force continues. And I see this that, where has it gone? That this type of a structure is formed now. This block has come down. This part has come down. Now this is because there is appreciable movement here. This is known as a fault. Now let us do the characteristics, everybody. See here. Just tell me, this block is there and this block that has gone down. This block which has gone down, and this is in the position where it was. The one which represents the lowermost part of the fault with respect to the height, right? With respect to the height, it is known as a down thrown block. The part of the fault which has gone down, that means it is at the lowest height, lowest level. So that is known as a down thrown block. The one which is at the highest position or uppermost part is known as an up thrown block. Now, please understand, there can be a lot of dynamic activities also acting. A block cannot necessarily be gone down, it can be pushed up also. We'll see that also, don't worry. But this is the lowermost level, this is known as a down thrown block. This is the uppermost, this is the up thrown block. This is the level where it had moved down. So this is known as a fault scrap. Scrap, that means this has moved down from this position till this position. The plane between this where the movement is taking place, this green part is known as a fault plane. Clear? Now see this. Along the fault plane, there are two words that you should understand, right? Two things that you should understand. This region is known as the hanging wall, hanging wall is a block above the fault plane. Block which is above the fault plane. Now you will say why it is above the fault plane? Because this is the block which has gone down or moving. So this is considered above the fault plane. This is known as a hanging wall. This side, this is completely, please, this is complete fault plane. But this plane, this part is known as a hanging wall. On this side is known as the footwall. This is below the fault plane. That means the one which was as it is, which is present here, right? This is this part, see if you can say this is a block, the edge of the block is known as the hanging wall and this part is known as the footwall, the block below the fault plane. The angle at which this movement is taking place is known as a dip angle. there will be certain angle that will be formed across which it is taking place, or angle of the fault plane can be known as a dip angle. Dip angle. So what is the dip angle? It is the angle of the fault plane with respect to the horizontal. This is the horizontal. What is the angle of the plane? This is the dip angle. Clear? Everybody clear? Are the paths of the fault clear to everybody? Are the parts of the fault clear to everybody? Can we move ahead? Okay. Now comes normal fault and reverse fault. Normal fault, reverse fault. Like folds, we have different types of, like different types of folds, we have different types of faults also. Clear? Okay. See here. Normal fault, do you remember one thing, everybody? I told you whenever we are talking about faults, we talk about the tensional forces majorly, right? Tensional forces. Tensional forces are a little bit diverging in nature. Yes. See here, supposingly this is let us say a crustal plane. There is a joint that might be created due to the forces that are acting. Now there is tensional forces, that means diverging forces. And because of that, you realize this part moves down. This is known as a normal fault. What? A normal fault. Why? See, caused by tensional forces that tend to pull the crust apart, and by the forces that tend to expand by pushing it. So that means major thing is tensional forces are acting. What are these? This is what? Tensional force. This is what? Tensional force. They're moving and it tends to move downwards. This is known as the normal fault. Clear? Clear? Now, reverse fault is a reverse of the normal fault, where let us assume compressional forces. Now you will say, sir, how come compression is come here? Because reverse means opposite force acting in comparison to the normal fault. So opposite is going to be of compression is opposite of tension is compression. Supposingly there is a joint that is existing here. Compression is acting, so that means it is possible this might be moved downward in this direction. So this is known as reverse fault. This is known as reverse fault. Clear, everybody? Clear? They are moving towards each other. So this is the major thing. You always remember I told you faults are associated with tensional forces. So tensional forces, that means normal fault will be created because of that. But reverse fault, reverse force, that means there is some compression. That is why reverse fault. This is a very simplistic definition and explanation. Otherwise, you will never be able to understand what is reverse and normal fault. Everybody clear in your minds? I have made the diagram. I have highlighted it through the keyword. Towards each other is compressional. Here it is tensional. Tensional forces means diverging forces. Diverging forces means they are moving away from each other. That is why again this diagram is there. Reverse fault is reverse of the above forces, so it is compressional. That is why this diagram. Clear? Whenever you have any problem with respect to remembering, remember these two diagrams and remember normal fault tensional, and over here towards each other means compressional. You will never forget it. Okay, let's move ahead. Lateral fault. There might be cases where two blocks of rocks like are sliding along with each other. Like they are formed where blocks are displaced horizontally along the fault plane. This is known as a lateral fault. There can be step fault also. Step fault, what happens is supposingly due to various forces that are exerting, one block might be pushed downwards, other little more downward, other more downward. So what happens when you see from a distance, you realize these are like step-like structures are formed. This is known as a step fault. Again, you realize there are again forces acting. This is a step-like structure. Clear? Okay. Rift valley or graben. See here. You would have realized this whenever you study the drainage system, you would very often come across the concept of rift valleys, right? Narmada Rift Valley, right? Have heard that? The concept of Rift Valley is very common when I'll be doing the Indian geography. I'll be doing the drainage system, so I'll be mentioning all these concepts also. Now, there are various processes through which this can happen. Let us say, when you see a rift valley, see here, there will be certain part which is above and certain part which is at a lower altitude. This part is known as a horst, H-O-R-S-T. If it is not clear, I'll just write it again. What is this? H-O-R-S-T. The one which is down thrown or moved downward is known as graben, G-R-A-B-E-N. G-R-A-B-E-N. Now you will say, sir, how is it possible? Satpura, absolutely. How is it possible? See here. Supposingly, let us see this, though I will be telling you over there also, but let us understand this. Let's see. Clear? Great. Yes, yes. Now, what happens sometimes is, it is possible that certain fractures might have been created. There is a process, there is a probability that supposingly due to the fracture created, this might move down. My board has started shaking. I don't know, there was an earthquake or possibly I'm shaking, I don't know. Chalo, koi nahi. As it is after 11 hours, everything starts shaking. So what can you do? Okay. This part moves downward. So can I say the new position can be this? And this can be removed. This can be removed. That means this has moved down. Yes or no? Yes or no? Yes, possible. It is possible. Another thing that can happen, I'm saying here that supposingly these are still, they are not moving, still, but this has moved down. Case 1. This is first case where certain part has moved down and the one that is remaining here, that is why you can call it a rift valley over here, because this is the rift valley which has gone down, and these are again what? The part of the one that is at a higher altitude, right? Another thing that can happen is possibly case 2. Case 2 is that some part can be pushed upwards also, pushed little upwards. In that case, the other part is still, but the part that is moved, let us say this part is moved upwards. So it can move above and the height will be more than the surrounding. So in that case also you can see a rift valley, this is also known as block mountains also. If you see, block mountains are formed because of this, right? Clear? Okay. Third case is case 2. Third case is where both of the forces are acting, where some part is going down, other is being pushed up. In that case also you can have even higher block mountains. Clear? Everybody clear? So this is again a relief feature resulting from the faulting activities, represents trough and depressions or basins between the crustal parts. So this part is known as a rift valley between these two heightened parts. Right? Clear, everybody? Clear? Okay. Now see, how many of you remember that in the first diagram that I had done, I had told you about endogenetic endogenic and hypogenic forces. Do you remember that? How many of you remember? I have done this, right? Have I done this? This was done? Yes or no? We have done this, epirogenetic, orogenetic, all those things are done. Now having done this, I am coming to exogenetic and exogenic processes. Understood? I've completed endogenic or hypogenic. Now comes exogenetic, exogenic or epigenic. What do these basically include? What do these basically include? These include weathering. Weathering can be physical, chemical and biological. What is it? Physical, chemical and biological. I'll be explaining you them. Then there is mass movement. Please remember, this is the most interesting topic, mass movement, where movement is taking place under the impact only of gravity. There is no external force. Any movement that is taken place under the impact of gravity, let's say certain rocks fall, right? Under the impact of gravity, that is mass movement. That can be slow, that can be rapid, that can be very fast also. We will be doing this in detail, don't worry. Weathering and mass movement. Then comes the erosional and deposition. Do you realize any force that is eroding is also depositing? Let us take running water. Do you realize running water is also eroding mountains, places where what lot of things, but they are also depositing, forming deltas. Yes or no? Similarly, groundwater in the karst topography is also eroding. It is also depositing stalagmites and stalactites. You've seen that. Glaciers are also eroding. They are also depositing in the form of tills and moraines. Waves and ocean currents are also forming, let us say they are eroding the, let us say wave cut platforms are what? Erosional features. But beaches are what? Depositional features. So that means, remember, these are agents of erosion as well as deposition. Agents which they are both erosional and deposition. That is why I have written the same thing below both of them. After completing these two parts, when I will start this, after completing weathering and mass wasting, I'll give you 5 minutes break. Then I will start this. That is the last part of geomorphological part, where I will be covering running water, erosional feature, depositional feature, glacier, erosional feature, depositional feature, glacier, erosional feature, depositional feature. Once you have done that, UPSC will ask any damn question, you will be able to do it, right? Any damn question, I'm going to do it with diagram. So make sure that you understand this is very important. A lot of effort is put here. Make sure that you understand, then you will not require anything else. Clear? Okay. Right now, let us begin with the concept of weathering, then mass wasting and these two. Let's begin. Clear? Yes. Now see, everybody, just before I begin with this, weathering is a process. What are the driving forces? Before we begin, you should just have an idea of it. Weathering, what are the forces that are acting? The forces are physical, chemical, biological and also gravity for that matter. Physical forces, we will see chemical processes, biological processes that are acting. These are what? Driving forces. Mass wasting or mass movement, both are one and the same thing, mass wasting or mass movement. Here, whatever movements are taking place, all of them under the impact of gravity, nothing else, only gravity. Erosion is because of the kinetic energy. Just tell me one thing, when the river water is moving, there is kinetic energy present there. That kinetic energy is basically eroding. Later on, when the energy decreases, the deposition happens. The glaciers are moving, there is some kinetic energy there, the movement is causing the erosion. Later on, when that energy decreases, it basically deposits. Yes or no? So kinetic energy is the reason for the erosional activities to take place. When that energy decreases, the deposition happens. Yes. So in the erosional process, kinetic energy is the driving force. When that decreases, the deposition will happen because they do not have the energy further to carry it forward. Like the rivers basically erode, they carry the sediments along with them. But they have the force, that is why they are able to erode it and they carry. But once that energy is not present, that means, what do I understand by this kinetic energy? Over here, it has the ability to move it also, transport it also. That is because of the energy, to erode it also because of that energy. Energy decreases, deposition. Yes, it is somewhat like when you are fresh, you can carry a lot of load, you can study a lot. By the time you reach the end of the day, the amount of input that can go in your mind will decrease. Why? Because you're already now lacking energy. Again, everything comes to the basis of the conservation of energy, right? Energy cannot be created or not destroyed, but it can be transferred from one body to another. Now, I am speaking here for the past 11 hours, possibly with the same energy that I started my lecture. So I should also transfer my little bit energy to you people so that you are also in a state where you also show a little bit of energy so that you are able to incorporate these things in your mind. Yeah? Right? Right? Clear? I'll explain you that, Manish. Let us do this. We'll be doing that also. Okay. See here. Let us begin weathering. Let's start. Beta, if I am not, see, remember, I have already told you because YouTube has restricted to 12 hours. I cannot go beyond 12 hours. Till whatever I am able to do till, let us say, 11 and a half hours, will do this. In the next lecture, which is on 19th, because the Indian geography part is generally of 7.5 hours to 8 hours. The remaining hours I will cover the physical geography part, that is little bit climatology and ocean, because those part take lesser time. Geomorphology is the biggest part, right? So I will cover and complete it there. You don't need to worry about that. I have to complete it and I will complete it in the next video, which will cover the Indian geography part also and the world geography part also. That I will do. Don't worry about that. Because it is my duty to complete. I cannot compromise with the quality. So I'm in front of you doing every detail. I will cover them. Don't worry. Okay, let's begin. Weathering. What is weathering? Weathering is disintegration and decomposition, not deposition. Weathering is disintegration and decomposition of the rocks in situ. In situ means, right? In situ means in the very specific region where it is located. Now, please understand a very important keyword, right? What happened? Priyanshu is saying, you can shut the live session and again begin. Beta, I can do it. There is no problem. But my team will say, sir, do you realize the whole office is gone? And the only one with my studio person sitting here and the person who's giving me tea, the whole office is empty. And the only one in the headquarters over here who's giving the lecture. Everybody has gone. So possibly they will also have a life. They'll say, sir, bas karo, hame bhi ghar jana hai. Otherwise, there is no problem in continuing. Okay, chalo. Weathering is a process of disintegration and decomposition of rocks in situ. In situ means in the original place or the place where it is located. In weathering, there is, it is through mechanical and chemical changes. Even physical changes also can happen. There is no movement of weathered material unless it is under the influence of gravity. Okay? Please remember one thing very clearly. Many of you think weathering and erosion are same. It is not, because you are doing weathering right now. When you will do erosion, you will understand that also. Weathering basically disintegrates or decomposes the rocks. It is not concerned with movement of rocks, because erosion will include the transportation and all, not this. If any movement is taking place, that is basically under the influence of gravity. Weathering simply concerned is with disintegration and decomposition. Is it clear to everybody? Right? What does weathering cover? Weathering simply covers disintegration. That means breaking up or decomposition of the rocks. That is it. There is no movement of rock material. If it is going to be under the influence of gravity. Clear? This is right now. Please remember, in erosion, we are talking erosional agents will come and all that we are not studying in, that is not a part of weathering right now, right? Weathering simply is breakdown, only breakdown, remember that, clear? Okay? Whatever, please, this is whatever I've marked in yellow are the most important keywords here. There is no movement of weathered material. If there is, it is under the influence of gravity. For example, let us say there is a rock and water has entered in a crack. During the time of, let us say, in a cold region, that water converts into ice and force is exerted on the rock and the rock breaks and falls. Now that is under the influence of gravity. Understood? Like that it is allowed, but no movement of weathered material as such, that is not part of weathering. The movement of weathered material under the influence of gravity is called mass movement or mass wasting. Now understand, this movement which has happened under the influence of gravity is mass wasting. Did you understand the difference? Quickly. Disintegration of the rock, right? Because of the processes that are going to take place, that is breakdown is taking place, is weathering. Now, this movement which is happening because of gravity is mass movement or mass wasting. Clear, everybody? Now remember, weathering aids mass movement as well as erosion. See, weathering helps in erosion because, see, weathering helps in erosion. Why? Because for erosion to happen, weathering is basically breaking down. Breaking down will help in erosion. Weathered rock material is known as regolith. Regolith. Clear? Clear? Done? Okay, let's move ahead. Types of weathering. Now, weathering are of three types. Now, please, this is very important. Mechanical weathering or physical weathering, chemical weathering, and biological weathering. These are the three types of weathering. Now, I will be explaining you one by one each one of them. See here. Mechanical or physical weathering. Whenever we talk about mechanical or physical weathering, you will realize that it involves mechanical rock disintegration caused by temperature and pressure. Temperature and pressure forces. Now see, one by one. Block disintegration due to temperature changes. What? Block disintegration due to temperature changes. Now please see. Supposingly this is the original log that was present, and you realize that a large block has broken from it and fallen down. See how it has happened? See here. Block disintegration refers to the effect of temperature on different rock types like expansion and contraction due to temperature variation. Now, do you realize there's a rock present? And during the daytime, right? During the daytime, realize it is heated, and during the night time, it is cool and the temperature decreases. It is possible that cracks might develop and certain part of it might break off. And in this case, a larger part is broken down. That is why a block disintegration word is being used. So that is why, see, these lines that I have drawn are the cracks that have developed because of repeated heating and cooling. And a large plot has fallen down, large broken block. Block is fallen down, that is a block disintegration because of the temperature change. Clear to everybody? So the block disintegration is due to the temperature changes that are happening. Clear? Why? Because during the daytime when the heat is there, the temperature increases. The temperature increases leads to, again, expansion. During the night or the time, it is going to cool. This repeated cooling and contraction leads to development of the cracks which are being shown over here, and a large block might fall down. That is block disintegration due to temperature changes. Clear? Okay. First. Second, granular disintegration due to temperature changes. Now, when I talk about granules, these are finer particles in comparison to a block, right? Let us see this. Coarse grained rock, the rocks which are coarse grained rocks are more affected by shattering process in the hot desert, which are characterized by high range of daily temperature. Now, please understand, this granular disintegration, again, there can be similarity in the temperature variation that is happening in block disintegration and in this, but the difference is the type of rock we are talking about. Over here, the rock is coarse grain, right? It is not fine, it is coarse grain. If the rocks are coarse grain and are of different colors, why do I talk about different colors? If there is this dotted line represents an original rock and it is coarse grain and it has multiple different type of, let us say, minerals inside it. Now they might be of different colors also. Now every mineral has a different capacity or ability to absorb the heat. So that means a mineral of different color has a different ability to absorb. So that means that region might be heated a little more than the other part. So what happens is that this disintegration will happen into smaller particles. Same process is happening, heating, cooling, heating, cooling, heating, cooling. But these are what? Coarse grain. So that is why small fragments will fall rather than a block falling. This is known as granular. Granules are there, small particles are there, than in comparison to the block disintegration that took place in the previous slide. So this is the original surface. Now this is the new surface. Small fragments and grains accumulate that are fall down. This generally happens in the desert regions, very commonly seen there. Clear, everybody? Granular disintegration due to temperature changes. Everybody clear? Okay. Next, block disintegration due to frost. Block disintegration due to frost. Now this is also very interesting. Supposingly this is let us say a rock that is present here and it has a small crack. Generally cracks are very normally visible in various rocks also. Now water enters this crack. What? Water enters this crack during the daytime, let us assume. Now you know that during the night time it is possible that temperature might fall rapidly. When the temperature falls rapidly, you know that very well the characteristic feature of water is when it converts into ice, it expands, right? The expansive nature of the water. Do you realize when it will expand, it is going to basically exert more force on this rock and it will widen the crack? When the crack widens, it is quite possible that it will widen and later on more water will enter it. Then next happens, ice melts and again more water is here. Next time what happens, the same process happens and this is basically split into two parts. Freezing and thawing basically leads to block disintegration. So disintegration of rocks into large block size due to freeze and thaw of water, common in temperature and temperate in the cold climatic regions. Why cold climatic regions? Because see, for the water to be converted into ice in the natural environment, the temperature has to be cold, very low. This can only happen in the temperate or the very cold atmosphere, cold region. So that is why present in the cold climatic regions. Clear? Okay. Next, exfoliation due to temperature and wind. Exfoliation due to temperature and wind. Now please understand this. Supposingly there is a granite that is present here. Now you know the insolation is coming. Insolation will lead to expansion of this particular granitic rock. At the night time, again I've shown night by the moon, showing the moon. There will be contraction. When the contraction will lead to creation of these cracks. Again in the morning, expansion will take place. So you will realize that this will lead to peeling of the layers. You realize this is how mushroom rocks are formed in the desert regions, right? There will be peeling. And again, this slowly, this is a remaining structure that is formed. This is known as an exfoliation dome, also known as a mushroom rock also. So exfoliation weathering, also known as onion weathering. Why it is known as onion? Onion means, if you realize, I see an onion, one by one the peel is removed, right? Peeling happens. Similarly over here, one by one the layer is being removed here. That is why it is known as onion weathering, right? Due to peeling of concentric shells of rock due to combined action of heat and wind in the hot desert and the semi-arid region is observed. Clear? Okay. Is the physical weathering clear to you now? Did you see any appreciable movement? No. That is why whatever you have studied, understand now what geography is. Did you understand? Did I mention any transportation taking place? Did I mention any deposition taking place? Did I mention about any kinetic energy with respect to? No. I mentioned disintegration of the rocks that are taking place and whatever little bit falling of particles is taking place, that is under the impact of gravity. Now, can I say this movement under the impact of gravity is mass movement or mass wasting? Yes. We will see it in a larger extent now after when I'll show you landfall and all these stuff. Clear? Okay. Now see. Done physical weathering. Now let us come to the chemical weathering. Now, chemical weathering again, please understand. Please see one more thing before we move ahead. First is solution. Next is carbonation. Please remember, carbonation is also a type of solution. So even if we do not do, it is same. And I've written here also. It is also a type of solution. So even if you do not write carbonation, sometimes it is fine. It broadly comes under the category of solution itself. Carbonation basically comes under it. So there is no problem. Then is your hydration, then is your oxidation, and then obviously the biological weathering. Let's see here. What do you refer to? What is solution? Right? What is solution? It refers to dissolution of soluble particles and minerals in the rock with the help of water or acid. Something that is dissolving in water or something that is dissolving in acid. On coming in contact with water, many solids disintegrate and mix up as suspension in the water. Soluble rocks forming minerals like nitrates, sulfates, and potassium are affected by this process. So that means certain minerals are basically dissolving in what? Water or some acid. So that means that is again chemical weathering that is taking place. Example, this is actually an example of carbonation itself. Let us see. Minerals like calcium carbonate and calcium magnesium bicarbonate present in limestone are soluble in carbonic acid. So if they're soluble in carbonic acid, so what will happen? Again, chemical weathering due to chemical processes are taking place. Carbonation is the same thing, reaction of carbonate and bicarbonate with the minerals in a group common process is helping in breaking down of the feldspar and carbonate minerals. So this is exactly the example of it. Hydration. Hydration is a chemical addition of water like CaSO4 plus 2 molecules of water create CaSO4.2H2, which is gypsum. Now what is this? Chemical addition of water, right? Now calcium sulfate takes into water and turns into gypsum, right? Next, oxidation refers to reaction of atmospheric oxygen to form oxides like 4 iron plus 3H2 plus 3O2 gives Fe2O3.3H2, which is rusting. Rust is created, right? So this is basic formulas which you have done in, I think, school also. Next comes biotic weathering. Biotic weathering again by organisms, plants, animals, human beings. So biological weathering is a geological process in which plants, animals, and various microorganisms basically contribute to disintegration, alteration, and breakdown of the rock particles, right? Burrowing organisms. You would have seen rodents, various rodents, let us say like insects, earthworms, they create tunnels. So what happens is they're basically trying to weather the rocks, and that basically lead to their disintegration. That is burrowing organisms. Microorganisms, you know that bacteria, fungi, lichens are microorganisms that produce organic acids. These organic acids are metabolic byproducts. These acids can even dissolve various elements that are present in the rocks. So that is also contributing to biological weathering. Plant roots, you know, the plant roots go deep inside. Now plant group, they exert pressure on the surrounding, causing it to crack and break apart. That can also happen. Now comes the mass movement. Weathering concept is clear. I think we have done weathering in a lot of detail. Having done a lot of detail basically helps you from the perspective that this is not erosion. I think many of you, I'll ask you something. How many of you understood that erosion is something different? Weathering is something different. And mass movement is again another concept. You would have realized by a little bit, we've just done the weathering concept. It is basically the breakdown or disintegration of the rocks. So that is clear in your mind. Do you realize now conceptual clarity will be coming in your minds? that acha, this concept is different. It is not like rather than erosion, you are using weathering, weathering, you are using transportation. No, they have their own role. That is why these different words are present in geography. You should be very clear with each and every word. What is the meaning of that word? You cannot simply just keep on using one word for the other. And that is why many times what happens in the civil services, particularly the prelims examinations, the question is being asked and you interpret it differently and you write and you just mark something wrong. Similarly, in the mains also, they might use the word, let us say, explain the processes of weathering. And over there you said, okay, weathering, chalo, all the river, motion, glacier, vagera, everything I will put. No, that is different. So this should be very clear. Okay. Chalo. Mass movement or mass wasting, both of them are one and the same thing. So mass wasting or mass movement, you take it as one. Mass movement refers to the transfer of the mass of rock debris down the slope under the direct influence of gravity. Now, please remember, anything that is happening, let us say, if there is transfer of rock debris or any movement down the slope or from a height, and only under the influence of gravity, then it is known as mass movement or mass wasting. Now, weathering is not a prerequisite, but again, it can be helpful. Okay, again, if weathering is done, then obviously mass movement can happen, but it is not a prerequisite. That is why, see, weathering is not a prerequisite for mass wasting but though it basically aids. Aids means if weathering is happening, obviously that thing will fall down under the influence of gravity. If it is not weathered, possibly it might not fall down. So, depending upon the scenario, right? Weathering is though not a prerequisite because these are both different aspects. Mass movement aided by gravity and no geographic agent like running water, glacier, wind, waves, etc. participate in the process of mass movement. Mass movement does not come under erosion. That is why this statement can be pushed as an MCQ. Mass movement is an integral process related to the process of erosion. 100% you will mark it correct. Do you tell me honestly, if a question as a statement is asked in UPSC, mass movement forms an integral process under the broad dimension of erosion, you will say 100% are correct. No. The NCERT very categorically mentioned this statement. Mass movement does not come under erosion. And this is such a statement that if you just take the definition from your own definition or words, possibly you will get it wrong. Clear? Erosion is different. Now, brief aspect you have studied. Now, let us understand the major classes. The major classes are very rapid movement, and slow movement. Over here, there is no water required or no water is present here. Right? Now, please understand over here, do not take this water from the perspective that, okay, this is like a running water. No, it is a characteristic feature. So, do not take it from a running water perspective, please. Water over here is not present. Even without that, landslides can happen. Slump, debris slide, rock fall and rock slide. These are the 4 categories of landslides that are very fast movement under the mass movement. Over here, the characteristic feature is that they inbuilt have lot of saturation of water, right? Rapid movement, earth flow, mud flow, sheet flow and avalanches. Slow movement where the characteristic feature is some water might be present. Now that is not a, please understand, that is a characteristic feature of that thing. If you see mud has a characteristic feature that it has water. Rock fall does not have water. So it is not, please, it is a characteristic feature of different characteristic features of different, let us say, mud or earth. So you should not take it as an agent of erosion, please. That is a different concept. Slow movement includes creep and solidification. Let's see this. First is rapid movement. Rapid movement basically covers the landslides. These are relatively rapid and perceptible movement. The material involved are relatively dry. Slump, please see here. Please see here. Over here what happens is rock debris basically moves down, but it moves down in this curved path. See here, it is curving and moving down. Slipping or one or several units of rock debris with a backward rotation. The important thing is backward rotation. Backward rotation is taking place. So what is going on? It is moving backward, not simply moving down. It is moving backward and then moving down. So that means there is backward rotation with respect to the slope over which the movement is taking place. So the movement is taking place where the rock debris is moving down, but it is slumping in a curved path. Curved path. Debris slide, rapid rolling or sliding without backward rotation. So over here, the debris is moving down and there is no backward rotation that is taking place. What is backward rotation? You realize it is in a curved surface. It is moving like this and moving down. So if there is such backward rotation, it is slump. If it is moving down, right, without, beta, this avalanche is not glacier wala avalanche. This is different. Wait, study right now. Wait. Debris slide, where there is movement of the rock debris without any backward rotation, then it is known as a debris slide. Clear? Okay. Rock slide, you realize that over here, when the rocks are sliding down, sliding of the individual rock masses down because of joint and fault, it is known as rock slide. Now, there are rocks are sliding down. A rock might fall from certain height, then that is a rock fall. Rock fall is freely falling of the rock blocks. Freely falling of the rock falls, that is rock fall. Clear? Okay. Now comes a rapid movement. Earth flow, the movement of water saturated clay or silty earth material down the low angle. Over here, see, water saturated clay or silty water is basically moving downwards. This is known as the earth flow. Next is mud flow. In the absence of vegetation and over heavy rainfall, thick layer of weathered material gets saturated with water and rapidly moves down. It is much more rapid than the earth flow and it is more saturated with water, then that is known as a mud flow. Debris avalanche. Now this is the avalanche which you're talking about. Why it is known as avalanche? The speed is much more, even faster than mud holes, possibly, right? This is more characteristic in the humid regions without vegetation. Over here, the movement of debris that is taking place is much, much faster than even the mud flow. That is why it is known as avalanche. That avalanche, we are not talking about glacier avalanche. We are talking about the avalanche which is related to the mud. Why it is known as avalanche? Because the speed is very fast. Clear? Okay, slow movement. Now see, slow movement over here includes creep and solidification. It occurs on moderately steep soil covered slope. These are slope which are again, this is a soil covered slope. Now what happens is, slowly this slope will move downwards. It is so slow that you cannot basically observe with your naked eye, right? Except, like for example, if you sit here for hours and hours and days and then you see possibly some movement has taken place. It is so slow, but it is moving down. Solifluction, slow downward flowing mass of fine grains of the rock debris saturated or lubricated with water. Now this is solifluction where the soil is moving downwards because it is saturated with water, but it is very slow again. So this is known as solifluction. Okay. So factors affecting earth crust, we have done endogenetic, we have done exogenetic के these two parts. These two parts are done. Clear? Clear? Now we have to do erosion and deposition. Before that, let's first do two MCQs. Answer this. Answer this question. Answer this question. Quickly answer this question. Consider the following statement regarding weathering. What is the answer of this question? Quickly tell. Weathering involves in situ disintegration. Weathering requires movement of material. Mass movement occurs under the influence of gravity. A, B, C, D. What is the answer? Weathering involves in situ disintegration of rocks, right? Quickly, first of all, do it, then I will explain. Quickly do it. Okay. Weathering involves in situ disintegration of rocks. What is in situ? In the place where it is located. It is correct. So, weathering requires movement of material. Completely wrong. It is not required. Mass movement occurs under the influence of gravity. Absolutely correct. B is the answer. Somebody saying C. What have you eaten, मेरे बच्चे? This is what I taught you. Okay, next question. Which of the following statements are correct? Tell me. What is the answer here? Let's see how many of you can answer this. See, the good thing is that people are getting the answers now. Do you see? I'm very happy that you have been till now, since morning you have been till with me. Do you realize that you have gained a lot of knowledge? I will be adding the last PDF of geomorphology. Before we end, I will complete it. The landform chapter, which is basically deposition and erosion, I'll complete it. Don't worry. And we will complete it before 9. The geomorphology part. That is a main core region, because next chapter I will be covering climatology, oceanography along with Indian geography, right? So do you realize you are able to answer correctly now many of the questions and many of the topics? So let's see here. Folds are caused due to compressional forces. Correct. Symmetric folds have limbs dipping at the same angle. Correct. Monoclinal folds have limbs dipping in opposite direction. No. You remember that 90-degree thing which I had said? Yes. This is not correct. 1 and 2, B. 1 and 2 is B. Clear? Give me 5 minutes. Within 5 minutes, I will be adding the next slide, so that we basically complete geomorphology also. Give me 5 minutes. Be with me. There are certain questions related to that, and then we'll be doing it. Give me a minute.
बच्चे कम हो रहे हैं सर पहले जान
ओवरऑल जो व्यूज होते हैं ना वो लास्ट में
हाँ वो यूपीएससी का सर वैसे भी जिसको जब समय मिलता है हाँ लेक्चर में
Okay, quickly. I am again. You can get this on Telegram. This is my Insta ID, and this is the movement. Quickly, quickly. Are you with me? This. How much time is there? This next 20 minutes, may we will complete this chapter. You will be completed with complete geomorphology, right? My request is this next 20 minutes, because we cannot go beyond 11:55. 11 hours 55 minutes. Next 20 minutes, be with me. We will complete this quickly with proper focus, concentration, and MCQs. Are you with me? Can we start? Quickly, tell me quickly. Are you with me? Can we begin? These last 20 minutes, you have been there along all this time. Let's start this 20 minutes so that we can complete it quickly. Okay. Endogenetic, isogenetic process have been done. We have done mass wasting. We have done weathering. After this, the topic is erosion and deposition are there. Now, please see. What is erosion? See, erosion is a process of wearing away, detachment, and removal of soil, rocks, and regolith from the earth's surface by natural agents. Natural agents like running water, wind, glaciers, sea waves, and groundwater. You will see, sir, over here it is mentioning, let us say what? Detachment. Beta, detachment in weathering is or decomposition a different process. Over there, these natural agents per se are not there. Though that is a different concept. Over here, these agents of erosion are there which are basically eroding it. That is why erosion includes destruction plus transportation. Destruction plus transportation by what? These agents of erosion and transportation. Over there, weathering, these things are not there, right? So, this is erosion. Next, erosion is basically what? Detachment, that is losing of particles by the agents of erosion. By agents of erosion. Transportation by the agents of erosion, and abrasion, that is scraping of the surfaces during movement. That means they are scraping against each other during the time of movement. Okay. Deposition, briefly. Deposition is a process in which transported material is laid down when the carrying capacity of the agent decreases. What do you mean by carrying capacity of agents decreases? Because now it does not have the ability to take away or carry the load forward, because possibly the kinetic energy has decreased. So deposition is construction or accumulation. That is like delta formation is what? Accumulation, construction or accumulation. Now, what are the agents of deposition and erosion? What are the agents? This can come in examination. Waves, running water, groundwater, waves, and glacier. Waves, or I should say, right, wind. Sorry, it should be winds here. Right. Waves, running water, groundwater, winds, and glacier. Now, the most important concept which comes every year, 2 to 3 questions come. They will ask you erosional features, depositional feature of all of them. Shall we study now? Quickly, see. One by one, before I will do this later on. Okay. Landform before. This is the difference between weathering, erosion, and deposition. We will do after we have done erosion and deposition. Landform is what? A natural physical feature like mountain, plateau, or anything that is present there, right, on the surface. It is an outcome of what? The erosional features and the depositional features taking place. That is why landform is formed. Otherwise, how will the landform form? Something is being deposited, something is being eroded. So any landform is an outcome of the depositional forces, or let us say the depositional forces, erosional forces that are taking place, right? Okay, let's begin. Agents of erosion and deposition and their associated landforms. Now, with every agent of erosion, I'm going to mention the agent of the things that are deposited and that which are eroded. So, if you have done this, you will not require anything else. Let's see. Let us take wind. What does wind do? Wind is a dominant agent in hot desert. In the hot desert, it plays a very important role. Wind erosion generally takes place above the ground. Above the ground, why? Because it is basically moving. So it is obviously above the ground. So wind velocity plays a major role in the determining the earth. Now please understand, whenever I talk about wind erosion, there are three things which are happening, or the three ways through which basically wind erode. First is deflation, second is abrasion or sandblasting, and third is attrition. We'll see what are these. Deflation, abrasion or sandblasting, and third is attrition. Clear? Clear? Let's see what are these quickly one by one. Deflation. What is deflation? Process of removing, lifting or blowing away of the loose particles of sand and dust by wind. Supposing there are some rock or some substance that are present, wind basically removes them. So that means process of removing, lifting and blowing away the loose particles of sand and dust that is done by wind is known as deflation. Abrasion or sandblasting. Abrasion or sandblasting means wind-driven sand particles strike against the rock surface, wearing them down. Let us say wind is moving. Now wind has certain, let us say, sand particles. Those sand particles along with the wind will hit some other rock. Those will help in again what? Eroding that rock surface on which it is hitting. That is known as abrasion or sandblasting. Again remember, wind will pick up certain particles while it is moving. Those particles along with wind will hit certain body, let us say a rock. Because the moving of the wind along with the particles, those particles hitting the rock surface will further erode that particular rock. That is known as sandblasting or erosion. Attrition. Attrition is a process by which rock fragments and particles carried by wind collide with each other. Now, do you realize that wind is flowing? Now, within the winds, there are a lot of sand particles that are moving, right? Because it is carrying. Now, those particles are colliding with each other. They will further collide with each other and they will break into smaller particles or smoother particles. That is known as attrition. So, please understand, deflation is being lifting, removing and carrying away of the particles by the wind. Abrasion or sandblasting. Sandblasting means sometimes when you have a sandpaper which is you rub against the wall. Similarly, wind carrying the particles hit a surface where the particles aid in the erosion of this rock surface. It is known as abrasion or sandblasting. Attrition is whatever the particles that are present in the wind itself which is being carried, they hit each other and they further smoothen and become smaller particles. That is known as attrition. Clear? Deflation, abrasion, attrition. Clear? Okay. Though rain is scarce in desert, but it comes under the torrential short period of time. Thus, weathered debris in desert is moved not only by wind, but also by rain and sheet. We see certain situations where rain can also happen during the time in the desert. Then obviously rain can also contribute in certain landforms, which we will see. See, quickly first of all, erosional work of wind and landform. See here. Supposingly this is hard rock. This yellow part represents hard rock. This region is soft rock. Now tell me one thing, it is easier to erode a soft rock or a hard rock? Obviously it is easier to erode a soft rock. Now deflation hollows, what is it? When the wind is moving, it is going to strike this surface, it is going to erode it, but you realize that the hard rock is more resistant, it is difficult to erode. So this will erode the softer rock more. So this will further erode and move like this, and slowly you realize it is going to form this shape. So depressions formed in the desert due to the removal of sand by deflation is known as deflation hollows. Clear? Deflation hollows. So this is what is a deflation hollow. Clear to everybody? Clear? Deflation hollows. Depression that are formed in the desert due to removal by the sand by deflation is known as deflation hollows. Okay. Next comes mushroom rock. Now you know that why it is called a mushroom rock? Because it is in like a shape of a mushroom. Now please understand why it is formed in a shape of a mushroom. There's a reason behind it. Generally this region, then let us say initially it was like this. Right? And this part was hard rock and these parts were soft rock. Slowly when erosion started happening, you know that the wind will be coming here. It is going to sandblast this. You know that sandblasting, I told you, sandblasting or abrasion means that the river which is carrying the particles with it, it is going to hit a rock surface. Over there it is going to erode. The one which is softer rock is going to be eroded more, and the one which is harder is going to be eroded less. So slowly which is hard rock is eroded less, when the softer one is eroded more. So what will happen? This harder rock is broader, and the softer one have basically eroded more. So it is like a mushroom that is formed. This is known as a mushroom rock. Now mushroom rock is a very common name. There are technical names also added to this. What are those names? Pedestal rock, and it is Filsfen. Filsfen is you do not have to remember, but again you should know. Who knows? UPSC can ask you that Filsfen is associated with which regional feature of which? Wind, glacier and all. So that is why you should know. Clear? Clear? Now see, Inselberg, residual hills and mounds, relatively resistant rocks in an arid region. Now what happens? In an arid region, supposingly erosional activities are going on. But there are certain rocks which are of a harder, let us say more resistant nature. They are not eroded like the other parts. So what you see after a long time, if the erosion has taken place, the ones which are more resistant are appearing like these mounds over here. These are resistant rocks. Other regions were less resistant. So they appear like small residual hills or mounds which are more resistant to erosion. That is why these are known as Inselberg. What? Inselberg. This can be asked in your paper. Inselberg is associated with which among the following? Wind erosion, glacial erosion, and all these things, right? Okay, let's move ahead. Demoiselles. Demoiselles basically represent soft rock on top of which hard rock is present. If you go to the regions of Australia, very often you will realize that these types of structures are formed. So you see that represent a rock pillar having relatively resistant rock at the top and soft rocks. These are soft rocks. On top of it, hard rocks are present. Clear? These are known as demoiselles. Next comes Zeugin. What is Zeugin? Now please understand, these are also known as ink pot type features, where you realize that due to the differential erosion of the hard and the soft rock, these cap-like structures like this is formed. So these are known as Zeugin. What? Zeugin. Yadangs. Now please tell me one thing. This is hard rock. This is soft rock. This is soft. This is hard. So if the wind erosion is happening, there's a possibility that this part will be eroded more. So you realize that this will be eroded and there's a depression of a large stretches formed. This is known as Yadang, where deeply undercut laid by alternative bands of hard and soft rock. So you will realize that this region is eroded and this hard rock is elevated. So these are known as what? Yadangs. Pediments, erosional plains formed at the base of the surrounding mountain areas. If you see, there is a mountain area, and you will realize sediments that are lying down close to the mountain area, that those are known as pediments, right? Then please understand there is a concept of palayas, flat bottomed low lying desert basin that temporarily holds water after rainfall but usually remains dry in most of the time. If you see in this region, Palaya basically a region sometimes when there is rainfall, this region has water that is deposited here. But other times you realize this is relatively dry. So that is known as Palaya. Bajada is basically a transitional area between the pediments and the Palayas. Bajada, this question can be asked. Bajadas and Palayas are associated with which of the following? Over here, the role of wind as well as water or rainfall in the desert region is important. That is why water is being deposited, right? Okay. Depositional work of wind and land and their landforms. What is the depositional work? Are the 7 points which I have mentioned in the erosional features of wind, are they clear? Palayas, pediments, yadangs, Zeugin, demoiselles, Inselberg, mushroom rocks, and deflation hollows. Clear? Let's move ahead. Sand dunes are the first. Now, sand dunes are of various kinds. Let us see. Heap and mounds of sand. Barkens. Barkens are basically crescent shaped dunes. What happens is, it is in this direction of wind is this shape, it is in crescent shape like this. Where the wind is flowing over here, it is in this shape. This is elevated and this is the direction of the wind. This is known as Barken. Parabolic dune, it is a reversal of Barkens where in the direction of wind, this is the shape and this is the part which is elevated here. Seef. Seef is basically a Barken only where one arm is basically lacking or one arm is not present. If you realize here, this is exactly same as this. The only difference is that it does not have the second arm. This is known as a seef. As a seef. Longitudinal dunes, you realize that the wind is flowing, large dune structures are formed in parallel to what? In the direction of the wind. Now these appear long and these are very lengthy. Now for this to happen, the constancy of the wind direction should be the same. If it is in the same direction or long time, only then this can happen. If the wind keeps on changing the direction, then this will not happen. Transverse dunes. Transverse dunes are again, these are again formed perpendicular to the direction of the wind. Wind is flowing in this direction. These dunes are formed in this way. This is the elevated part. These are transverse dunes. Loess, second, other than the sand dunes, you have the loess, represents thick deposits of unstratified, well sorted, fine grained sediments. Clear? Okay. Bache, because again 10 minutes are left, I will have to stop here. Okay, I will have to stop here. Because again, what will happen otherwise, there will be a disruption. It will end before I could complete. I am giving you the PDF. I will not remove the PDF. You will be getting this PDF. In the next session, we will be completing, because this is the last part. Then we have climatology and oceanography. Those are not long. I cannot move ahead because of this, because there is restriction of 12 hours. In the next class, we will be completing this along with Indian geography. Clear? See, I can go ahead till further 2-3 hours, but there is certain policies that we have at PW. We can simply not just move ahead with new links. It is not possible, right? Whatever has been done till now, revise it clearly. If you do this, you will be in a state, because 98% of the geomorphology has already been covered. This is the last part, landforms part. Again, you see, if you see here, I'm giving you this glaciers. This was a question that came in the examination. Fords, if you were to see this here, the question had come, I had already done in the class, right? I had already done in the class. This was a question which was asked. So all the depositional features and all I have mentioned, I will be doing this in the next class along with the Indian geography, right? So last was the volcanic, and these are certain. Had there been one more hour, I would have completed this. See, I have given my best that I could have done, right? I started at 9 a.m. It is now 10 minutes to 9. I would love to finish this, because again 20-30 slides are there, but I know very well that it was not possible to complete because I cannot compromise with the quality. So the important thing is, I will be doing it. The PDF will be available to you. You can just go through it. I'll be revising it, and in the next class we will do this, and along with it, obviously the Indian geography. Please make sure that you do it. I realized something good that happened in this class is that in the initial phase, when I started discussing the MCQs or multiple choice question, many of them were not getting the answers correct, right? Many of them were not getting the answers correct. But slowly I realized that that you started getting the answers correct because you were focusing and you were listening to the lecture very carefully. This is what I want. When you revise, initially you will have wrong answers. Initially you will get lower marks. Initially you will be frustrated. Initially you will be thinking that whether I will qualify this examination or not. The reality is, if you keep on doing it, keep on preparing, keep on revising, keep on solving, a time will come that your answers start becoming, or you will get correct answers. You will get a higher score. You will get a better marks. But that comes with time, right? That comes with time. So my request would be that keep on practicing. Whether you are getting lower marks does not matter. With the time it will increase. Whether you are getting answers wrong, doesn't matter, with time it will improve. When you will say how, when it will improve, please understand that depends upon how much you are revising and how well focused you are. Most of you will be making very silly mistakes, very silly mistakes. I want you to just work on them. And if you work on them, I am guaranteeing you, you will be at some good place, right? So lots of love from my side. We'll be meeting you again. I would have loved to continue another 1 hour, but again, certain restrictions and uh, uh, again, this 20-30 slides are mentioned. I'm feeling really bad right now that 20 slides are mentioned. I cannot proceed because YouTube does not allow it to do it. Okay, doesn't matter. Next class, I will do it. I'm always there for you. We can take all those marathons are there, so don't worry. So God bless you. Lots of love from my side. We'll be meeting you tomorrow. Not tomorrow, on the 19th. So please remember, do catch me live on the YouTube channel on the 19th of this month, where the other part will be done. And obviously later on we'll be having the places in news, where and then Indian mapping and then world mapping. So complete geography done on YouTube for you, so that you are there well prepared. And for all those who have seen live, many congratulations to you also. Please remember, it is not me, but you people who are sitting there and listening and watching. That is a big thing. I know most of you are going to see the recorded format because many of you have some classes and all, so it is difficult. So please do see in the recorded format those who have missed, and we are always there for you. God bless, take care, and lots of love from my side. And at the last, as you always say, Jai Hind.